And we are back for day 2. Carolina, are you with us?
I am. I just need you to enable my camera.
Oh, right. Give me a second for that. In the meantime, welcome everybody, and feel free to, here you go. Welcome, Carolina.
Welcome, Luca. Good morning,
Fantastic.
everyone.
Good morning, everybody. Feel free to tell us where you're joining from. With you again, Luca, moderator of the Platform Engineering community, joined by fantastic co-host Carolina.
Hi, everyone. So excited to be here again for the second year and for the second day this year.
Awesome. Okay, look, for those of you who were here with us yesterday, this is very similar to yesterday. We have a couple of highlights from day 1 that we're going to walk through, but except for that is quite similar. So if you're here already, we're going to repeat a lot of things, just FYI. For those of you who were not with us at the kickoff yesterday, here's what we're going to cover today really quickly, probably like 15 minutes max, and then off you go. You can go watch the talks at your own pace or follow the stream that we're going to queue right after this. So we'll quickly go over the schedule, watch parties, which is a new entry this year, learning paths to help you navigate through all the amazing talks that we put together. We'll walk through how you can make the most of the Slack and the Q&A with the speakers. We will talk about our code of conduct for PlatformCon, and then finally, what are the main highlights from a content perspective for today, and then again, the fan favorite, our raffle. All right, so let's get right into it. Again, before we get started on PlatformCon, I want to acknowledge the amazing community, the platform engineering community that's come together over the last couple of years. It's really crazy to see when you just look at this journey, just how it accelerates as well. Just if you look at the sheer amount of things that happened in 2022, right? So in 2020, I believe, is end of 2020 is when we started the meetup groups in Europe that quickly grew. Then we launched the Slack end of 2021. And then from there, it really started taking off. We launched platformengineering.org, where you can find all the upcoming events, the tooling section, jobs. I was just looking at the new mockups for platformengineering.org yesterday. We're going to release a new site probably in the next 2 or 3 weeks. It's really exciting. It looks really, really cool. And then obviously PlatformCon 22 was the big highlight from a community perspective last year, and something that we're super excited again for this year. You can just look at how much it grew, right? It went from 7,000 signups to 20,000 signups this year. And that really speaks volumes to just like the sheer amount of interest that is gathering around platform engineering just in the last 12 months. And so with no further ado, let's jump into PlatformCon.
Right. So let's quickly recap day 1, because I am pretty sure that the ones that joined really found the talks insightful and chats in the Slack channel also really fruitful. So you can see a couple of moments from yesterday. We had an amazing watch party in London. So here you can see our beloved Nikki Watt and Daniel Bryant discussing platform engineering trends. Also some really nice posts from social community. Here are some of the very nice quotes from our Slack channel. So really hope to see you all there today, and let's chat and discuss the talks again today.
Awesome. And yeah, just I want to reiterate just a quick look at kind of like the numbers from 22 to 23, because it's just crazy to see, like, especially if you look at the first row here, the YouTube subscribers, like we went into PlatformCon 22 with, basically non-existing YouTube channel. And now I think we're close to hit 13,000 already since yesterday. And, the Slack has grown. It's probably going to cross, 15, 16,000 by the end of this event. And so this is really important because, again, PlatformCon, I think really what makes it special is it builds on top of the existing destinations that the community gathers around, right? So we already have a lot of YouTube subscribers. There's already a lot of people in the Slack, and PlatformCon really is a boost that builds on top of that, right? And that's really what makes PlatformCon special. It's really what makes the engagement in the Slack so fun. So again, if you haven't joined the Slack yet, please do. That is really where all the action takes place, especially during PlatformCon, but also throughout the entire year. And then final thing here that I want to mention, the talk submissions is, again, to me, that was really crazy to see back in, I think, like February or March, when we opened the CFP, just like the flooding of talk submissions that came through, right? We had a 5x growth on talk submissions, which means two things. Again, there's an amazing increase in interest in platform engineering, and also really in the in the desire of practitioners to share their stories with other practitioners. And B, also it means the quality of the talks got even better this year, right? If you look at the rate of acceptance from last year towards this year, we've been very strict, very picky, and so that means great content for all of you. Watch parties. Yes.
So, as I mentioned you from the highlights from yesterday, we had actually 3 watch parties in Austin, San Francisco, and London yesterday. But where this watch party idea came from is that so we ran the post-conference survey after PlatformCon 22 last year, and we noticed how much you missed in-person meetups. So obviously we heard you last year, and that's why this year, together with our amazing sponsors, Syntasso, Atlassian, OpenCredo, and Adevinta, host 4 in-person watch parties. And I know that today we're still waiting for the Barcelona watch party to start. So, I mean, regards in advance for everyone who's going to join, and I hope you're going to have an amazing day together.
Nice. Slow start in Barcelona this morning. Okay. So just a quick look at the tracks. We have 5 tracks this year instead of 4. The 3 that you recognize from last year, if you attended PlatformCon 22, are story, stack, and culture. This is obviously where we talk about, the war stories of the practitioners. We zoom in on different technologies and different parts of the platform stack. And then obviously not just the tech side of things is important, but also the culture components, stakeholder alignment, getting buy-in. And that's what we discussed in the culture bit. And then we have 2 new tracks that I'm really excited about. Impact, that's about, the ROI of internal developer platforms, is about the total cost of ownership. And really it's a track more aimed at the kind of C-level executive persona. However, even if you're not a manager and, or you're a manager, but you're actually on the kind of like practitioner IDP builder side of things, this can still be really helpful for you to understand what is the lingo that you need to speak to get executive buy-in for your platform engineering initiative. So it's really, I think it's a really interesting track. Can work both for the kind of like C-level and managers out there, as well as the practitioners. And then my personal favorite, which is blueprints. This is, again, something that a lot of people in the industry, in the community have asked for. It's like, hey, it's great. I'm bought in, platform engineering, hot and trendy, but where do I go next? How do I get started on my platform journey? How do I get going building my IDP? And this is really what Blueprints is about providing people with clear reference architectures, clear design principles, and starting points to get going. And this is something that we're really focused on this year, and something that I'm personally really excited about. So hope you enjoy all of these. Okay, as for the schedule, same as yesterday. We are doing the kickoff right now. We're going to be done in about 10 minutes, and then you have a few choices. You can either follow the stream that we're going to queue after this. It's going to be a stream of selected talks for day 2 by our content team, or you can go and watch talks at your own pace on the Platform Engineering YouTube channel or on the PlatformCon website, whatever you prefer. After this, we're also at 5 p.m. Central European time. We're also gonna do another kickoff for our Americas colleagues, but you don't have to join it. This is it's just going to be a repeat of this. If you want to hear us repeat the same things for the 4th time, though, please join us again. Otherwise, this stream is going to keep going until 7 p.m. And at 7 p.m., we're going to do the Q&A with the speakers. I want to stress that if you have questions and you want to start a thread before 7 p.m., you're very welcome to do so. Not everybody can join us at that time, but we've decided to crunch all the sort of like Q&A action in that specific slot so that, you know, that we can cover the sort of like the majority of our attendee base. But again, if you can't make that time, or you really need to ask something in the next, 7 hours, please go ahead. We're also going to have speakers. Speakers are hanging out in the Slack anyways, and we're also going to have speakers probably dropping some threads anyways, because again, not everybody can make the 2-hour slot. So that's really a general guideline, but you can jump in at any time and get really into the action, the conversations. There's a lot going on in the Slack. It's really the fun part of it. The other way that you can consume content is the learning path. So obviously we know that 169 talks can be quite overwhelming to navigate through. And so we put these 3 together. There's obviously a fundamentals path. This is where we put together content for beginners and people that are getting started on your platform journey. Advanced for those of you who have more years under the belt, building platforms and want to dive into specific, tooling questions or ROI questions and stuff like that. And then management, again, is about the sort of like cultural components, stakeholder alignment, and so on and so forth. You can find all of this in our YouTube channel, where you can also find, by the way, different playlists for the different tracks for the different days. So you really have broad choice, both on the Platform Engineering YouTube channel or on the platformcon.com/talks website, where again, you'll be able to filter today by everything, actually day 1, day 2, tracks, speakers, everything. So really, you can choose your own adventure here.
Yeah, and Luca mentioned most of the important stuff regarding the Q&A session, but let me just highlight once again in the most important parts. So don't forget to join the Platform Engineering Slack channel, where you can ask any questions you want to our conference speakers. And yes, officially we have the slot from 7 to 9 Central European time, but feel free to jump in throughout the day, ask questions. Just don't forget to tag the speakers and ask questions, and then they will get back to you as soon as possible, probably throughout the scheduled time slot for the Q&A. Yeah, so don't worry. All the questions will be checked, and hope you're gonna get what you're looking for. Sorry. Okay, and this is kind of a warm up before the day starts. So here you can see a few great speakers and their talks for today, including Marco Maroli, Principal Delivery Lead at McKinsey, revealing successfully implemented reference architectures for developer platforms and leading cloud providers. So in his talk, he focuses on the Google Cloud reference architecture. Then we have Chuba Obi, SRE from the Home Depot, who walks through the journey around how they increase the security of a multi-tenant Terraform workspace with reducing the toil. Then our well-known Honeycombs charity majors highlights the importance of platform engineering and talks about the glorious future for developers and ops, where every engineer writes code and owns what they write with reduced cognitive load. Then we have our co-author, Team Topologies, Manuel Pais, who explores how every team and every division in an organization can adopt a platform mindset in which they treat what they offer to other teams as an internal product. And last but definitely not the least is Humanitech's senior tech evangelist, Fernando Villalba, and his talk about love. Well, he's actually highlighting the importance of understanding UX principles to ensure that the internal developer platform wouldn't become a burden. Yeah, and before wrapping this kickoff, we want to touch on some really important points. One of them is code of conduct, so please read it carefully, but TLDR, be kind and respectful to one another. And if you have any questions or concerns, please reach out to our community manager, Julia, Luca, or me, or simply write us an email to support@platformcon.com. Just note that we take all reports seriously and we will respond with as much courtesy, confidentiality, and urgency as possible. Same thing with technical issues. Should you have any, reach out to the same email or just simply Slack us.
Awesome. And just to wrap up with the favorite part, we wanted to repeat the raffle this year. And in fact, we already did one yesterday. So here's day 2 raffle. Again, really simple to sign up for it. You just need to go and register for Platform Weekly. This is our, again, community newsletter, one of the really favorites in the communities where we talk every week about trends, hot topics, as well as long-form deep dives on platform engineering topics, cloud native, DevOps. So go sign up for that, and then you need to go and find a hidden rocket emoji in the video descriptions of some of your favorite talks there on the platform engineering YouTube channel. So once you have those 2 things, really easy, you just send us a screenshot of the rocket that you found. We're going to double check with your email that you signed up for Platform Weekly, and off you go. You are part of the raffle, and we're going to announce the 10 lucky winners at the Q&A in the Slack channel at 7 p.m. So, and again, if you can't make 7 p.m., don't worry. We'll make sure that if you're a winner, you'll get your merch anyways. So happy hunting and good luck with that. And one final thank you to our sponsors. Again, for the ones of you that were with us in 2022, you'll remember this section was considerably smaller. We've had, and this again speaks really to the crazy interest in platform engineering over the last 12 months. And we have some of the really major cloud native players here, right? Like Atlassian, Docker, Google Cloud, and many more. So thank you to all our sponsors. The PlatformCon 23 wouldn't have been possible at the scale that we're doing it this year without all of you and without your support. So thank you again. And also thank you to our media partners, Women in DevOps, TechStrong, SDT Times. This is really, it's really great to partner with all of you.
And lastly, share the platform love on your social media by using hashtag PlatformCon 2023. Share photos, experiences, and also follow us on our LinkedIn page for more great content. And that's it. Let's round off. And Luca, shall we start an exciting day 2 already?
We shall. So now watch me as I do some magic here.
Yeah. All right. So I'm saying enjoy your day and goodbye.
Fantastic. Yeah. Have fun, everybody. Enjoy the talks and see you in the Slack. Bye-bye.
I'm going to talk about the future of ops jobs. My name is Charity Majors. I'm the co-founder and CTO of Honeycomb.io, co-author of Database Reliability Engineering and Observability Engineering. The observability book is fairly newly out, and if you want a free copy, honestly, we post the link on the Honeycomb Twitter feed all the time, so download it. What you might want to know about me is that I identify as an operations engineer. I have been doing infrastructure, ops, SRE, my entire career. I used to say I've been on call since I was 17. I care a lot about operating software effectively and efficiently. I feel like that is what's interesting about software. That is what's hard. Production is where the hard problems sit. It's where the users sit. It's where things get real. Honestly, you can round the cost of building software down to zero compared to the cost of running and maintaining it over the life cycle of your code. If you're writing software and it isn't in production yet, it may as well not even exist. So I'm pretty adamant on that point. How many of you have seen this pop up in your Twitter feed? Well, I can't see anyone waving hands, but yeah, me too. Which is basically why I was baited into writing this talk. This kind of bullshit is what gives marketing a bad name. Software doesn't die. Methodologies don't die. Teams having empathy for each other doesn't die. Software to prove that software doesn't die, here is a very long list of crap that is not dead, all of which is extremely older than DevOps. Saying that DevOps is dead is just kind of stupid. It's clickbait marketing at its worst, and I find it incredibly annoying. But the reason it got so much attention is because there is a little tiny kernel of reality underneath, which is that the need for DevOps is not eternal. And what I mean by that is, consider the long arc of software careers from, 1980s or whatever until the current day. Well, we started out with engineers who wrote their code and ran it in production. And this involved, telnetting into servers and editing the code in Vim live, right? Hitting save and, if you were lucky, maybe you committed it somewhere. But it was, you didn't have ops and devs. You just had people who dealt with software. Stuff got complicated, and we kind of spun off into these teams, these famous silos, right, where the devs write the code, they lob it over the famous wall, ops runs the code. This doesn't work very well for anyone. Friction ensues. People get mad. Some of us go on to write comics about the bastard operator from hell, right? Not good. So 2007, 2006, 7, 8-ish, DevOps emerges where they're like, hey, all right, the lamb and the lion must lay down. They must be friends. Hug ops, we have empathy for each other. But now I feel like for the past, 5 or so years, I think that we've been trying to figure out how to reunify the streams, how to bring back together the writing of the software and the running of the code to help engineers own their own code in production. And I think increasingly, we're putting software engineers on call for their code. We're spinning down ops teams. And these days, I think, every engineer, this is the expectation on a healthy team, right? Every engineer writes code and every engineer runs the code that they write. They're responsible for their software in production. This is a good thing. I think that, what is it that we all want out of our work? According to Dan Pink, it's autonomy, mastery, and meaning. If you're writing your software up in, some ivory tower, it doesn't really have much meaning. It doesn't have any meaning until your users are using it, right? Ops production is where code meets reality. And so why is this happening now? Well, I think it's because the shape of the complexity that we're dealing with is changing. It used to be there was a lot of surface area, but systems are becoming, hold that thought. I'll get to it in a second. Systems are becoming rapidly more complex, like exponentially more complex. And because of that, they can only really be operated well by people who write them. And the flip side is also true. You really can't do a good job of writing them unless you're regularly exposed to the feedback loops of operating them, the way that they fail, the error cases, the way they behave. If you're an engineer who only looks at your system when it goes down or when there are problems, you're not a good engineer because you don't know what good feels like. In order to know what bad feels like, you need to train your gut on what good feels like. Systems, it used to be that ops could kind of like treat them like black boxes, set up monitoring checks and stuff. But increasingly, you really have to introspect the systems themselves. You have to be comfortable changing code. You have to be comfortable, operating it. It really goes back both ways. But does this mean that operational skills are obsolete and that people who are expert in running systems can retire now? I wish. Actually, operational expertise is both more difficult than ever and it's more important than ever. What is true is that the landscape is shifting. Your skills are not obsolete, but the job titles are different and the expectations are different, mostly because the level of abstraction where engineers get to operate is getting much higher. Like my ops team works for AWS. I started out in ops teams that were racking and stacking servers and, we had screwdrivers and when the RAM failed, we'd take it out and we'd fix them, when I got paged in the middle of the night that the database primary was down, I would call a taxi, get in the car, go down to the colo, plug that thing in or hook up the crash card or whatever. But we're all moving up the stack in one way or another. We've moved way up the stack from racking and stacking servers, which is great. But two really big trends are kind of converging here. The one that I just mentioned, where everybody writes code and runs the code they write, and the second one, where the level of abstraction is growing and software is becoming much more reliable. It goes against my grain to even say those words, but it is true. We can take for granted, when was the last time you had to debug, a kernel stack trace in your code? Probably not very often. And that used to be a very commonplace thing. Right now, if you're using, a stable, branch, a stable of Ubuntu or of Debian or whatever, you can pretty much assume that if you're running normal workloads, and you don't have millions of nodes, you can take the operating system for granted. You can take the web server for granted. This is phenomenal. We can take so much software for granted. We can all move up the stack. This makes us incredibly productive. Back in the days when we had to go deep on back-end stuff, you couldn't spin up an app with just a couple people, right? You had to hire armies of engineers. Instagram was famously built with 8 people, right? Sold to Facebook for $1 billion. 8 people, not even 8 engineers. It was 8 human beings, although they were mostly engineers. Anyway, if you love operational work, first of all, I salute you. We have a similar pathology. But secondly, you increasingly are coming to a fork in the road, and your career choices will take one of 2 paths. If you love infrastructure, then you should go use your skills to solve a category problem for the world, whether that's, paging alerts at PagerDuty or, observability companies or whatever. If you deeply love working on infrastructure software, then you should probably go work on a PaaS or infrastructure as a service or just a really good tool that can kind of sweep the landscape. Because again, the world doesn't need a cajillion engineers who know how to configure DNS and bind. We're going to have a couple really good name server companies, and the rest of us just get to pay them a small amount of money for them to do what they do. All right. So if you love infrastructure, go build infrastructure, solve a category. But if you really love operating code, this is where I think it gets interesting, because the skills that you have developed for running software and building infrastructure can be used mostly to help other companies run as little infrastructure as possible. To focus as many of their core engineering cycles on their core business problems as possible. Software engineering cycles are the scarcest resource in every universe. It's harder to come by and scarcer than money, even now that we're not in a zero interest rate phenomenon. If you love operating code, then basically you kind of have two options. You can either work as an SRE or DevOps or someone who specializes in, it's almost like you're a consultant, right? You're helping software engineers. Software engineers are owning their code in production and you're helping them. You're helping them do it well. You're building like reusable components, whatever. And secondly, platform engineering, I think, has kind of emerged from this whole reshuffling, realignment. And I want to talk about that super briefly. Companies are shutting down or looking for ways to shut down their ops teams, traditional ops teams that don't write code, left and right, as they should, and outsourcing infrastructure to companies that can do it better than they could if they tried to do it all themselves. But that means that we all now rely on a very complicated web of other providers, services, tools, be it APIs and SDKs. Just look at how many companies go offline whenever US East goes down. And this has led to the development of these platform teams where, software skills and ops skills, I think, are equally important for a good platform team. But does this mean that platform teams are ops teams? No, it does not. In fact, I have a handy dandy little test for you to be able to see if your platform engineering team is really a platform team or not. This is the question. Is the team responsible for SLOs, service uptime, reliable customer experience? If no, congratulations, you have a platform team. If yes, you do not have a platform team. You have some kind of ops or service or SRE team. Because the real core difference here is that platform teams build for developer productivity. Platform teams succeed when developers could easily choose good defaults, self-serve their infra, and own their own code in production. Platform teams are not responsible for building lots of software. They can't be. They'll get bogged down on it. Platforms are the ultimate glue team. So, which metrics does your platform team care about? SLOs, errors, service availability, etc., or time to spin up a new service, or database, or run a migration, or do some other developer workflow. That's really what separates the teams. And if your platform team spends a lot of time writing software, honestly, something is wrong. They shouldn't have a lot of code to own. They're not a product team. They're a glue team. Platform teams kind of uniquely sit between these two tectonic plates: infrastructure code and business code, each moving at very different speeds. Infra code moves at the speed of Debian upgrades and software releases. Business code changes several times a day. Lots of small diffs, shipped frequently. This is part of letting engineers abstract infrastructure away. Run less software. A huge part of any platform team's remit is what I think of as vendor engineering. It's choosing and evaluating vendors, writing libraries, helpers, providing a consistent user interface to engineers so they get lots of goodies for free. Platform is an incredibly high leverage team. And one of the best ways you can leverage your expertise, of course, is to help companies not run infrastructure. It's harder than you think. Cost is an essential part of architecture. I think this is something we kind of lost sight of over the past few years. One of the best ways that you can get ahead of the curve and be a super valuable senior contributor is really just to learn to think and talk about the value of your work and translate it into the universal language of business goals and dollars. And for infrastructure engineers, we really, really, really have to learn to be a product team, to work with product folks and talk with users, do user research, even work with designers. But don't lose heart. We're still ops deep down. the hardest part of software is operating it. Always has been, always will be. Got another meme here. Wait, platform engineering is just ops? Boom. No. Wrong. In conclusion, we are still ops engineers at heart, which means that what we really bring to teams is the reassurance that computers are terrible, everything fails. It's not a question of if, it's a question of when. Everything dies. So have fun.
My name is Marco Marulli, and I'm a principal lead at McKinsey. And today I'm going to talk about reference architectures for developer platforms. I'm also going to give a brief demo, and that's going to be on Google Cloud. I'll start by showing you this picture that tries to explain what is the situation, the world that the developer lives in today. It's like a child in a candy shop. They have just too many options to choose from. Too many platforms, too many libraries, too many programming languages. And if we are in an enterprise context, the lack of guidance, the lack of guardrails, the lack of standardization just leads to a poor developer experience, especially if this is combined also with a lot of attrition, a lot of friction, a lot of handovers between different teams. As an example, if I'm an application developer, I have my code ready to be deployed, but I need to rely on an operations team or an infrastructure team to deploy the underlying infrastructure required by my application, and my productivity just gets impacted. My request is then going to be added to a number of other requests, a number of requests coming from other application teams. And so what this does in turn is putting a pressure on the operation teams to deploy a number of infrastructure resources, so a number of resources to the cloud. Most of the times, from what we've seen on the ground, enterprises are still not do not still have in place fully automated mechanisms to deploy these resources, and so there is a lot of manual effort that needs to be completed as well, to be done as well. There is also a constant ask, an increased ask on developers to keep up to speed with technologies and to be really like a Mr. Know-all. What all of this leads is to have to have application and platform stacks that over time just keep increasing in complexity. How do we reduce this complexity? It's just by introducing, one example is by introducing developer platforms. A developer platform allows an enterprise to standardize the tech stack and tools across the organization, while at the same time establishing industry practices for developing engineering behaviors. A developer is allowed, empowered to deploy an application by himself because the underlying infrastructure is deployed in an automated way. And what this does in turn is a couple of things. Reduces the number of interactions between teams and reduces the ask on the developer to really know everything and anything. Here on this slide, there is a reference architecture that we use to deploy an MVP developer platform. I'm going to focus on two components that allow for separation of concern. One is the workload specification, and the other one is the platform orchestrator. Starting from the top, both application developers and infrastructure engineers, infrastructure developers, they will use a portal and an IDE to write their code, push it to a user version control system like Git. There is one thing that the application developer would need to do on a developer platform differently than they're used to do today. It's writing a workload specification file. What this file has not only the details of the container image that has the application that needs to be run, but also the list of external dependencies that are required by the application. As an example, a MySQL database. Once everything is merged into a master branch, a CI pipeline is kicked, is triggered, and the container images are built and pushed to a Google Artifacts registry. Once the images are ready, then a platform orchestrator is notified. In this case, we're using Humanitech, but there is a number of different platform orchestrators that can be used. What the platform orchestrator does is takes the input workload specification file that has really the recipe, all the ingredients that the application needs to in order to run. Compares like the list of deployed resources, or the list of resources that have already been deployed in the cloud platform, and deploys the delta, the missing resources. So at the end, what you have is a result that all your compute data and networking resources are deployed. There is integration also with monitoring and logging through standard Google Cloud Monitoring. There is a possibility to manage secrets using Vault on GCP. So before we go into the demo, let's talk a little bit about the application that will be deployed, that will be deployed during the demo. It's a very simple application that, and when we do the deployment, the underlying infrastructure will also be deployed. This is a slide that shows that infrastructure, how that infrastructure looks like, and we have a VPC that has a subnet in which there is a private Google Kubernetes Engine cluster that will be deployed. The cluster allows traffic in from the external world through the use of a load balancer, and the application uses a MySQL database that will be deployed on a private Cloud SQL instance. A private Cloud SQL instance that will be hosted on a separate Google service producer project, to which our project is going to have access to a VPC network peering. So as you can see, it's not extremely complicated, but there is some complexity and requires some knowledge, especially from a networking perspective. All of this is going to be deployed in an automated way, and without the need for the application developer to know anything about this. So I'll switch over before going into the demo. I'll talk about a little bit more about the two components that allow for separation of concerns, like the score, like the workload specification file and the platform orchestrator. So if we start with the workload specification tool, here is the repo that contains the application that we are about to deploy. It's a simple application, 3-tier application. It has a front-end service, and it has two APIs: the user API and the money API, and it also has a MySQL database. If we go, for example, and look at how the money API has been structured, we have it's an Express backend that it's a Node.js application. You will see here that the typical files, the usual files that you would expect to find in a repo that has such application. Apart from that, the only difference is that you also have the workload specification file. This is core.yaml that has not just information about the service and the container images, the images that need to be executed. Right here we have the money API, the money API image, so really the application code. We also have a reference to a Cloud SQL proxy container that allows for connection to the private MySQL database. But also here at the bottom we have listed the dependencies, that external dependencies that are required by the application for the application to run. Right? In this case, the application needs a MySQL database, and this is pretty much the extent of what the application developer needs to put in the file. Just really a reference to the type of database that needs to be used. So let's go for a second to the platform orchestrator. So here, if we go to the resource management section, you will see that there is a list of resources. Here you have the list of resources that the application that will be deployed to a cloud platform, regardless of what a cloud platform is. It could be it's Google Cloud in my example, but could be AWS, could be Azure. list of resources that will be deployed as long as there is an application that requires them. And here is the list of applications. I just created a shell for the back demo, for the back application that I'm about to deploy. And if we look here at the back demo, there is really nothing at the moment. It also it eventually will list the workloads and the shared resources the application is going to use. And the expectation here is that there will be 3 workloads after the pipeline, the CI/CD pipelines are triggered, and the workloads will be one for the front end service, and then one workload for each of the APIs that the application uses. All right, so I'm going to trigger the pipeline in a second. The deployment is going to take about 20-30 minutes to execute. So I'll pause the recording and come back as soon as the deployment ends. All right, so the pipeline just completed its execution. You can see like the front end, all the three different components were executed, and the score was the score workload. The specification file was sent to the platform orchestration to the platform orchestrator. And now, if I go into the platform orchestrator, you see that the 3 workloads have been deployed. If I click on each of the workloads, I get to see some details about what was deployed, and especially if I go now to the front end service, I get also to know what is the domain that's been automatically created for me. So I don't need to go and log into anything. I just click here to copy the domain address that's been created for the application. I just hit enter, and here is my application, right? If I go to the Cloud Console in Google Cloud, I can see that the database was deployed for me, was created, and as well as different the other required components. So it's taking just a minute, I guess, to load, but you can see here, for example, if we go to EKE, I see my Kubernetes cluster is deployed as well. All right, so this concludes the demo. And so to resume here and to finish, we probably have solved the problems that we discussed about the beginning of the presentation, right? The time for me to deploy the application was about 20-30 minutes, and not months or weeks. I didn't have to rely on anyone else to deploy the underlying infrastructure for me. That infrastructure was deployed in an automated way by the platform orchestrator. And so there was no need for me to really know anything about how to deploy that infrastructure, no need to deploy anything about how Kubernetes works, how private clusters, how private Cloud SQL instances need to be deployed in the cloud. So there is an overall reduction in the complexity that in the overall complexity, right? But this is just a tool, right? The platform orchestrator, a developer platform, is just a technology component that just by itself, it's not going to enable these reduction in complexity, this agility, like this speed in delivering. Everything, there is a number of things that, maybe like 3 things that need to happen before the technology can help. The first thing is that foundation needs to get right, and then here we go from putting in place the right cloud strategy to taking the right foundational architecture and application pattern decisions. There is also a need for a shift in mindset, right? There is a need for a strong engineering culture that needs to be embraced by the top leadership and communicated down throughout to the entire organization. And also, like, there is a need for processes and governance to be put in place so that teams, they're not getting get stuck in organizational red tapes, right? So I hope that you enjoyed the presentation. I want to thank my colleagues Mike Gatto and Stefan Schneider for working on this together. And we are all going to be available in the chat room if you have any questions for us. Thanks a lot.
Hi, I'm Manuel Paes, and today I want to talk about beyond engineering, the future of platforms. Specifically, I would like to address some of the challenges that I see in many organizations when we're trying to achieve faster flow of value to customers, but there isn't necessarily the awareness of how internal processes and the way we work actually impacts our ability to deliver to the customer quickly. It's great to be back at PlatformCon. 1 year ago, I spoke about what is platform as a product? What is this approach? What does it mean in terms of principles and practices? And I got a lot of positive feedback of many organizations that are applying these ideas within engineering specifically, and for internal developer platforms and other types of platforms. And it's been really helpful for them to move away from the idea of platform as somewhere where we standardize and we centralize some shared services to something that's really seen as a product with actual customers that we're trying to improve their life. We're trying to provide a great usability for the platform in whatever form it might be, APIs, tools, or actual user interface, right? So it has been proven essentially that this approach of platform as a product is very helpful within engineering. And before I talk about how we might apply some of these ideas outside of engineering, I will do a short State of the Union kind of speech, if you like, about where I see us as a community in engineering 1 year later after last year's talk. If you don't know me, I'm Manuel Paes. I'm one of the co-authors of the book Team Topologies with Matthew Skelton. And as I was saying, I do believe the ways of working outside of engineering directly and indirectly impact our ability to deliver value to customers, have a fast flow of value, right? Meaning that we can take an idea or a customer request or something that the business would like us to experiment and take that all the way to the live environment systems and being used by the customers, right? So if we think about how internal processes might affect this, if you think about, if you have a complicated, training approval process, or you have difficulties with procurement processes to be engaged with third parties that might offer some helpful tools or services that you need to actually be able to deliver faster with quality to your customers, then there isn't a direct impact, at least on our ability to deliver, to achieve this fast flow of value, right? So what I see in many organizations, this sort of divide, this abyss between our approach to fast flow within engineering, or I should say in some organizations, not all, and the way that other parts of the organization that are equally necessary and important, obviously, accounting, legal, HR, even leadership, how they think and how are they aware or not of these ideas of fast flow and blocking others and helping others achieve their goals and outcomes, right? And I believe that's to a large extent because teams tend to optimize for their internal processes over the outcomes for the organization. And what happens is those internal processes, when you look at them in isolation, yes, it's good to optimize locally, but that optimization might not translate to improving the outcomes and improving our capacity to deliver quickly and actually answering the customer needs. I see a lot of friction of often, whether that's some difficult processes we have to follow. We have to keep a lot of steps in mind. How do I request the training, or how do I engage with the third party? What kind of contracts are needed? who needs to approve what and when. I've definitely had experiences, as an outsider, as a provider to organizations where the process, whether that's invoicing or the initial procurement, is really cumbersome and puts on cognitive load for me to remember and understand all the steps necessary, and for the organization itself, especially the teams who are not the specialists in that function, right? Who are not the legal specialists, they are not HR specialists. They just need help to do their work in whatever way, recruiting or third-party help, etc. These sort of frictions probably sound a bit deja vu, maybe, to some of you. And that's because when the DevOps movement started in 2009, effectively, we went through a lot of these frictions within engineering, development teams incentivized to deliver features, while ops teams were incentivized for stability. And so they didn't want a fast pace of change to the systems. We had sort of similar problems within engineering that we've been able to make a lot of progress in the last decade or so. We've been addressing those frictions, and obvious things like platform engineering and platform as a product approaches have been quite helpful in supporting others without blocking them. It's interesting that Patrick Debois, and I checked this with him before the talk, only recently he came up with his own definition of DevOps, where he says, everything you do to overcome the friction between silos is DevOps, and all the rest is plain engineering. And it's not saying that plain engineering is not necessary. Obviously, it really is kind of the engine to support a lot of the good practices and approaches of DevOps. But the ultimate goal for him was, and I agree with him, is to remove friction between silos, have a smoother flow of value to our customers. So maybe we can apply some of the things we learned with DevOps, platform engineering, etc., outside of engineering. Before we continue, though, it's good to make sure we're on the same page about what we mean by platform, right? So I fully agree with Evan Butcher's definition of a digital platform as a foundation of self-service APIs, tools, services, knowledge, and support, which are arranged as a compelling internal product. And embedded in this definition is this idea of platform as a product, right? And I think that is helpful for any kind of platform approach, even if it doesn't include tools, APIs, or actually running services. If we think of a platform as anything that helps other teams accelerate, reduce their cognitive load, then the idea of platform as a product is more broadly applicable, right? So I do believe it's a key pattern for overcoming friction between silos, not only in engineering, but outside engineering as well. And the key point, I would say, is to start by treating others as your customers, right? Yes, they are your peers, they are your colleagues, and there are specific dynamics about that. On one hand, it should be easier to reach out to them versus an end user or customer. And on the other hand, they might have demands that are different from an end customer. But fundamentally, this idea of I'm going to think about others as customers and not just people who have to follow my processes, right? So if I do that, I will look at what I offer rather than what I demand. So it's an interesting change of positioning. And I will be looking at what do my customers need? How do I improve the experience for them of going through my process or some kind of procedure that they need to follow, right? And understand why are they asking this? And how do I make it easier for them to get what they need to deliver value to our end customers? Like I said, I want to do a little detour briefly to do a sort of state of the union of platform as a product 1 year later. And this is inspired by John Willis, by the way, who used to do this state of the union for DevOps in the early days. And essentially, your mileage may vary. Some of these things might seem like science fiction still. Other things you might say, well, we already do this in my organization. It's trivial. But as a community, as a group, it's interesting to think about what have we gotten right and what do we still need to improve. So some of the things that I've seen at least evolve and progress over the last year include a lot more focus on the user experience for the platforms, especially internal developer platforms and so on. In engineering, we now understand that it's not just about providing the service, it's how easy it is to onboard, to consume, to understand why this service is helpful for the teams, right? Effectively, having the right tool for the job and also understanding that different people will do the same job differently, basically, right? Maybe we need different entry points, different approaches, even though what they're trying to do is fundamentally the same. We've made, and I believe there's a wider understanding that the platform really is not just a bucket of shared services, it's really an approach as a product that helps to manage cognitive load at scale, meaning that it helps the teams that are using the platform to have less to worry about, to remove some of the distraction and aspects of the work they do, which is simply very hard to deal with if you have hundreds of tools, frameworks you need to know about just to do, to follow the life cycle of software. That's really difficult. And we have no capacity left to focus on the customers. So the platform helps reduce a lot of those complexities by providing useful abstractions for our customers, our teams. In fact, a couple of years ago, the State of DevOps report from Puppet Labs found that highly evolved firms around DevOps use this combination of what we call streamlined teams or product teams with platform teams as the most effective way to manage cognitive load at scale. Effectively, they saw in the data that organizations taking this approach have a competitive advantage compared to others. I think there's more awareness as well of the need of having good product experience and product management inside platforms, even technical engineering platforms. Maybe extensive experience is still something, sort of an ambition, an aspiration. Maybe we could say some teams have relevant product experience, but maybe most teams, in fact, what I see is start to have some product experience. It's still not nearly enough, in my opinion. We need a lot more. We need to bring senior people with a lot of product experience who have been in the trenches, maybe with end customer products, not so technical, but they know the things that you need to do to understand your customer base, to prioritize the demands when you have a successful product. And those are the things we need to bring into technical platforms as well. So I highly recommend organizations start doing that. Now, in terms of what we're still missing, I could do a whole talk about that. And it's normal, this is a field that's evolving. But a few key things that I want to highlight are the fact that the boundaries of the platforms need to be more fluid. There's still this idea that whatever we define the platform is going to live there forever, and that essentially the platform keeps growing forever. And while that is partially true, we shouldn't look at the platform boundaries as being so rigid, because then they start potentially to block teams and increase their cognitive load. And that's when we sort of prematurely or too rigidly define, well, this service or this feature is in the platform, and so we own it, and other teams have to ask us for change. And that might work well in the beginning, but when the environment changes, turns out that the product teams or streamlined teams need faster changes to that service or functionality, especially when we're talking about business functionality that is in some kind of platform. Then you might have a different pace between how the platform can change that service and how the streamlined teams need that change, how quickly they need it. So you don't want that. You want at least to have the openness to say, okay, let's figure out what's a better way. Is this something that we should allow the product teams, streamlined teams to change themselves or even remove from the platform and say, there are too many variants possibly of this functionality. Each team needs to figure out, or they need to work together, figure out what they need, but cannot be in the platform. Essentially, it needs to be more flexible, what's in and out of the platform, and what can we build on top of the platform as well. Obviously, we should use good approaches, good API design and so on to make sure the platform is also as extensible as possible. Another problem I see is not being mindful of the cognitive load on the platform teams themselves. And so we need to be realistic about the capacity of platform teams. They have a lot on their plate, from how many tools and frameworks they might need to deal with, and sort of abstract so that it makes life easier for the development, application, and product teams, to all the responsibilities they might have from actual doing the development of services and those abstractions, to operating them, making sure they're reliable and available, those platform services, to helping educate your customers, because like I said earlier, it's not enough to have the service if people don't understand why is it useful to have an observability service, for example. What does that mean? How do I use it? How do I integrate this in my workflow as a product team, right? So you need to do some of that education work as well. And so a lot of different things that might be required from a single platform team. And so try to use simple approaches like time boxing, basically. Define some target, how you want to spend your effort. Maybe we say, well, 50% development and operations, 30% education, 20% on communication and sort of marketing the platform to other teams as well to show what we offer. And then the reality, you can measure how much do we actually spend on each part. And so if it doesn't match your target, what are the things you want to do with what you actually needed to do? Then you can take some actions to try to whatever that might be. We need to reduce how much time we spend answering support questions. Then maybe we need to improve documentation. It can be anything else, right? Sometimes we can provide more value and not build as much, right? Might be that it's the documentation, the examples that are not easy to understand. It's not that the service really needs to change or that we need to add more features. Another aspect I see missing is this idea of trust boundaries. To give you an example, I often see organizations that have a platform tribe or department, right? And so all the teams working in some kind of platform are in the same department. So to some extent, this makes sense. The problem is that platform teams, more than almost any other team, need to build trust with the product teams and the teams using the platform. And that's going to be very difficult if we're working sort of isolation in our own tribe and then we just come out now and then to talk to others. And so we need maybe better approaches to the way we design the organization, and especially the platform part, to make sure we are aligned with trust boundaries that exist for any human being. We don't feel the same level of trust with a larger group than we do with a smaller group. We don't feel the same level of trust with someone that we've only seen messages in the Slack or our chat tool, right? So we need to work on those things, make sure those connections are built over time, and that kind of education work or enabling work from the platform, training and talking to customers is really important. It's not a nice to have people skill, is really might make or break your platform success. The fact that you have built trust with the customers and the product teams, right? So that's it in terms of state of the union. And let's get back then to this idea of what if outside of engineering, basically across the organization, we always think of others as our customers, even if they're colleagues and peers from other parts of the organization. And these ideas I just talked about of platform as a product, how could they help if we're trying to adopt this platform mindset outside of engineering? Well, let's look at some examples. What about compliance as a platform? And forget for a second about the bananas in there. I'll come back to that. What if we had a compliance platform? How could it look like? Well, maybe a common type of service that we could have is some way to search for applicable regulations for our domain or the domain of the product we built. What kind of regulations exist? What is the impact? What is the context for this regulation so that we can understand what we need to do? What is the validity of this regulation, and so on, right? An easy way to search for that. with the guidance around it as well. Like, when do you need to ensure you are compliant with this kind of regulation? Maybe another service could be some checklists for auditing to make sure our service or application is compliant, and will likely pass some kind of auditing request, right? And this might be just some artifact, some documentation guidance that we use, or might be an actual running service that we could test our application against. Obviously, that's more involved, and you could start just something simple like proper guidance and context. Turns out this already exists. There is an organization I talked to where what they do is interesting. It's not related to software. It's about labeling, nutrition labels and other kind of labeling for food items. And therefore, turns out the bananas labeling is actually fairly complicated. And so the people doing that on the ground and certifying, etc., they need to understand the regulations in different countries, different regions. And so they actually they don't call it a platform. They actually have some people, a team that works on making sure this is easy to understand, that providing these regulations as a kind of service to those teams or people doing the work on the ground, let's say. Another example, what about legal? Could we think about legal as a platform? What would that mean? And just to make sure we're on the same page, doesn't mean that suddenly all we do can be turned into a platform as a product approach. Obviously, there's a lot of work around legal that it cannot be turned into a platform. But what we're trying to do is maybe a significant percentage of what we do with our processes can be done more in a self-service fashion by other teams and not depend on us as the legal team or any kind of team that I'm talking about, right? It's also not meant to say, well, now we provide this platform, so every other team can be a legal expert. Obviously, I strongly discourage that. That's probably going to be very risky. It's just to make sure kind of common use cases can be easily self-served and, again, contribute to a much faster flow of change whenever we need, for example, a new contract with a third-party provider. So in this example, maybe the legal platform is something which provides some service around standard types of contracts like non-disclosure agreements or things like that, right? So that the teams that need something fairly standard, trivial, maybe we need to engage and contract some, consulting services or training services, we can have, quick access with the right context and guidance to some contracts that are needed to be in place. Again, I've seen some examples of this. One particular example in a large retailer across the world, and their legal team, I could see from the way they were presenting. In this case was about this type of contracts, NDAs, that they were trying to make life easier for those teams that needed to do the NDA with the third party. Another example could be leadership as a platform. What if leadership, obviously part of their work would be how do we help teams be able to understand better our strategy, better understand if we are aligned to that and what should we be focusing on. Maybe we could have some services around, maybe some strategy boards with, a way to the right questions and the right things to consider for any team to figure out if we're going the right direction, if we're aligned to what is the goal of the organization. Maybe some metrics service, which again might not be something running, but just some examples of metrics that are useful, how to measure certain things, what not to measure, how to interpret metrics. That could be helpful as a leadership platform service. Again, turns out I've already seen at least one example of this, and I know there are more, where this consulting company in Norway effectively tried to apply team topologies to the whole organization. And so leadership became what they call a team strategy, where they have this sort of platform approach. They're trying to help teams do things around strategy and metrics in a more self-service way, rather than telling them, controlling and telling them exactly what to do. Now, the problem with this, even in this early examples is that sometimes we lack adequate team interactions for effective platform evolution, because it's fairly easy to design, have these diagrams and have this approach and put it in place. And that's great and very helpful. But then as the needs change, as teams come to us and say, actually, this is not the right contract that I need a different version, are we as a sort of platform outside of engineering open and ready to have the right interactions, whether that's collaborating, facilitating, etc., right? So in the case of legal as a platform, what I've seen is that in this actual real life example, the team that needed a new type of NDA because it wasn't a good fit what was in the platform, couldn't achieve it, couldn't get that new version because the legal team was not open to the fact that there are different use cases coming and that we should address them, or at least provide a way for teams to implement them. And so there was a lack of collaboration here happening. In compliance as a platform, I've also seen the fact that, again, this is ideal, but then maybe those teams, especially if they're not experienced with regulations, they might actually need help to facilitate that knowledge and understand more about the regulations before they can actually use them, right? And understand in which context do we need to do what. Effectively, what we need is to have some shared values to play well together, right? So that we understand across the organization that this sort of platforms are going to need to evolve. We're going to need to have different interactions in place depending on what are the needs of our customers. This is something that Byron Miller from Red Hat was talking about in a Twitter shared last year, that it's not about autonomy doing what you want. It's agency to operate with safety and being able to do the work you need efficiently with the encoded values that are jointly shared between, in this case, legal or HR or whatever part of the organization and the rest of the teams, right? You need to have some shared values. Okay, this is how the platform is going to evolve. This is what we're going to do. And so I think it's quite important to have this well-defined. So some examples that I think are important of shared values include prioritizing fast flow of value to end customers. So when we're changing the platform or defining it, we should be thinking about how do these services help reduce blockers and improve the flow. Unblock others through curated self-service patterns, right? So understand that it's not just about providing some service and let others use it. It's actually understanding how are they going to use it? How do we make it easier to understand? Number 3, the platform should be open for change, and teams should be open to collaborate when we discover there are new needs or variations of what we have that we need to cover, right? We cannot just say no, whatever is in the platform, and if it's not in platform, then no, you cannot do it. That's not really acceptable in modern days when we know the context inside and outside of the organization changes so quickly. Number 4, we should optimize for adoption and discoverability of our platform in whatever function we're providing, right? In some way, we need to sort of market and make sure people know there's some kind of legal service that we can use or some leadership service that we can use, right? Make sure it's as discoverable as possible. And lastly, enable others by meeting where they are today. Understand that not every team knows a lot about compliance or legal. And so you might have some that are quite experienced and other teams that really are new. So you cannot sort of apply the same approach to every team. Even if you have a platform, you need to educate some teams more than others. You need to cater for new needs and new ways to explain how the platform works. So I hope that this talk was useful, that it sort of shed some light on some of these problems. And hopefully when you encounter this sort of divide in your organization, next time, that maybe you can plant the seed of sort of understanding, explain some of ideas of platform as a product to other parts of the organization, maybe even help them figure out what could we start providing in a more self-service, unblocking way, right? And maybe in a few years, this future of platforms will come true. And if you want to know more about the ideas of team topologies, fast flow, platform as a product, you can check our online video-based academy, and we have different learning paths around platform, and we have a special discount code for PlatformCon attendees, PlatformCon 2023, and you get a 15% discount on any of the academy courses or bundles. Thank you very much.
Hello, beautiful platform engineering community, DevOps enthusiasts, brothers and sisters in arms in our fight against developer burnout, repetitive tasks, and cognitive overload. Well, it's happening. We finally can say that we have a PlatformCon yearly tradition, and I'm super happy to be here with you today. My name is Mathieu Franette. I am the Director of DevOps at Nesto in Montreal, Quebec, Canada. I've been a software engineer for quite a few years now, and like all of you today, I'm sure I love everything that surrounds platform engineering. Last year on PlatformCon 2022, I gave a talk entitled On Growth Challenges, Generic Helm Charts, Golden Paths, and Abstraction Levels. If you haven't watched it, I encourage you to have a look at it. Today, I'll try not to get into too much transcendental stuff or universal truth, but rather stay down to earth and really focus on the very concrete strategies that our team is using to try and make our platform happen. We'll talk today about making time for what matters, reclaiming control of our own ship, building our MVP, and transitioning devs to our platform. If I was to ask everyone here today what their idea of the perfect platform for their company or their team, I'm sure everyone would be like, hey! So I'm sure that even if we ask ChatGPT or Bard or Copilot what their idea of a perfect platform is, I'm sure they would have their own idea. Maybe something like this, or maybe if we have a larger budget like this or a smaller one. But that's not the point of today's talk. We won't tell you what your platform should be, what it should look like. We'll try to see what we can do to make it happen in the midst of everything else. Because let's face it, our days are filled with unplanned work, support tickets, access requests, new infrastructure to provision, meetings, which all leaves us with very little time to work on our dear perfect platform. So let's start by how to make time for what matters. So we figured that we shouldn't wait for the ideal moment with an official mandate to focus solely on that project. We said, okay, let's just take the initiative and go ask. So I went to my VP of engineering and I asked him, can we allocate 20% of our team's time to building the platform? And guess what? He said yes, because he understood it was important and the proposal was reasonable. It was just enough time to make it working, to make it possible, but not too much to detract us from the other things that we needed to achieve in our days. But then to make sure that this 20% time gets actually used, that it gets leveraged, we reserved in our team's calendars sessions every week to work together to further the project, to discuss, to ask the hard questions, to design, to create tickets, to groom them, to create specs, and to prepare the work. And we affectionately call those sessions our DevOps Jam sessions. And to be quite frank, these are my favorite times of the week. But then we also book time on our own to work on the platform so that when we go back to work, we are sure that in our week, we won't forget to allocate some time to the platform. And then we used a tool, a schedule management app, to help us preserve those precious focus times. And in our case, we are using Clockwise. We have no affiliation whatsoever with Clockwise. We just love the tool. There are many others out there that do similar job, but that's the one we picked. So that has made a great deal of difference in making sure that our calendars didn't get super fragmented. We also defined and shared with the other teams our team API, which describe how to best get in touch with us in a streamlined and efficient way in order to reduce the noise, to make sure that we understood what their expectations were, what were the level of priority or of urgency, and that we can all streamline that into a single or as few channels as possible. And talking about noise, we also realized that we could split the responsibilities within the team based on our individual strengths and interests. We realized that one of us was super socially inclined, that he was happy to just be on the front line, to be the one talking to developers, to take in all the requests through Slack, to turn them into tickets, to check the boxes like quickly throughout the day to make sure that we gave a great service to developers. And that is making him happy because he loves to do that kind of work. And it also greatly reduced the noise on the rest of the team to help us focus on the platform development itself and the other things that we needed to achieve. One other thing that was generating a lot of noise was continuous requests from developers to get special access to, let's say, a production database or to a production Kubernetes cluster. And these were taking up a lot of our time. It was repetitive work that could easily be automated. So we currently are putting in place a commercial solution to automate that, to allow developers to do self-service in terms of privilege escalation, and it will greatly free us from having to do that on a daily basis. Reclaiming control of our own ship, which can also be called paying off your technical debt. And this is something that we quickly realized that if we didn't address that technical debt, it would be pretty hard to make large-scale changes to our infrastructure, our CI/CD pipelines, our way of deploying, of managing everything. So that's a tough part. It's something that is really foundational work that needs to be addressed first. We started by standardizing our infrastructure via infra as code. We did the same thing with our CI/CD pipelines, which were scattered everywhere. It was tons of copies of similar pipelines with just a few tweaks here and there, but it was very difficult to make changes to those pipelines in a coordinated fashion. So we standardized those into templates that we are now managing via infra as code with different parameters for the different use cases. And we did the same thing with our Kubernetes deployments by creating a generic Helm chart for all our deployments. So instead of having tons of copies of Kubernetes manifest for each project, we centralized that, standardized it into a generic Helm chart that can be reused across the board. And that's exactly the topic of my talk last year, if you're interested in learning more about that. So my takeaway advice for this part is really be patient, be courageous, because it takes a lot of time to do that, a lot of effort. It's not glamorous work. It's not highly visible. It doesn't shine, but in the end, it pays off. It allows to make big changes afterwards. It allows to be in control of everything you want to put in place instead of being constantly fighting with the chaos around you. Building our MVP. So I had the great opportunity to start at Nesto as a backend developer, and that has helped me to put myself into the shoes of developers, to experience what they are living through, like firsthand, to understand their challenges, their pain point, what is causing friction. And but we didn't limit ourselves to that understanding. We used surveys and workshops to gather as much information as possible and feedback from the developers to create this big picture understanding. And then we used that to think big. We wanted to envision the ideal solution and not be conservative there, really create ourselves a North Star, even if we knew that we would not get there in a day. We picked the best of breed solutions to avoid reinventing the wheel. In our case, it's Argo CD, Crossplane, Helm, and others. And we only added the little missing parts to glue all of that together and turn it into a very seamless and smooth solution and developer experience. And in our case, we named that part Joy. And it's something we'd like, hopefully, to make open source someday when it's ready. And it's made up of a few custom CRDs, a Kubernetes operator, and a CLI for developers to interact with the system. Then we broke down that big picture into viable steps, into manageable chunks, and decided what would be the very, very minimal first step that we could do as an MVP. And that's tough. That's a very tough exercise, but it's necessary to be able to deliver value as quickly as possible. And given the little time that we have to spend on the platform, we want to be able to deliver something, not when everything will be finished and ready, but really very early on. In our case, we also narrowed down the scope of that MVP even further by reducing the initial target audience to only early adopters, assuming that they would be willing to put up with having to do a few steps or a few operations manually, not having all of the features that the full audience would expect or require. So that has allowed us to make it even smaller, that MVP. So we're working on that as we speak. Now, transitioning developers to our platform. We started with, as I said, our early adopters by moving them to our generic Helm chart very early on. As soon as we had that generic chart ready, we didn't want for the whole platform to be ready to have them start to experiment with it, get used to it, migrate their services to it. And for that to work, we had to create temporary pipelines that only them would be using. It's really a compromise, but it has allowed us to really lower the bar to entry when the platform comes, and not PlatformCon, but when the platform comes, it will be really easy for them to move to that platform because all their services will already be on the generic Helm chart, and they will be used to it. They will be familiar with it. So that's one of the ways we found to make that transition smoother. There's also a tool that all developers are currently using to manage their releases, to cross-promote between environments, to see what's deployed where. And that tool, we tweaked it in advance to make it forward compatible with what's coming, because we want the old and the new to be able to coexist in parallel so that we can make that transition more progressive, smoother. And it was a really small change that we needed to do in that tool to make it work with what's coming. So developers will be able to keep on using their existing tool, their old way of working with the new platform working in parallel. So services will be like distributed as hybrid between the old and the new platform. So here we are, super happy to have made it thus far, but the journey is not over. There's still plenty of ground to cover. The journey is just starting, actually. So next we'll need to migrate our early adopters to the MVP when it's ready, to gather feedback from them, and to add the few features that will be required to target a larger audience, and then to progressively migrate everyone else to that platform. So that's going to be made like ideally we're hoping in 1 week iterations, one team per week, and eventually everyone will be moved on to the new platform. Finally, we are hoping that the next iteration, after we have closed that large gap, which was really challenging, we're hoping that the next iteration will be much smaller ones, much more manageable and faster and shorter, because we'll be working on all the new platform and we won't have constantly to consider the old ways. So that's our hope. That's all I had for you today. Thank you all for watching this presentation. I hope it will hopefully help you or inspire you in your own platform journey. I also wanted to extend a special thanks to my colleague Felix for his precious support in preparing this presentation. And I wish all of you to have a great PlatformCon, and we'll see you around in our wonderful platform engineering community.
Hello, I am Fernando Villalba, Tech Evangelizer at Humanitech. Today, I'm going to talk to you about how to make an internal development platform that your users will love. For me, this is about the developer experience. And in this case, we're going to touch about the user experience of the tools that you're using to improve that developer experience. And we are aiming to solve this problem. This was a popular post in Reddit that someone posted some time ago, where someone just spent months building a platform and devs hate it. Help me understand why. Hopefully, this talk will help understand why or how you can make a platform that doesn't suck. First, I want to make this differentiation here. UX is not the same as UI. Some people get them confused, but for me, user experience encompasses the entire user experience. Well, not just for me, in general, like that's the actual definition of user experience. And when you think about great user experience, you generally think of great design. One example here, I would say that Amazon delivers a spectacular user experience when it comes to delivery, but sometimes, in my experience at least, Prime Video hasn't always been as good as Netflix, for example. Like sometimes I'm browsing through the menus and when I press back and I'm sent to something that I wasn't looking at before, or the subtitles are out of sync, etc., etc. Not to say that it is bad, but it's not as good as the Prime delivery, in my opinion. So good design is great communication. Great design is intuitive. It communicates clearly the intent of the tool without the aid of documentation. And this is quite important because RTFM kind of sucks. I mean, this is read the effing manual, and you see it a lot over and over again. Engineers telling to each other, oh, you should RTFM, you should read the manual. And sometimes it has a good intentions behind it, but sometimes it also feels like people who lean too heavily on this end up being lazy on the design, and then creating a lazy design that actually ends up in a very clunky manual for the user to read and use. And I want to show you a simple example of what it means to have like this RTFM driven design. And it's quite funny, and I promise you that this video is not a joke, it's actually a real video showing you how to use a tool, Lightbulb in this case. So as you saw in that video, I mean, it's not exactly the kind of experience that you want for your users, and it's not the kind of experience that you would want for your internal development platform. So RTFM driven design piles the burden of responsibility of usability on the user. And this is exactly what I mean by that. When you design a product or you pick a product that takes minimal amount of the complexity burden, your user is going to be unhappy because they're going to have to do the extra work that the tool doesn't do. But when your product or your tool takes on most of this complexity burden, then the user is going to be happier in the end. To create an intuitive tool, I'd say you should design with the weakest, sillier user in mind. You have to think that there are no bad users, there's just bad design. And what I mean by this is that we all have our silly moments. And you want to have a design that protects you from silly mistakes and is also very intuitive. So when you grab the tool, you can understand how it works and you can use it as easy as possible. And you always have to remember that internal development platforms are complex. I mean, there are many tools, but you can always compartmentalize them into multiple users, multiple personas. So you can deliver experience based on these personas, which is what we're saying here. And this is a good way for you to get to the bottom of why a design is not working. If you see that your users are struggling with something, just keep asking why and keep going as far back as possible to the design that is making your users like confused about how to use the tool. Never stop at the user, keep going and see if you can solve it at the same time. So a few words on design and beauty. Beautiful design is important to attract your users. It will make it more palatable for them. It will make more attractive whatever tool you have. If you have a nice presentation, nice design, but it may not keep them around. So, and I'm saying this here because sometimes people, when they associate design, they think, oh, something beautiful, something pretty, but that's not always the case. It helps, but it's not the only thing that we're talking about here. So now I'm going to talk about some elements of design that you can learn and leverage in order to make your platform better. So First, we're going to talk about features, and I argue here that you should have quality of features over quantity. So there is a flexibility and usability trade-off. If you have a lot of features, your tool is going to be more flexible, but it's also going to be a lot less usable. And I like to use this example here because I bought this TV, this Samsung TV that had 2 remotes. And the one at the bottom that you see there, the really complex one, no one at the house ever used it. Even though you have lots of features in it, it does more than the other one, but the other one was just so much handle to use. And the complex features that you needed to access that the other one offers, you could just go via contextual menus because they're not that commonly used features. So this is one example where you can leverage certain level of abstraction for your more complex features that you don't use as much. And you can create a clean user interface for your users to easily use. And again, you can leverage the Pareto principle here. Just implement first the features that are going to be the most used. Get some feedback from your users. Now, signifiers. Whenever you're designing something and you're not able to effectively convey how to use the tool just with the design itself, you can add a small signifier. This is a good example. You have a signifier that tells you like how often this cron job runs. And I think it's quite elegant and quite simple. You just hover over it and it shows you that, and it's quite good. This is a funny example I saw on Reddit. Someone was chastising these users that wrote these reviews because they were too dumb to know that, you know, you just have to remove this protective film. And while I can kind of agree with that, I think that whoever was selling this product was making the assumption that everyone is going to have that previous experience with peeling protective films. This could have been very easily solved with putting a little tag on the side of that protective film that said peel here, and it would have solved that problem. So whenever you're designing a tool or you're designing an application, you know, you always have to think where you should put those signifiers to help your users without them having to actually read the documentation. Feedback is usually what you get when you interact with a tool. Like, for example, when you're charging something and it goes from red to green, you know that it's fully charged. And when you're running a command, in this case, it's telling you everything that is happening, and then it gives you a command that you can run, and it gives you a link that you can follow. I think this is very neat. Or if you have an error, it tells you, oh, maybe you meant this, or it may tell you what the problem may be. I think this is excellent, especially when you're using command line tools, or when you're dealing with logs. An application may send a log, giving you feedback, what the problem may be, and where you can look at. It even saves you from going to Google. I think good feedback beats this. This is another popular meme, which I don't particularly agree with because, I mean, anyone that has to deal with an outage knows that, you know, reading 5 minutes of documentation is going to solve you from that outage. Sometimes it may, if you know the tool beforehand, and I think it's good that you read the documentation, that you're familiar with it, but it is not a substitute for having good design and good feedback and all of that. I think for me, the good structure would be this. First, you have design. Design is the most important. Then you go to a signifier, add signifiers, then you get feedback. And then at the very end is your documentation. Documentation is also very important. And I'm not being facetious here. Sometimes if you're using tools that are very complex, you're always going to need documentation, sometimes a lot of documentation, but I think that comes last. Design is always first. And remember, your the worse your design is, the chunkier your documentation is going to be. Conceptual models is the way that your users see things. Whenever you design something, don't cater to the way you understand things. Cater to the one that your users understand the world. So, for example, this is the example on the left is Jenkins. Jenkins out of the box has these blue balls that tell you that a deployment has been done correctly. And the most popular add-on, the most popular plugin for Jenkins is one that turns those into green because That's what people understand as, okay, green color, not blue. Blue came from like the original creator of Jenkins being Japanese, but yeah, it's definitely not a conceptual model that most people are used to. And then on the right is this example, this joke, this meme, which I can kind of agree with. AWS naming their things that, they're not that intuitive to get. But Azure just names the products for what they are, and the same with GCP, which makes it easier to know what you're dealing with. It makes it easier for your users to get familiar with it. Feature constraints and persona constraints. Feature constraints, I mean, the example here on the left is from Mario Bros, the first game. And I'm using that as an example because I think video games sometimes are examples of great design, because you cannot afford to have like crappy design with video games and be successful. Well, someone may disagree, but most games are well designed, do well. And Mario is an excellently designed game. And here's an example. Whenever you get the mushroom, if it is the first time you're playing the game, you wouldn't know if that is an enemy or if that's something that, an item that gives you a power up. So if you're trying to dodge the mushroom here, the block on top will push you back down. So you always get that mushroom. This is an example of using constraints to lead the player to do what you want it to do. So you can leverage these constraints in your application to get users to do what they need to do. And these constraints can help them to stop like doing something stupid, something dangerous. And you can also use persona constraints in order to deliver the best possible features for whatever users you're catering for. So an internal development platform will have multiple users, so you can use personas in order to leverage a better user experience for them. So internal development platforms are composed of multiple tools. You can create some of them by others. Understanding what good design is helps with both. So you should always understand what good design, and not just focus on numbers of features. Especially don't just focus on number of features, also focus on what good design is, because ultimately good user experience is going to make the life of your developers and your users in general a lot better. And it will probably yield software faster. So where does Humanitech fit in? Humanitech sits at the center of your internal development platform to help your platform engineers deliver the perfect level of abstractions for your developers. So basically it takes care of standardization by design for you by ensuring that every deployment has all the correct infrastructure and configuration. So if we look at these graphs right here, you have a developer sitting on top here, defines workloads and resource dependencies with a score workload specification, which is a simple file saying, I need this resource and I need this workload to be deployed. And the platform orchestrator will actually create all of that for that workload, and it will inject all the configuration and do all of those dependencies based on what a platform engineer sets up. So a platform engineering can actually deliver a good user experience for a developer. And this is where this is an internal development platform on GCP. All of these tools make up one internal development platform, and you have platform orchestrator at the center, you have an artifact registry and monitoring and all of that. So whenever you are designing your internal development platform, you have to look at what your users are going to interact with, and ideally pick tooling that is easy to use, because that in the long run is definitely going to help your developer experience much more than picking tools that are very complicated and take a lot of steps to do something, and you have to read a lot of documentation, and it just slows down development in general. And that's pretty much it from me now. This was a very long talk. If you want to read more on UX and platform engineering, you can search for UX platform engineering, and the top result, as it is for now, is mine. And there are references to books there that you can check out, and there's more information there that I wrote. And if you have any questions or you want to have a chat or whatever, just talk to me on LinkedIn, or you can find me in the Platform Engineering channel. Thank you very much for your time.
Hi, everybody. Welcome to the session on platform adoption engineering. I'm Sheila Shankar, and I'm an executive director at JP Morgan Asset Management. So JP Morgan Asset Management is the world leader in investment management, and we have $2.5 trillion in assets under management. We're the top 5 in the Fortune 500 companies, and we have over 50,000 developers with $11 billion annual technology budget with 3 lines of businesses. My team is Morgan Advisor, and we build applications for financial professionals to analyze their portfolios, to compare funds, etc. And our team is a mix of back-end and front-end specialists. And our cloud technology that we use is primarily AWS, EKS microservices, ECS, Lambda, etc. So wanted to share some of the applications that we build. So as you can see, they are heavy on the UI, heavy on data, because you have to analyze portfolios. All of these applications are built and operated by us. We do not have any specific DevOps or SRE team. It's the developers that build and operate the system. So I wanted to take you on our cloud modernization journey. So our cloud modernization journey started way back in 2016. We started with Pivotal Cloud Foundry, which was platform as a service. We were on that platform for 5 years, and then we wanted a little bit more flexibility, more tools, etc. So we adopted the AWS and migrated all our services to the public cloud. Starting in 2021, it took us about 2 years to complete that journey, and now in 2023, we are in the maintenance mode. When we finished our cloud migration, we were blissfully happy, thinking that all the heavy work is done and we can now relax. But within a month of going live, we realized that there was a lot of heavy lifting that had to be done month over month. Let me introduce you to the cloud operating model and how does it work in JP Morgan. So JP Morgan, since it has 50,000 developers, we have a really large global platform team that provides all the tooling necessary to build and operate a cloud platform. Namely, we have Terraform for infrastructure provisioning. For continuous integration, we use Jenkins. For our continuous delivery, we use Spinnaker. We have multiple tools for monitoring our applications, for detecting vulnerabilities, etc. So is that enough? Is tooling enough to build a cloud, application? So tools alone are not enough. You also need skilled drivers. So for example, you do have Terraform, but you do need developers to be able to provision the right infrastructure. So they have to be at least aware of all the different tools available in AWS to be able to provision it. And also you need developers to provision the right tools. So use the right tools for the right services. If something can be written using a serverless function, use Lambda. If it needs more functionality, then you would probably use an EKS service. Or if it's a simple container application, you could just use ECS. So you need developers to choose and pick the right tools. We do have Jenkins pipelines, but you need to be able to write good, efficient Jenkins build scripts so that your container images are optimized and are not bloated. You need your pipelines to be efficient, so that you can have your application build time as less as possible. The tools may also detect vulnerabilities, but you need developers to fix the vulnerabilities. So tooling alone is not enough. You need skilled execution. In addition to that, we have in the public cloud world a lot of maintenance activities. So since we are using EKS, there's EKS cluster upgrades using blue-green. That happens at least at a minimum twice a year. You also have database and Terraform stack upgrades. You also need to renew your certificates at least once a year. So this would be your load balancer certificates, your X509 certificates, etc. Then you may want to refactor your application because you constantly see that something or the other is not performing as well as you want it to be, or you are seeing that it is costing a lot, so you want to make some cost optimizations. So these are the types of activities that have to be done throughout the year. There is no respite, and it is not going to go away. That is just the reality. In addition to this, you also want to modernize the platform. So today you're using manual pipelines. Tomorrow you might want to build abstractions. You might want to, for example, we just migrated from Jenkins to Spinnaker. So that required a lot of rewriting of all our deployment scripts. Tomorrow you might use GitOps, right? Using Argo CD. So there's always some amount of modernization that's always expected. So what does this mean? This means that there is a lot of cognitive load to the entire development team who are building and operating this platform. So I wanted to talk about the 3 different types of load. So you have the intrinsic load, which is the the minimum knowledge that you need to be able to write some code. The germane load, this is the good load, which you want developers to have. This is the load that you will have when you're building something new. So you're learning new skills. So for example, you're adding machine learning capabilities to your microservice. You're learning something new. So you have that load for some time. The extraneous load is what you want to reduce. And this is the load that is, in addition to your application logic, in addition to something which you are learning, you also have to do this additional extraneous load, which is, for example, you want to spin up a new cluster, you want to deploy your application to a new EKS cluster, or you want to bring up your development environment, and that takes up a lot of work. That's all the extraneous load. And what happens is that the developer has a limited working memory, so you overload too much, that causes a loss in productivity. So the main objective is how can you reduce cognitive load? So we read this book by Matthew Skelton and Manuel Pei, the Team Topologies book, and we decided to adopt that. And the book talks about having a platform team in addition to your stream-aligned teams to be able to increase the flow and to increase the efficiencies of the stream-aligned teams. So that's what we did, and we built our own platform user team. So out of a team of 30 people, we took about 6 people to work on the platform team. And a few skeptics may ask the question, why will this help in reducing cognitive load, right? And you already have a central platform team. So the difference is that previously, in each of the individual teams, we had platform, developers playing the platform role, And they not only had to do the application logic, but they also had to actually make their write some sort of platform logic, platform code to make their application deployed on the public cloud. So instead of that, you now have a dedicated platform team that is just meant for making sure that they work side by side with the Streamline team, and they can also work by having different software as a service sort of functionality. So this helps in reducing the cognitive load, because now the platform user teams, they increase their germane load by they have to only focus on the cloud platform, and the application streams, they are only focusing on building application logic. So it works for both the application teams as well as the platform teams by giving them just one area of focus. So what are the key differences between the two platform teams? So the central platform team is all about standardization, building blocks, having tooling for CI/CD and improving the developer experience, etc. Whereas the platform user team is all about building customizations as needed. They're using the tools which are provided by the central platform team to actually build applications. And they are building products. They have a focus on FinOps, because your central platform team is not going to be able to monitor your cloud bills, right? So your team's cloud bills are our responsibility and not the central platform team. So our team is responsible for the security of our applications, the costs of our applications, how we operate it, and how we observe it, etc. So the platform user team's responsibilities are all about supporting the different applications for that particular team. So what are some of the guiding principles that we have followed? So first one is to build shared services. So as I mentioned, we have a couple of tools that we build and operate, and all of them have similar requirements like authentication, authorization, sending out emails, making calls to external services, etc. So we build, the platform team has a shared, a shared set of services which are reused by all the applications. Secondly, we want we have a very strong communication between the central platform team. So both the wins and frustrations are communicated, and we're also early adopters. Any new functionality that is offered, we're always ready to be the early adopters. Then our focus is on reducing the cloud costs and to make sure that we are operating as efficiently as possible. And for that, we do monitor our cloud bills and make sure, for example, KubeCost shows you how many of your clusters are, how much memory and CPU is being really used. So optimize that, turn down environments if they're not being used, etc. We also want to build efficiencies and expertise by working, with the platform. And as you work more and more with the platform, your efficiency, your expertise increases, and the speed at which you do perform your duties also increases. So, for example, by having this platform team, when we migrated to Spinnaker, we were able to turn around all our pipelines by having a dedicated platform team, because they were only focused on that particular task. So increasing efficiencies by focusing on one thing at a time. So what are some of the key takeaways that I would want you to take away? Is you don't provide the platform alone. You also need to invest in developer training. because you want your developers to use the platform to all its abilities. You want them to use it efficiently and to use it well. So just having one platform team is not sufficient. You can have as many platform teams, and the only thing that determines that is the size of your application team as well as the complexity of your applications. Second is to be very mindful and to be aware of the time that it takes to run the platform. So it's important to have these objectives in while setting our OKRs. So we have clearly defined objectives that this is going to be the different the different initiatives that are going to be done by the platform team. And similar to that is to have a product mindset, because the platform team has a clearly defined backlog, and the items on that backlog come from the different application teams. So the platform team is not inventing tasks of their own. They are helping to increase the flow of the application teams. So treating the platform as a long-lived product, and also to have a clearly defined backlog, I think is very important. So I think that concludes my talk on platform adoption, and I hope you found it useful. And thank you for listening to this talk, and hope to see you again.
Hi everyone, my name is Ralph Hack. I'm the founder of Logilica, and I'm going to talk to you today about the return of investment for platform engineering activities. More precisely is how can we come to an approach where we measure a little bit more what's the effect of platform engineering and how can we sell it to management to maybe invest more in this, continue investing in this, and building out a roadmap. So let's start off right away. Why platform engineering? So one of the first things, obviously, we learned in the recent year, DevOps is dead. Well, even if DevOps is not dead, we know there's a lot of complexity, a lot of challenges that comes along with the DevOps processes, especially if they're kind of run by each team individually. There might be a lot of duplication, load on development teams, and all these things that come about if you don't sort of have a centralized function around running your tooling, infrastructure, efficiency, and so on and so forth. Now, the question is, how do we improve on this? How can we change to a different approach? And obviously, platform engineering as a topic and as a theme coming up is quite important. And it is sort of something a lot of companies like to invest more into. But how do we do this? Well, the first thing is you just rename DevOps engineers and they become platform engineers, and you do things as you've been doing them all along. But to be honest, that's probably not the best way to go about it. Secondly, I mean, what else is there? You kind of say, okay, let's start from scratch. We burn down the house, and afterwards we start from the beginning, reorganize everything and start things from scratch. However, if you take that approach and take it to your management and say, like, this DevOps thing didn't really work out for us, let's do something completely different, they probably look at you a little bit like that and say, I'm not really sure. What do you mean and why? And, that's kind of a bit of a huge investment and change of the org, maybe. I don't think so. So now the question is, how can you build a case and how can you build sort of a roadmap to change from one mode of operation into a different mode? And looking into platform engineering, from a tech point, it's quite simple and straightforward. You say, okay, what does it give us? Well, we might have less silos. We can better reuse components and have a better developer experience such that, developers can self-serve. They're happier and more productive. That's quite true. And it's also probably quite important. but that doesn't really give you much of a business case to bring forward to say why you should actually change things. Yes, it's nice to have, but what does it mean in terms of numbers? What's the investment for the company, and what's sort of the return of that investment? So in order to address this, it might make sense to look a little bit more onto the actual business drivers behind this. And obviously, from a business point of view, I mean, the dollar and the headline figures is important, but it's not everything. And the more you can can create some return of investment based along some business drivers, the easier it is to be an advocate of the change and get the support that's kind of needed. Obviously, one of the things that's highly important for business beyond the actual dollars is predictability. If you can create a case that says, we get much better accuracy in delivering, in the cost of delivery, in our forecast, and we know better the type of value that we deliver, because we now have got a much better understanding and have a much better platform, then this predictability easily translates into predictable business outcomes, which is often quite highly sought after. The other thing is probably the speed or time to market, or even time to react and fix issues that we might have, and the velocity of the company. If you can have a business case that improves the time to market and basically improves the agility of the company, so that quite often means you can outperform competitors in the same space, you can create and react much better to market demands, be more flexible there. And again, that's probably something that gets much more traction than sort of having low-level activities that are a bit vague in terms of business outcomes. And I think the other one, which often gets neglected a little bit, is everything around compliance and around risk. So that might be security, cybersecurity risk, that might be quality issues, reputational risk, or just simply reporting obligations that can be unified and created much simpler in the course of action. So, and I think if you, from a platform engineering point of view, can create a business case and roadmap around those types of themes and align it with that, then that becomes a much easier transition into getting the support that's necessary to execute a proper strategy in that stage. So how then can we measure, or how can we create some of those metrics a little bit better to support a business case? Obviously, as an engineering team, you don't have access to all the operational data, to the sales, marketing metrics, to some of the revenue drivers, but you have got a lot of value creating metrics in terms of what the engineering teams and you as an engineering organization is actually doing. And if you think back about your delivery pipeline, so you also go through different stages, let's say from the planning to code creating, building, deploying, running the infrastructure. And some of those themes that I just talked about earlier are not too different in the engineering side as well. So you also want to create value and to have a sense of cost towards that value about creating features, shipping them, security, quality, creating features, ensuring you have the security, quality of the product as well as the platform. And then obviously the speed, having no roadblocks, having as little delays as possible in delivering from the initial inception to the actual feature delivery, or from delivering sort of the bug fixing up the environment and being up and running again. So these are sort of similar alignments. And if you then want to look a little bit more into, okay, what should we actually measure? I mean, firstly, that might be quite dependent on your own organization, where you are in the platform engineering sort of maturity, and also where you start looking into first. Do you look first into sort of developer productivity? Do you look more into platform stability? Is it more on an organizational side, or is it sort of on a silo where you start off with? However, I think no matter where you want to start off with, I think the important bit is start off with something that management can Google. So that sounds simple, but basically if you create your own framework, your own metrics, that's typically a much harder sell than if you have something, you find a lot of cool hits, something that gets supported by analyst companies such as Gartner or Forrester, or something that's just generally well known. And NIST has been in the security space, for example, sort of a reference point. If you have something you can piggyback on and you can refer to, that makes it much easier to have this transformational step on saying, okay, let's say we're looking at DORA metrics. So one thing is about the speed to deployment and then the ability to recover if something goes wrong. And this gives you basically already a couple of high-level reference points you can move back to the initial ROIs that you might have defined. Another one is maybe the SPACE framework, which is more about developer experience, productivity, satisfaction. Maybe you already do some kind of net promoter scores around developer satisfaction. Can you measure this and improve that over time? Do you have things that are blocking? That's quite often highly regarded in sort of like flow type of frameworks. Do you see how much the velocity, speed, throughput of certain activities are? What is blocking you? Where are you kind of wasting time by waiting on things that might be infrastructure, that might be people, that might be coordination overhead? Is there sort of certain things that you think is a particular in your organization you want to improve on? Map that back to one of these frameworks and then build a ROI or a business case around those frameworks. And just as a simple example, and these are really proxy metrics, and you can say these are, I think, proxy metrics, however, they map back to the next stage up and then the next stage up, which might be the more predictable business outcome or speed. One of those things might be lead time, and that could be the lead time from inception of a ticket or like an issue, or we use Jira, for example, until that really becomes a feature that's going to get shipped. Or it's going to be an incident that needs a bug fix, that needs a deployment until it gets fixed. So if you can say we improve lead time by, let's say, 20% for a particular class of activities, obviously you can say, okay, this is a proxy metric to how we're improving our speed in terms of fixing our time to market. And also in a similar way, you can look into, let's say, infrastructure. If you don't have each team maintaining their own infrastructure, but you can reuse components or can reuse hardware and you bring it down, let's say 35%, that's obviously directly relatable to cost metrics and to dollars. And similarly, maybe if you just start very low level, let's say we know we all do code reviews, but because at the moment there's so much chaos and people always jump from doing code reviews to do other stuff to fixing the build server. So quite often these things are the least fun bits and they get delayed, and maybe also sometimes the least urgent things. If you can measure this, how long does it take for us to start a code review or get through it? If you have a heavy reduction in that one, that also gives you a good indicator about costs being more efficient and improving productivity as well. So we find typically these types of things work quite well. They can be abstracted then up to the next level and build an argument. Quite important on that space, I think, is to not do this once in terms of creating and then measuring, but continue and watch out the trends. Ideally, if you can say, look, in the past, before we even started something, it was like this. Now we are doing our first steps and we already see or have at least a gut feeling of a difference, even though we might not have measured this over time. Now let's put a framework in place for really measuring some of those things that are important to us and then project it out to the future. So one, projecting out where do you want to be? And the other one is a little bit, how are we tracking according to the goals that we might set ourselves? And these can be just like 1, 2, 3 metrics that give you some indication how things are going. And that, as we'll explain this in the next steps, is going to create then the trust to communicate that up and continue going into this. So as a summary and how to build some roadmap to come to ROIs that are specific to your organization and that make sense for you, and then be on this continuous improvement journey, is to define some KPIs and some deliverables. And these don't need to be too much of a stretch goal. Maybe you don't have anything that you currently track continuously that's kind of gets communicated into the right level, and just start somewhere. From my point of view, I think it's quite important to make that visible, and the simpler, the better. However, it should be not something where you put in a lot of time and effort, but something you can automate around. And that might be just, how many developers do you have? Where do they spend time? How's your infrastructure going? What's your lead time? How's maybe your review times coming down? Do something simple. Put that into something that's almost live visible, and it reports to the right level. So that right level might be your director of engineering, or it might be some of your VP level, or even sort of the C level. And you probably need to adjust that messaging. Your director of engineering might be great understanding about your review cycles and things like this. Your executive might really not care about this, and just, how much people time do we have? Where do we make improvements? What can we do instead? And how do we invest more to improve that even further? So at the same time, I think quite important also is, don't boil the ocean. Pick 1 or 2 or 3 metrics that are important, and, be aware of your limitation within the organization as well. So in summary, I think your mission is, or the platform engineering mission is, to create trust into a platform transformational journey, starting from understanding the business impact, creating the right processing metrics, creating the visibility, and then creating trust, which then in turn comes back to more investment and future improvements in that space. So thank you very much for this quick walkthrough. If you've got any questions, ralph.huck@logilica.com or in the Slack channel, and I'm happy to talk to you. Thank you very much.
Hey friends, my name is Brian Douglas, and I'm excited to talk to you about release automation. So let's jump right in. Excellent. So to talk about release automation, I need to first talk about continuous integration, continuous delivery, to automatically always deploy your project or your platform, really, to production. Now, great automation looks like this. You've got a simple setup that you could scale, and this is actually not a scale, it's a treadmill. But instead of walking downstairs to travel all this wood to the basement, you create an automated process. And that's like the bare bones of automating releases. Now, I previously worked at this company called GitHub, which most of you have heard of. I spent about almost 5 years there, and I worked pretty heavily on talking through the idea of automation through this tool called GitHub Actions. So GitHub Actions really is a bunch of primitives that GitHub's built over the past, at this point, 15 years today. Amazing. But these primitives, the API, webhooks, authentication, all built in and bundled into one layer, which is interactive, which is your repository. Now, I was a big fan. I grew up in the 90s and big fan of BA Jam. And I think what it really comes down to this process is, just like in the game of basketball, you have a process to get the ball in the hoop, just like getting wood to the basement. So I always use this like analogy with basketball when doing automation, where on the game of basketball, it is to get the ball in the hoop. And there's one concept or statistics in the game of basketball. There's a book actually came out called Hooponomics. And so the book was called Sprawl Ball, but the idea was called Hooponomics. And it's basically money ball applied for basketball. And there's one point in the court where all the majority of the points win. Sorry, the most of the points attempted as field goals win in 30% of the time. So if you knew that 31% of your shots would go in if you got the ball to this point, you would optimize and create play structures to automate yourself to the hoop. Now, automated as in you don't really have to think as an NBA player. NBA players are very smart, but what I'm getting at is you don't have to think about where everyone is at the court when everyone has a job to do. So in this, what we're looking at is, and I'll get into automation in a second, but this is what we're looking at as a triangle offense. For the 1, 2, and 4, it creates a triangle. And so that way, no matter where you are in the court, you always know somebody is in the spot of the most highest percentage shots, which is number 2 here. And the idea is if you know someone's there, or if you know that person double covered, at least a 5-4 and the 3 will be wide open. So think of that when you think of the concept of automation and getting things shipped continuously and iteratively to get your releases cut. My name's B Dougie. I introduced myself as Brian Douglas, but go by B Dougie on Twitter, B Dougie on GitHub, and I like to say that I'm the Beyonce of open source. I only have 15 minutes, so I can't go into detail on why I call myself that. You just have to Google it. And I mentioned earlier GitHub Actions being the feature. Now, I used to work at GitHub, but I've built almost all of my infrastructure and all of my platform, which is open source today, on GitHub Actions. And I'll get into that in detail. So we touched on the workflow automation, but we want to talk about like the different pieces. So to kind of understand how you interact with this one DevOps tool, everything within the idea of GitHub Actions is built inside of a workflow. And these are the workflows as just like playing the game of basketball, you have plays. Well, these plays will be inside of a workflow folder, which is written in YAML. And every single workflow is triggered by webhook events. So any interactivity on GitHub within their webhooks, which is one of the primitives, will trigger an event to start the automated process. Now, workflows include jobs, and we're going to go we don't have to go all the way down. This is as deep as I go. But these jobs will go do one piece of the puzzle. Now, these are all the players on the court. This is this sort of mental anecdote analogy that I'm providing for you. So if you know these are jobs and these are events that you do repetitively, you've identified this repetitive task and you automate those. So in the concept of like what we do at open source, we identify every time we want to cut a release, we cut a release every single time there's a merge pull request to the main branch. We built that automation structure, and everything we use right now today is open source, so you're more than welcome to jump in the code. I'll give you some repos later, but can't actually show every single part because I only have limited time to talk through that. But one of the repos I mentioned inside the open source org is the Explorer. So Explorer is basically a way for users and contributors to get an idea of what the data looks like on our Explorer page. So this is our automated process of how we deploy a new version of the new Explorer page every time we merge a branch into the main branch. So we start with we build the application. So that's one of our jobs. We also put that into a container. And then we deploy that through releases, bundle it down statically, and then deploy that through GitHub pages, actually. So that's our choice and infrastructure for this project. But this is sort of give you like a mental idea of what's happening as far as the release process. Now, all GitHub Actions you can find, if you're using any of them, you can find in a tab inside of a GitHub repo. But inside of the code itself, all it is just YAML. So I'll show this one briefly, but the YAML here is triggered basically what I mentioned before, every time there's a merge or a push to the main branch. So going back, pull requests themselves, these events that get merged into the main branch, they trigger the actions that I mentioned before. These actions also trigger an event to the Cloud Runner. So all of GitHub Actions compute is actually hosted in the cloud. You could also self-host it if you like. So there's pathway to host that on your DigitalOceans or your Azure or AWS. I choose to host on my infrastructure with GitHub Actions specifically in their Cloud Runners because we're doing open source and it's free. And then this is just an example of our logs that we get. Because we're hosting it, we can see the logs directly when we have our static build that gets hosted up in the cloud. We did actually switch projects here, but this example is our docs page. It still has the same structure as well, also open sourced. So I really quickly wanted to talk through another concept and how we sort of release using artifacts as well. I live stream on Twitch every Tuesday and Friday. And I've built, as every live streamer, any sort of live coder on Twitch, the first thing you do is you build a chatbot. It's kind of like building your lightsaber if you're a Jedi. And so I built a chatbot years ago, and I've been updating it on stream a lot of times when I'm fixing stuff while I'm still live streaming and showing other stuff. But what I'm getting at is there's this one tool, my original chatbot is called Slaybot, which is, actually it wasn't the original. My original was called Baybot. But Slaybot is like Baybot, but it slays is literally the tagline I have in there. And the idea is every time I make a change on stream, I actually upload a bundled version of the Slaybot up into the cloud or into a GitHub artifact. Now, this is what our sort of build release pipeline looks like. So I actually have a check to say if this is just a pull request or a sort of preview or staging environment, I will build pull request into a staging environment. But if it gets merged into the main branch, I will build that to production. And that's what this little fork in the road looks like. Now, we deploy these GitHub packages also using GitHub Actions. I know this is like really a GitHub heavy way to automate release, but the beauty of this is it's all built in, especially if you're using open source code for your platform. This is what it looks like for our GitHub package. It's also going to be available in the packages tab. And the one thing I did want to mention is the option to generate release notes. So this is the one thing that I wanted to spend a little more time in and take some time to really explain. Release notes is like, it's the bread and butter for really understanding and sharing communication around what's happened previously in your project. So for that reason, every time a release is cut in open source, we generate a change log through automation through these GitHub Actions. And we do that purposely so that way there's a sort of breadcrumb for folks to understand what happened prior, or the sort of prior art, what's happened in our project. Now, when you cut a release, you go to this tab where you generate a release. So if you haven't done this, there's a lot of documentation around this on GitHub. But you generate a release inside your repository, and there's like this new little flag here. And currently it's actually in the bottom right over here that auto generates release notes. Now, I point this out because we automate our version, but I did want to point out that you could do this yourself automatically. So automatically add all the markdown for merge pull requests and the diff. So what this means is every single change that happened from the current tag, which in the concept, I think a lot of folks use Git these days, but the concept of Git, you have tags between today's tag that you're creating and the previous tag. You can show all changes through commit history and then generate that markdown. It's once you really think about how programmatically Git sets everything up for you to be successful, you kind of understand how this is actually, you can automate this pretty easily. And this is what the output looks like. Here we got some markdown that kind of shows the first commit. It's sort of cut off a bit, but you can see Sam has a commit to the docs. Below there, we've actually got, I'm sort of blocking it, so apologies, but below there we've got the docs for all new contributors, which is exceptional. But I want to point out, not only can you do this just clicking a button inside the release tab, you could also do this specifically automating in your YAML or your workflow. So specifically, and I'm cutting this off again, but it just says generate release notes and then flag true. What this is doing is actually running some automation using the GitHub API. And now, reminder, the GitHub API is one of the other primitives of the GitHub Actions that is provided by GitHub. And you don't have to set up the API manually or anything like that or pass any tokens. You get a free token, and I say free token. Nothing in this world is free, but what I'm getting at is that you get a GitHub token that you can leverage out of the box. As long as you're leveraging that up the line above my head, you can then also turn the flag on to generate release notes every time you cut a release or publish to the main branch. And that's our workflow. This actually, ultimately, what's the beauty of this is when you cut releases on GitHub, you get distribution of your project to everyone who's following you as a developer or you as a organization. So organization is open source, 100% open source. This is how we do announce features, is through our releases. And we have a lot of folks, about 300 people who are following specifically just the code of our project as well. So I bring that up because if you're looking to take action, we've actually got actions just like these in open source. They're all public and open source. You're more than welcome to go through and discover how we leverage actions in our project. Again, open source is open source, so like we're more than happy to get feedback, open issue, or ping me and have a conversation. I also wanted to point out that one of the projects that we actually created a couple years ago, which is hotopensauce.pizza. It's a free and open source project that we put together with a bunch of community members for discovering up and coming open source projects. Now, all the data that we source to get up and coming open source projects is actually powered by the previous repo, which is the Actions repo, that populates this list of up and coming projects. So it gives you the ability to upvote and source ideas for projects that are looking for open source contributors. So sharing that in case you have any interest. Also sharing the fact that I mentioned open source a few times. Check it out if you're interested, and if you're an enterprise that is looking to get involved in open source or looking for contributors or growing community, maybe you want to do a hackathon. That's what we do. So we'd love to have a conversation about that. And as a reminder, I'm the Beyonce of open source. Again, no time to talk through that, but definitely Google it if you're interested. And you can find me on Twitter if you want to chat about more things about releases and automating things throughout your platform. So appreciate your time. And a reminder to shut up and jam.
Hello. Today I will be talking about how your new internal development platform will benefit from treating it as something like a startup, so you can achieve the goal of scaling digital delivery for your organization. Now, thinking like a startup, it is about recognizing that building your internal platform is only part of the battle. You need to get market validation. You have to ship something that is perceived as valuable and useful for your customers. And for an internal platform, your customers are your internal development teams. So you need a marketing pitch. You will be repeating it over and over because you need to convey your value proposition of reduced operational cost, how you can gain speed and agility through the standardization and the services that you provide in your platform. And ultimately, you want to aim for getting an internal development platform that acts as a flywheel that accelerates your journey more and more by each individual feature that you put into it. My name is Jon Skarpeteig. I am the tribe lead of the global platform tribe at Signicat. Signicat is a software as a service company. We have offices all over Europe. The headquarters where I sit is in Trondheim, Norway. And last year, we also made it to the 1,000 fastest growing companies in Europe. We provide compliant onboarding, electronic signing, secure login with the highest level of assurance, which means we cater for regulated industries, financial institutions, government, health insurance. All right, so you built your new internal platform. You got your teams in place, you created something you think will be useful, and you shipped version 1, and we're done. This illusion that if you build it, they will come, doesn't really hold true. If you look at common reasons for why startups are failing, you will see that a lack of marketing or a lack of getting a product market fit, getting something that your users will find useful, is the things you want to focus on. And for a new internal development platform, you might have a new way of working with the team autonomy. You build it, you run it. It might be a new architecture of microservices. You might have a new technology paradigm where containerization and cloud native becomes issues. And this should not be treated lightly. For someone that is familiar with a different way of working, a different set of technology, this is a barrier to enter. So you need to be aware of this. So you need to do a lot of product evangelism. Now, you will have some early adopters that are just excited about this new technology. This is not your challenge. Your challenge is the other group that is kind of sitting on the fence. What is this about? How will this help me? So one trick you can do is to identify one or more reference customers. Typically a group that will work with you and be the advocate as well for using the platform. And you want to do whatever it takes to make them successful. And any learnings you get on the way, you want to roll them back into the product, which is your platform, to ensure that this one really solves the need of your reference customers. You want it to be loved by your reference customers. Don't make it so generic that it's just loved by no one, and it's not really great, because what you want to aim for is viral success stories. So any resistance to change can evaporate. But be a little aware that throwing too much all at once is a challenge. With all of these great new technologies, all these opportunities, all of the things that you offer and use in your platform can be a bit overwhelming. So you want to be the shield that protects a little bit, so that the teams can relax and generally have a good time for it when starting out. Now, one of the advantages that you get with platform engineering is this concept of the platform as a product. That means that you can leverage product management techniques, which have books written about it, and it's a lot of inspiration you can get and how you can leverage that, how you can understand the value that your customer is looking for. And if you find that what you have made does not align with what your customers, your development teams actually need, you need to change, because the customer is the one that will be using it, and you need to react to that. Of course, you have some basics that you have to have in place. If you do not have your guarantees of security, compliance, and reliability, you will not succeed. But for other features, you can use a very useful technique called product discovery. Now, this is where you evaluate your new wonderful idea on how you will make everyone's lives easier. Then you evaluate the risks of introducing it. I mean, the risk here is if it's just wasteful, because if nobody's using the feature, if nobody's using your platform, it is waste. So somebody must find it valuable. They want to use it. It has to be possible to use it. The people are able to figure out how to use it. And it has to be possible to build it, obviously, otherwise you can't make it. And finally, you have to address the viability risk. Is platform engineering the group you want building this? How does this fit with the overall strategy you have with your internal platform? Does it fit? And your opinion on this is not enough. You need to collect evidence from the ones that will actually be using it, from your customers. You also, of course, need to market it. You have to explain what the value you provide, how do you help your customers, your dev teams. And it also is about getting people on board. How do they get started, getting the documentation up to speed. And it has to be as good as you would have made it for paying customers. It is the same experience you want to aim for. You have one advantage with this being an internal platform, is that the customers is your internal teams. And hopefully you will know your colleagues, you will know your organization, you will know where they hang out, you will know how to reach them. At least the things that are happening inside of your organization already. Internal wikis, be sure to put your information up there. If there are any product catwalks, forums, present your solution, present your platform as a product, brag about it, be proud. And one thing I found very useful in conveying a lot of information in a short amount of time is visualizations. Getting your logos right, getting some architecture diagrams, getting something visual to represent what you're offering, and be sure to distribute it, get it into the hands, be visible in the organization. This has some advantages. One is to, of course, drive adoption, but it is also about ensuring you avoid duplication. Because if people don't know that you're offering a specific feature or service in your platform and they need it, they will build it themselves. So be visible, and marketing, it kind of never ends. It is a key thing to get the outcome you're looking for. Eventually, your platform matures. It gets out of this minimum viable stage. It is stable, it is perceived, and it's generally useful. And you have actual revenue generating products on the platform. And you get the good adoption, and you kind of focused more on the long tail, the smaller groups, the ones that haven't really migrated yet. And you will notice that your efforts is no longer front and center of the organization. Your efforts will fade more and more out of sight. If you worked as a sysadmin long enough, you will probably recognize what I like to call the sysadmin dilemma. Because when everything works, your infrastructure is up and running, everything is progressing nicely, nobody notices your work. And you get your budget cut, because what's the point? Everything just works, right? When nothing works, everyone do notice, but, well, nothing works. So, well, you get to be the hero, which feels nice, but that incentivizes more problem creation than problem prevention. You don't want that. You absolutely want to incentivize problem prevention. And what you want to aim for is the flywheel effect. Because getting off the grounds, creating a new internal development platform, it takes a lot of efforts. It is heavy lifting. And it takes some push to kind of get it started, get the thing rolling. But after a while, you will see that it kind of rolls on its own. If you get kind of the breakthrough speed, it kind of almost builds momentum by itself. Because you will have a delightful software delivery, you have your continuous deployment pipeline, it's well documented, it's like a golden path. Obviously, this is the way to do it. And you get more and more people to do it, this wonderful path that you have paved. And when you have fewer ways of doing things, you get standardizations. And with standardization, there is less things to worry about, and you get to put more effort into fewer hosting providers. So you can actually leverage your marketing power, and you get economics of scale. And with economics of scale, that means also that you can operate more efficiently, you get more free time to even reduce the operational cost even more. Now, if you are able to get a 1% less work for every single developer in your organization, it will have a huge impact for the organization overall if you have a large crowd that is using your service. And with reduced operational cost, that means your development teams can spend less time worrying about it, and they can spend more time focusing on solving paying customer problems. And your platform teams can invest even more time to make an even more delightful delivery cycle, which drives standardizations, which drives the economics of scale, and on it goes. Now, to make sure that you kind of get an accelerated speed, you need measurements, you need your KPIs. One set of metrics I can recommend is the DORA metrics, which is measuring organizational efficiency to some extent. It comes out of Google research. It's quite nice. You should check it out if you're not already, because then you can see what your efforts actually produce if you're getting these accelerated results that you're hoping for. So you improve your documentation. Did it actually help? Do we get better metrics? The self-service initiatives have launched. Does it help? Because you want to optimize for outcomes. How your group or the internal development platform helps the overall organization. That is the key. That is what will make you successful. Thank you for watching. That's what I had. I will be sticking around for the PlatformCon to answer any questions, or if you want to reach out, please don't be shy. Hope to see you there.
Hello and good day. My name is Chuma Obi. I know it's a cool name. Welcome to PlatformCon. I hope you're enjoying your conference. A bit short on time. It's a 15-minute presentation. There's a lot to go over, so I'm going to go straight into it. Now, I'm going to be talking about Open Policy Agent, OPA, and how we've actually used it to alongside with Terraform Enterprise. All right. Awesome. So in this talk, I'm just going to cover what OPA is, the general objective of what we wanted to do and accomplish here, the existing controls that we had prior to introducing OPA, our OPA approach, the workflow that we actually put into it as well, and a slight demo for you. This demo is pre-recorded. As you would know, demo gods are rarely ever on your side in this kind of scenarios. So trying to bypass the demo gods and have a pre-recording for this to work. And I will not be taking questions for obvious reason because it's a pre-recorded demo. And yeah, without let's talk again short on time. Let's get into what this looks like. All right, so introducing to OPA. What is OPA? Open Policy Agent is an open source general purpose policy engine that unifies policy enforcement across stack. All right, it provides a high level declarative language, Rego, that lets you specify policy as code and offload policy decision making from your software. If that doesn't make any sense, it's fine. If you're new to OPA, if you're new to this entire security structure or actually this control structure, please don't be mortified by that. All right. So, like I said here, counting in the slides, if you've never heard of OPA before, all that stuff I just said doesn't make any sense. All right. So let's start off bit by bit. What is a policy? Policy is literally what that is. Like, right? It's a set of think of policy as any law enacted by Congress, right? Like as any house in the body that you are familiar with. So in this situation, though, as a developer, you are Congress. You have a set of rules that you want to govern a certain behavior for your platform or your software. So what does OPA do here? OPA is basically a policy engine that you can entrust to implement and enforce those policy decisions for you, right? OPA is many times confused as a security tool. Yeah, it's here to improve security in this ways, but while it's allowed to, while it's definitely used to improve security, as you would see in this demo, it's capable of so much more. Why did we choose to use OPA? OPA is super lightweight. Is ubiquitous because it can be used as a library in your code, like Java, Python, Golang, all of it. It can be used as a client server with OPAL, OPAL. It can be used as a sidecar in the Kubernetes. It can be used as a daemon set in Kubernetes, a gatekeeper library. It can be used literally in the repo. It can be used in the CI. There are multiple plethora of ways it could be used. So it actually makes it added benefit to why we can use OPA. All right. Policy decoupling. OPA also allows you to take the load of implementing policies off the service or the software and allows you to ship things faster. So think of when you have a JSON or you have a JSON that your app has to vet, and the JSON attributes has to have everything required for your app to work. Any introduction of a new attribute would mean remodifying and redeploying your code. If you move that decision making off to OPA, your code stands. It becomes a layer of gates before, your platform or your service is introduced to that. So it takes care of the policy decision for you, right? Without having to modify and redeploy the source code. Awesome. So what's the situation that we have in our hands, right? We have a multi-tenant GCP environment, and it is managed by Terraform. Terraform Enterprise, as I stated before. Now, in a multi-tenant situation, how do you ensure safe practices while remaining flexible for your tenants, right? Now, the first approach we had on it is have SR replay gatekeepers, right? We thought that was a good idea. Makes sense. If anybody's trying to introduce any Terraform changes, we vet it, we say it's okay, and they can be introduced. Now, for obvious reasons, there are downsides to that. One of which is massive toil on the SRE team. We've seen our SLOs, or we saw our SLOs rather, grow over time from the implementation of, hey, we're the gatekeepers for you, to over the years it went from, yeah, we can get back to you in a couple of hours, to, yeah, we can't get back to you soon enough. There's so many of you put in requests at any point in time, right? What that means transitively, again, is we've become the bottlenecks for development. Right now, we're actually stifling innovation at that point because we couldn't keep up with the requests. Now, you can go hire more members to just sit down and vet, Terraform changes, or you can automate it in a certain way. Now, even if you hire more members, it is prone to human errors, right? And we actually saw a case of this where a new member to the team wasn't really familiar with the process and was entrusted with the keys to the kingdom, and nuked hundreds of pop subs, right? And left like 4 of them. So yeah, it's not an infallible solution. So we needed to find something quickly, and we opted for OPA. So what was our objective? Our objective is to minimize toil as much as possible, right? As much as we can to elevate that toil from on the team, so we can actually be focused on all the things that we have to work on. Keeping security a priority, obvious reason. We have TFE, Terraform Enterprise, which is handled by a whole team in Home Depot to implement Terraform in all the spaces across multiple teams. HashiCorp uses Sentinel as its own policy engine. That's also going away. HashiCorp, not so recently, actually a while ago, has opted to also go for OPA, right? So, but in the current structure that we had at the time of, this is an MVP approach. We've grown past this, but I'm just showing the MVP approach. But at the time of implementation, TFE went with Sentinel for a company-wide security posture, and then we also OPA as an added security posture as well, as you can see. And it also introduced flexibility to the model where teams are actually able to do a lot of things and keep going without us having to, stifle them from innovation. So the existing controls, all we really did prior to OPA was basically saying branch protection on the main branch, right? And code owners, where our teams are the only ones allowed to basically approve pull requests. And every pull request has to be approved by the team before it can go. Otherwise, it's not going anywhere, right? So our OPA approach brought in deny or warn policy. So that for the MVP approach, again, we've grown past this. All we did was introduce multiple resources. We're a GCP shop, so multiple resources that team have frequently, kind of requests to do and attach weight to it. So we just kind of used our experience on having to review multiple pull requests and Terraform changes to basically ascertain what the weights are. So if somebody's trying to create, update, or delete a PubSub topic or BigQuery table, etc., we want to assign weight to it, and then also want to start modifying the blast radius. So in the case if somebody wants to delete a PubSub topic, that is over the blast radius, so we're not going to let them do that. But if they want to create a PubSub topic, it's fine. If they want to create 5 of them, it's also fine. But if you want to create a 6th one, we want to also vet what that is, right? So again, MVP approach, we wanted to see how this was going to work. And, we don't want to over automate it because, well, we weren't sure yet. We wanted to make it operationalized and make sure how it works. And this was a really good first introduction because it's alleviated our toil by 25%, which was impressive. And we've actually gone on to alleviate set toil even further with, other means at this moment. Cool. So our journey for this, I'm going to, for the sake of time, if you're using Terraform Enterprise, please understand that with having a remote backend gives you a limitation because you require a structured data in the form of JSON, in this case, to be able to pair it up with OPA, the policy that you've written with Rego, to be able to kind of make a decision, right? So Rego is written to be the declarative decision, declarative language for OPA decision making. but it also needs data to basically say, oh, this is what's coming in. I'm going to make a decision based on the data coming in. So it's a huge limitation with the remote backend from HashiCorp/Terraform. We had to work like our way around it. We stumbled massively for multiple ways that I can't really get into for sake of time before we can actually get to our location, right? So what was our approach? We allow some that basically has like very little changes and fall into the approved list. And if we are unable to determine like the automation, if it's as easy, if it's ambiguous, we kind of leave a warning for it and leave it for manual validation by a human SRE member. And then some that are security threats are basically going to be flat out denied, right? As I will show you momentarily. Okay, so how we have the workflow going now, a pull request triggers Jenkins. Jenkins goes over to Terraform, pulls out the plan from that pull request, and then the plan JSON is combined with the policy rego, and from there, a decision is made on either success is easy, is slow, keep going forward, you're fine to go. There's a warning that waits for a human validation, so we've got SRE team, or it denies you and tells you what the reason is and we're fixing something in a PR. All right, awesome. I'll just get into the demo real quick. No time to waste. We're short on time. So again, pre-recorded, so I'm just going to show you what it looks like. Now, we're going to talk about auto approval, right? So I'm going to make a code change on a pop-up topic. Very easy, just creating a pop-up topic right there, max attention, blah, 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 all of it. Cool. Raise a pull request based on that. And that triggers a Jenkins, comes back, you can see the approved list. Pops up topic has a weight of 10. So I'm just creating one which is well less within the blast radius. And it says everything's fine. And from there, right, your pull request is automatically approved. It actually even tells you, hey, your pull request is automatically approved because, it's low risk. We don't care. Just go ahead and just run the app button apply, and you should be good to go. All right. And next up, we're going to talk about the warning. That's simple enough, easy peasy. That's what we want for that to happen. And the one situation, in some spectrum of things, we don't know what's happening. As you can see in this place, someone is trying to delete an IAM member, and that could be potentially dangerous. I mean, at that point in time, we hadn't automated enough of the stuff, and it tells you, hey, I'm going to wait and pen for manual validation. Now, you can see right up here as well, telling you, hey, the warning, the resource changes to that particular resource, Google pops up subscription IAM member is significant and cannot be auto-approved. Contact an on-call member to kind of vet it manually. Pardon me, I'm not sure what's going on with my voice here. Simple enough, straightforward. Yes, it requires our human intervention, but not the end of the world. It's actually alleviating a massive amount of toil for us, right? Once validated, we just come in and click approve, and everybody's good to go. We're one big happy family after that, right? Next up, a flat out denial. Now, if you are used to Google IAM, right, like what happens with binding is if there's an existing binding of a role to a set of entities, if you introduce that set of, similar set of binding to the same role with new entities in a different code, Terraform isn't aware. What happens is the previous bindings gets nuked, right, and the new bindings take place. So if you had 7 entities bound to a role, and you didn't know about it in the Terraform code, and you come and introduce a new entity to the same role, the previous 7 entities are gone. So we were bitten with that before. So what we had done was to actually kind of pull from the plan, make sure that all the bindings are, are set, and if any new binding is introduced, it's going to stop anybody. As you can see in the deny role, it tells the person, yeah, this role that you're trying to, have a binding to is already utilized by another binding called Google Prototype IAM binding KMS admin. Any changes to this rule would wipe out the members already bound to the resource. So it became a way of us to have an added security. And honestly, this is also kind of eliminating that human errors spectrum, because we wouldn't have a way of actually vetting all the code and knowing if it previously existed, right? So it became a massive improvement and on our policy structure. That's the end of the demo. The last thing I want to cover that anytime we introduce a new rule, anytime we introduce a new policy, we also have unit testing that we've actually added there. It's like Open Test allows you to run a test scenario per unit test of what you've introduced to make sure that all your policies succeed as intended. I know it's short on time. I hope this talk has been helpful to you, and I hope you enjoy a good time. Enjoy OPA, exploring OPA as much as I did. Heads up, Rego, it's not a very intuitive language to get started with, but once you get accustomed to it, it's one of the easiest declarative languages you ever get to play with. Thank you so much for your time. I've had so much fun talking to all of you, and enjoy the rest of the conference.
Well, hi, thanks for coming to my talk. I'm going to go over, I guess you could call them best practices and ways of getting your platform started inside mostly a large organization that I've been lucky enough to talk with and study from platform teams, what we would now call platform engineering, over the past 7 or so years or so. Now, just briefly to introduce myself. Hi, this is me. I'm Kote. Like I was kind of alluding to, I'm pretty lucky in that while I've been at Pivotal and now VMware, and as previously as an industry analyst and other things like that, as a programmer long ago, I've really gotten the chance to talk with and study how organizations do software, improve it. And I'm always very interested in the human side of it, I guess, the culture, the process, the management, the strategy thinking. And as you'll see, sort of like the way that people organize and things that they do, not just the technology that they have. Anyways, if you're interested in that kind of stuff, you'd probably like the newsletter that I do nowadays at newsletter.cote.io. I have podcasts that I do as well, one called Software Defined Talk. You can go to cote.io to check all of that out. So first of all, let's start with what a platform is. Now, I'm sure you have a pretty good idea of what a platform is since you're attending PlatformCon and have seen many of the other talks. But I think it's a good opportunity to kind of check in to orient yourself around what a best practice of doing a platform engineering is. So if you look at these two diagrams, one of them is a newly released white paper from KubeCon EU from the Cloud Native Computing Foundation. There's a working group there working on what a platform is. But if you look at the other one, which is one that we at VMware have, you should get the notion that both of these are essentially application runtimes, right? It's the collection of middleware, the services that application developers use, things that you need from other stakeholders like security. But it's a way of tying together a whole bunch of things into that, again, that application runtime, that stack that your developers run their stuff in. Now, the main thing to notice here is that you have a platform for software developers. I think when we get excited about talking about a platform, we kind of lose a little bit of focus on that, not very much nowadays. But you want to think about our job is to build up that stack and curate that stack of stuff that the developers need, from the middleware services to even the build pipelines that they're using, the way that you're making sure things are secure, all your buzzwords like secure software supply chains and things like that. And the thing that I think is evolving here, I don't think it's quite sorted out, but I think what I've learned over the past 7 years, one of the critical things that we can pull forward into the kind of cloud native, the Kubernetes way of doing a platform, is that your platform engineering teams really aren't going to have a lot of time to worry about the infrastructure underneath, right? And you see that in both of these diagrams where there is cloud infrastructure under there. Nowadays, a lot of what people want and what some people use is Kubernetes. But it's not really part of the platform, is kind of the position that I've developed over the years and observing platform teams over multiple years do this. And if you think about that, that makes sense. If you've got all this middleware, all this stuff developers are using, I think you're going to find that your platform engineering teams are not going to have a lot of time to worry about building and running and managing their own Kubernetes platforms, right? That's a lot of work just to take care of that on its own. And hence, you're going to see, as I see in surveys more and more, that your platform engineering team is really focused on just that platform part. So what follows after this, what you should be thinking about next, is that there is that there is a big focus on developers. And this is an orientation that's especially good to bring forward and go over with infrastructure and operations people who are kind of used to building that infrastructure layer. And that is, instead of thinking about delivering the platform, delivering services, even delivering all of your nines and abilities, ilities, and things like that, which you certainly do need, but more you're reorienting yourself to think about the customers as developers, to even think about customers. And you rethink this in what you're doing with the platform into building a product, right? Now, this notion has come to the surface with a lot of platform engineering talk, and it does so because it's very important to always think about the point of the platform is to think about the developers that you're supporting, that you're building this product for the developers' needs. And as you can see, Thomas here, who's been running a platform team, he's been a product platform owner at Mercedes-Benz for about 7 years. I think that's where I got the 7-year thing from. It might be 7 or 8, depending on how you count it. But that's, as he says, you have to have this orientation, again, to support the developers. So the first thing is to think, how do we start thinking about developers as customers? Now, if you're building a product, right, this is something that us vendors know a great deal about, or people who are selling technology as its own thing. What you're doing is you're product managing that product, right? Again, you're not just delivering infrastructure to spec or kind of just like setting up even like a cloud or access to things. You're not just delivering tools. You're studying and thinking about what the developers need to be successful, not only using your platform, but just to be successful with what they're doing. And so that's where the practice of product management comes in. So product management, thankfully, or nicely, if you're getting into platform engineering, is a very well understood, very mature, very tested out methodology for doing things, right? And you can get a little sense of what goes on in product management here. There's a great guide for it. I guess you can't click now, but if you can look that up or click on the slides that you might get, you can get a very real sense of what product management is and how you do it. But essentially, you have a person, a product manager, and their goal is to always think about what it is we're going to do next in this next release, which I always recommend even for a platform being on a week or every 2 weeks. What feature or features should we prioritize so we put that in the release so that it helps our customers out, helps our developers out, right? Now, this means, of course, that the product manager is familiar with developers. They know the issues that they have, the problems, but they're the ones who are always thinking about what is the best set of features we can have in this release that will address the most important things that developers need. Now, of course, they're also thinking about weighing all sorts of options like the security needs you have, the compliance needs, whatever constraints or opportunities you might have, whether it's, whether you get to run everything in public cloud or you need more air-gapped environments. But the platform product manager is constantly thinking about how do we evolve this platform? How do we prioritize new features? And how do we work and understand what developers and other stakeholders need? And speaking of that, how would you find that out? Well, once again, there's a lot of things that over the past 7 years that you can look at to help you product manage the platform, to think about what's in there. And the first one, and this is key to understanding not only your customers, the developers, but like the process that they exist in, what they're doing day to day, and then also the area beyond the developers, right? So if you're making a platform, I keep saying you support developers, but what you're really supporting is your organization's software factory, if you will. The process that it takes to go from an idea to a person using the code to supporting whatever your organization's goals are. And the first step, even if you have done this before or you have some diagram on the wall, is to go and make a fresh exploration of the complete end-to-end process. Everything it takes from idea to someone using the code. And this is going to be, you can think of it as a pipeline, a value stream, a secure software supply chain. It's not actually that last thing. People will say value chain a lot, or value stream. But it's important to go through and find out what all the activities are, all the different people involved. And also, I almost think more important is figuring out those arrows between it, right? Because it's these handoffs and moving from team to team, box to box, that really is going to be where you are probably going to find opportunities for improving that flow, making it run faster, having better fidelity and better quality running through it. So think about almost, even though you're in charge of the platform, also think about you're in charge of this value stream, of this process, and think about what you're doing in the platform, how it can help that whole value stream out. And I think this is why in platform engineering, we see people moving way beyond just the container level, the Kubernetes level, the infrastructure level, and looking at how even beyond the middleware and services they have, but looking at the tools that developers use. Things like the internal developer portal, right? Like how can we use something like Backstage to have a better platform, a way of communicating with all of the various parties, handing things off, discovery, all of that, right? So once you have this as your scope of responsibility, it will really allow you to figure out how to improve the platform. Now, the next thing you can focus on, I helped us publish this last year. Just helps with the publishing. I didn't come up with this, but if you want to find things you can help developers with, to use an SRE term, you can find the toil that they have. So to do this, this is totally free and easy to use. You can just put it into Google Forms or Office 365 forms, or I don't know, send out some Scantrons or something. But it's a developer toil audit that doesn't take too long for developers to go through. And I guarantee you, they will be happy to tell you about the toil that they're facing. But they'll go through and fill it out and rate it on a scale of 1 to 5. And you can imagine when you get that back, you can just sort it in a spreadsheet and you can start to systematically go through as a product manager. You can decide which of those things you can prioritize to fix. And then you can go back again and survey them with the same things, and you can see if you've improved that. You've got a feedback loop in place. So you're testing out if the features that you're adding, the choices you're making in your product and your platform are helping out. Now, next, something that people skip over quite a lot because it doesn't really seem like something that we do in IT, you do in operations very much, but is very important. And this is one of the things I've noticed over and over again over the past 7 years or so, is you're going to be doing a lot of marketing. That's right, like internal marketing, platform marketing. You'll even come up with a name, a brand for what you're doing. You'll definitely, I would recommend right from the beginning, right when you start, you have one person, one role, one person fully dedicated to being the platform advocate. And this is the person that does a lot of that initial branding, does a lot of the kind of what we would call developer advocacy, like the team that I'm on. Again, something us vendors are very good at doing and have practiced doing for a while. You know, something we can help you out with, or you can just look up on your own. But you'll have these people who go out and they not only consult with people, but they're thinking about building that community. And they do things like every 3 months, you're going to want to run an internal conference where you share amongst your developer community, your platform community, not only like training in what the platform is, but again, this is like how marketing works. You want to get the peers of other developer groups who have been successful with that platform to talk about what they're doing with the platform, how they used it, what worked and didn't work, right? And marketing, again, is all about raising awareness, but also building up trust that the platform that you have is good and effective to use, right? A lot of times people struggle with, we put a platform out there, we put a Kubernetes thing out there, and the developers didn't use it, right? And I would suggest that's partly through a lack of having marketing. Also, probably because they didn't product manage it that well. You know, the question I often ask is like, well, how often do you talk with developers to find out what would be useful for them? And this practice, as you can see from the various people like Mercedes and BT and Allstate and Duke Energy, it's used over and over again in the platform groups that I see that are successful. Now, let's end with the 2 phases of rolling it out, right? So in the initial phase of doing it, what you'll be doing is you'll probably make a great choice of the platform that you use, that you build up there, right? I might have something to talk about with you there if you're interested, but there are many options out there, right? But you choose a platform, you're going to put it in place, and your first idea might be that, like, now let's get 20 teams on it, but you need to really slow down because you're not only learning about the technology, that the developers are not only learning about the technology, but you're learning how it fits in your organization, all the particular needs that you have. You're discovering all those little hiccups and barriers and hurdles along that value stream. So you want to use one initial team, go through an actual release of software to production over like a 3-month course, and use that to discover and explore how you run the platform, how you structure your organization, the various things that you're going to do, like the toil, all those sorts of things you do with that initial team. And this also builds up a great marketing asset, that you were successful with doing this with one team. And if you're not successful, just kind of sweep it under the rug, ignore that initial team and try it again, and build up a successful one that you can start to do. Now, after that, one of the things that you do with this initial team is you've identified, let's say, kind of empathetic, sort of people on your team who would be interested in going into this next phase. As you get 2, 3 more teams, you seed these people into the other teams, right? And you pair up, whether you're doing pair programming, pair product management, you do pairing on these new teams, and you pair them with these experienced people. And once you rotate the pairs, you start to have people working together and exchanging knowledge. And what they're doing is they're training each other, but they're also exchanging the trust, right? They're developing that word of mouth and trust in the platform amongst the developers. And then you can imagine as you scale that up more and more, right? I don't do math very well. I have a philosophy degree, but you scale that up more and more, and you have more people. And you, after about a year or so, you can start to get to like, I don't know, 10, 15, 20 teams. And year over year, month over month, you can add more and more people to help out with that. So if you're interested in more of how a large organization has been successfully doing this, especially the advocacy part, but also just the platform as well, you should really check out this talk from Nadi at JP Morgan Chase. It's a great overview of how they're doing things and a lot of tips that you'll get there. So with that, thanks for attending this. I hope it was helpful for you. If you want to get, there's even more details, a longer version of this, or just kind of check out what else you can learn about how large organizations are getting better at software, you can follow the links there, just check things out and enjoy the rest of the conference.
Hi everyone, I'm Suza and I would like to talk about how to eliminate config drift between environments. As part of my presentation, I want to dive into the problem space first, and then of course also discuss how a solution could look like. As part of that, I'm going to talk about Score, an open source project I've been contributing to. So let's dive right in. What do we mean when we talk about config drift between environments? Config drift is just one of these terms that can mean a lot of different things depending on the context you're in. So for this talk, I want to refer to config drift as inconsistencies between environments that run on different platforms. Just to give you an example, you might be running your workloads locally with a lightweight tool such as Docker Compose, while then deploying to a platform orchestrator like Kubernetes in a remote cloud environment. The problem here is that a developer who now wants to promote their workload from local to production in this scenario also has to be familiar with the platforms in place. In this scenario, it's Docker Compose and Kubernetes. And of course, any other supporting tooling along the way. So you might use Terraform to provision and allocate any required resources, or you use Helm to simplify your deployments to Kubernetes. The challenge here really is to keep your workload specification in sync along the way. If entities are configured differently across the different platforms that you deploy to, the risk of config drift increases. Maybe I'll give you a bit more of a concrete example. So let's say your workload has a dependency on a database. Locally, again, that database dependency might be resolved by pointing to a Postgres image or a mock server, for example. On its way to production, however, the database is now provisioned with Terraform. So making this transition happen can be quite a cumbersome task. And the fact here that production environments often require that extra bit of specialized knowledge or operational expertise is the reason for that. So taking a step back from the developer's point of view, they develop and run everything successfully in their local environment, for example, with Docker Compose, and they even pass the tests in their CI pipeline. The question for them now, of course, remains, how is that new database dependency I need or a configurational change I made going to be reflected appropriately in the next cloud environment, which might be running on Kubernetes, for example. And this question is answered differently in every team. And of course, it also depends on the complexity of the task at hand, right? So a variable change is easier to keep in sync and manage than provisioning a new database. So the issue here really is that we have no standardized approach when it comes to ensuring consistent workload configuration. And in practice, many things might happen. There might be that go-to ops engineer that you can reach out to, and they will help you provision that database or make sure everything's configured correctly after a change. You might dive in yourself, or you have a centralized ops team that you can create a ticket for, and they will help you out if you get stuck. Either way, the bottom line here is that if a property is wrongly specified or has simply been overlooked, the team will end up with a failed deployment, or also just a workload that's running in a way as it's not intended to. So now that we have a more concrete understanding of the problem space and what we mean by config drift, we of course also want to talk about solutions. And the solution I want to talk about today is called SCORE, as I mentioned before. It's an open source project that aims to eliminate exactly the problem I just talked about in terms of config drift. So, introducing SCORE, one spec to rule them all. SCORE, as I mentioned before, aims to reduce config drift between environments as one of its main goals. So, looking at what SCORE is in more detail, SCORE itself offers a workload specification that captures a workload's runtime requirements. So that means the SCORE specification essentially captures everything a workload requires to run. And the main idea here is that developers work with that single workload spec instead of juggling multiple platform and environment-related specs and value files. So looking at the spec in more detail and its characteristics, one of the main things that it offers is that it's platform agnostic. So it's not tied, as the name says, to a specific platform or a tool, but can be widely integrated. So that really depends on your tech stack, right? It might be Compose, Helm, Customize, ECS, really whatever you work with. The main point here is that the developer gets to describe their workload's runtime requirements in a way that doesn't require any knowledge of these platforms. The next item related to that is tightly scoped. So the SCORE spec describes common workload level items and thereby shields from the complexity of container orchestrators. Then, of course, it's also declarative. So the developer describes what their workloads requires to run, meaning it's like a cooking recipe or kind of a to-do list. And that essentially says, if you follow these instructions that I have specified, my workload will run as intended. So just to show how this looks in practice, as mentioned before, this is just an example SCORE file. So it describes common workload level items. So what we have here is a container with an image, container overrides, a dependency on a Postgres database, and also dependency on a second workload. Now, the idea is that this file is saved alongside the code of the workload in source control. So again, one file per workload, kind of establishing a single source of truth. And of course, now that we established a single source of truth, that's great. The entire team can refer to the SCORE file when needing to understand how the workload is configured and how it should run. But of course, it needs to be executed or put into practice somehow. And that's how we get to the SCORE implementation. So the SCORE implementation is kind of the counterpart to the SCORE specification that I just showed you. And what this means essentially is that the SCORE implementation is a CLI tool that the spec can be executed against to generate the required configuration. This required configuration that is generated by SCORE can then be combined with additional platform or environment-specific configuration to actually run the workload in the target environment. So this additional configuration was kind of abstracted away from the developer initially, but then to make your workload run, of course, additional configuration that is then platform and environment-specific is required. But it might be easiest to just show you how this looks with a graphic. As you can see here, we have the score.yaml file, our SCORE spec that captures everything that we need to know. And then we can choose a SCORE implementation. And this, of course, entirely depends on your tech stack. So let's say you work with Compose and Helm, you'll pick the SCORE Compose and SCORE Helm implementation. which accordingly will generate Docker Compose files based on the score spec and value files for your Helm chart. And that's essentially how SCORE aims to reduce the risk of config drift. Now, what happens here is that configuration is generated in a one-directional and automated manner. This means the team really has that single source of truth to refer to in terms of the score spec, and then the CLI takes care of translating everything accurately. Of course, by doing that in an automated way, making the whole process a lot less error-prone. So looking at the impact this has on the developer's experience, first of all, we're of course looking at pain-free local development. So developers essentially no longer have to worry about configuration inconsistencies down the line, meaning in remote environments that they're deploying to, as the configuration is generated from the same score file locally as remotely, meaning if your workload runs locally, it will also run remotely, simply because that main bit of configuration is captured in one separate file. Another benefit that's worth looking at is separation of concerns between dev and ops. So what SCORE allows to do is essentially establish a clear contract between dev and ops. So the ops team with the SCORE spec is provided with a comprehensive set of configurational requirements, which, if met, ensure that the workload runs as intended. So you could say that code here with SCORE is being passed through the fence rather than being thrown over it. Another point is making the acquiring of ops skills less urgent. So with that configuration work, that translation work being done automatically by the CLI, of course, that doesn't necessarily require in-depth knowledge by the developer. So that, of course, doesn't mean you can just forget about all the additional tools. Having a basic understanding of your team's tech stack is very important, especially when troubleshooting. This just refers to the fact that it makes it less urgent. If you're a junior developer that just started figuring out how to write JavaScript, Kubernetes might maybe not be the first thing on mind. So in that case, you could just trust SCORE to take care of all the complicated configuration work for you, and you can focus on your code for now. Related to that is also the next point, layered abstraction. This essentially refers to what I just said. You can stay on the top level with SCORE, or you can dive into the deepest level, for example, the generated Kubernetes manifest. So SCORE here really doesn't necessarily aim to abstract away. It's kind of instead trying to make the tools you work with a little more accessible for you. Exactly. So these are kind of the biggest points of how, if SCORE is adopted correctly, can improve the developer's experience. So looking at the details of SCORE, as I mentioned before, SCORE is an open source project. It was launched in November 2022, so it's still quite young. We launched it alongside 2 example reference implementations, Compose and Helm, that I just showed before. And last year, our focus was mainly on community growth, like getting the idea out there, getting feedback, getting people to play and use the tool, and also just understanding, does this make sense? Does the idea resonate with developers? And since that all worked out quite well, we're now focusing on improving product maturity and, of course, extending our suite of CLI tools. So we're really encouraging people to build their own CLIs or play with the ones we have and extend them if needed. That would be the next big step for us. But we also have a roadmap on GitHub. I'll just share the links here in a second. So this is the link for our GitHub repository that you're welcome to check out. We also have a doc site that you can find under docs.score.dev, and also our blog with a couple of helpful tutorials. Exactly. And that's already it from my side. Thanks everyone for listening, and I'm looking forward to seeing you all around at PlatformCon. Bye.
Hi, my name is Alex and I'm a Senior Staff Cloud Engineer at Mercado Technology. Today I'd like to share with you our journey over the last decade in building an internal developer platform that allows our developers to increase their autonomy and innovate at scale. I want to show you what we've tried that has worked and what hasn't, and also some of the general lessons and patterns that could be repeated from our product today. But before that, I want to take a minute to introduce to you who Mercado is and our journey to give some better context to the platform we've built. Mercado started as a pioneer in the online grocery delivery industry in the UK back in the early 2000s. Our first generation warehouses relied on a system of kilometers of conveyors, moving thousands of containers of groceries. We've completely redesigned that model, and today our automated grocery fulfillment warehouses use thousands of bots running on top of a three-dimensional grid of products. As we followed this journey of innovation, we've continued to evolve into a global technology company, and we now provide an end-to-end platform for online grocery to some of the world's largest grocery retailers. To illustrate the scale of our growth, we've deployed 19 of these automated warehouses, or fulfillment centers to date. In 2023, we'll be launching another 5, with more than 50 planned globally in the next few years. Since we provide our retail partners with a fully end-to-end solution, from e-commerce to fulfillment, logistics, and supply chain, we have a broad range of applications that will run on our platform. We have customer-facing, front-end web applications that are image and static content heavy, with cyclical request loads that follow daily and weekly customer shopping habits. And we have compute-heavy, RAM-intensive applications that optimize our delivery van routes. And we have real-time, low-latency wireless robotics control applications. And all this needs to scale during peak online shopping events, such as we saw during the global pandemic. We also have developers spread across the globe. We need to ensure they all have equal access to our platform and tooling. We want to avoid a situation where you know someone in ops and you draw some chocolates at their desk to make sure your tickets get to the front of the queue. Although we started from a single development center in the UK, the ratio of engineers working on our platform to the rest of the product engineers across the globe has always been in the low single digits, and we need a solution that will scale with the number of users we have. Even though we have that large diversity of application types, we want to try and simplify our tech stack by having some best practices and golden paths to follow. This makes it easier for new starters to learn, and easier for engineers to collaborate or to swap between teams. We can also make the platform more developer-friendly by releasing language libraries that make best practices repeatable. For example, we have a Java library that allows a developer to get a Java application with OAuth 2-based authentication deployed in minutes, with loads of features like health checks, logging, and monitoring working out of the box. If you'd like to learn more about our best practices for software development, we publish our developer handbook at the above URL. Although this talk focuses on the platform journey, it's a great resource for developers. So, around 9 years ago, we had this opportunity to redefine our platform when we started our migration to the cloud. Platform engineering wasn't a term at the time, but we started with a desire to achieve a few things. We wanted to be cloud native. We started just building a platform for those applications outside of our fulfillment warehouses, such as e-commerce apps, which were a great fit for the cloud at the time, as it was still a new technology to us. We wanted to embrace a DevOps culture and then the separation of developers from the practice of operations. And we wanted to build developer self-service at the center of our products. To enable this, infrastructure teams would act as software development teams, with product managers, agile methodologies, and prioritizing automation, APIs, web apps, and infrastructure as code over manual toil, ticket, and operational scripts. We wanted to use native cloud managed services over self-managed services, and all data and functionality should be exposed through service interfaces. Those familiar with the history of Amazon will see this as a bit familiar to Jeff Bezos' mandate back in 2002. By 2012, this had evolved into a core part of the microservices philosophy. With that in mind, one of the first products that became a core part of the platform was an application registry. In order to offer services to developers, we need to know exactly what applications exist, who owns them, and where they're deployed. We can also offer useful features like links to documentation and source code, dashboard, contact information, etc. Above you can see a screenshot of the UI, but everything is also always available over a RESTful API as well to support automation and integration. So one of the big decisions and debates in building the platform early on was whether the underlying runtime of the platform should be exposed to or abstracted away from developers. At one point, we had a Kubernetes platform running on premises that developers authored and deployed Kubernetes manifests to for every type of resource they needed. And we had an AWS-based platform that abstracted away details of the Elastic Container Service and the Relational Database Service to offer developers a minimal and simplified interface. This debate balances the autonomy of the user and the mental load placed upon them. Now, in my experience, developers do not want to have to learn more than they need to complete their daily tasks, like deploying an application or resizing resources like database. And in the end, we went with this abstraction model, meaning that we can precisely offer exactly the platform we want to our users and design its API around their needs. So having said that, one of the actions we've abstracted is deployment. So what does our deployment service look like based on our philosophy of self-service and abstraction? So we built a RESTful API and embedded it into our registry that would deploy an application for a user or a team. This becomes a huge benefit also if you do any audit or compliance activities, because you now have a central log of all production changes to, for example, check against your change management process. So to start deployment, a user just needs to make a post HTTP request to a URL that looks like this. And this includes what type of environment, such as development, test, or production environment, what business it's for, and what application ID it is. Included alongside that post request would be a payload. So this is the absolute minimum a developer needs to provide, which is just some JSON that says, here's my code. It's a Java application with this Java version, and we use default values for everything else. So they'll get a default value for things like CPU and memory requirements. And as a user becomes more familiar with the deployment tool, they can return to this simple deployment and add additional parameters to customize it to their needs. Now, behind the scenes, we're doing a lot on behalf of the developer. We're creating DNS records, load balancers, security groups. We're building and publishing a Docker image and creating an ECS task and service with auto-scaling. And when the application has been successfully deployed, the user will have a URL, which also has a corporate single sign-on in front of it. So here we can see a dashboard for my previous application of all the environments or applications it's been deployed to. So we can see things like the current health status. We can find out the URL. We can see what runtime it's running on and things like that. So alongside the idea of abstraction, we also had debates over how much access a developer should have to production environments. Now, on one hand, developers need to be able to support their applications during an incident. Some users were very used to having permanent SSH access to their production VM, for example. However, we found when we removed SSH access for security reasons, users did not complain and developed new workflows and ways to achieve their needs. As before, the solution is going to depend on your organization, but making restricted and temporary access part of the platform is something I would highly recommend. And in fact, we could use our product development discipline to find out what users actually needed beyond SSH when they were supporting a production incident. So another feature that we built into our platform to support this is the concept of approvals. So certain application changes might require an approval from an owner or a stakeholder. And a developer might need to request temporary access to a production database, for example, to support an application. Here, such requests can be made, audited, and access could be granted on the basis of an approval. It's very important for us also to be able to measure the metrics for our platform. And you can use these to drive our product development in addition to user feedback or feature requests. So we have some key performance indicators or KPIs. So firstly, the number of weekly code deployments we have, the average duration of a deployment, and the number of applications on our platform. And since there are many teams that maybe started off on a different solution internally and migrated to ours, we kind of want to check that these KPIs are trending in a positive direction, as one of the key benefits of building a service between your users and the underlying cloud infrastructure is that you can measure anything and everything. And many application teams are big users of observability tooling to better understand and monitor their business applications. We try to be the same with our platform. Often, a problem you might find with internal developer platforms is users are sort of obligated to use it. They have no choice. So it's really important to try and get feedback when you can, work out if people actually enjoy using your tools and if they would choose them over something else. Another key benefit of our abstracted platform is that we do have some ability to make cost savings without needing to have developers change their ways of working. Here we have an example of how we managed the underlying compute resources for our runtime. So spiky peak usage is fulfilled with a mixture of cheap spot market instances and more expensive on-demand instances. But the bulk of our stable committed usage is covered by a committed spend savings plan that most cloud providers will offer in one way or another. So we'd initially built a platform suitable for purely digital applications in the cloud, but what about the applications I mentioned in our physical fulfillment centers? So this is a more challenging case and an example of a potential platform customer that an out-of-the-box solution might not have been able to cater to. So a little bit about how our bots work. The bots are orchestrated by our proprietary AI air traffic control system to collaborate to pick customer orders. The bots themselves are not autonomous and do not make their own decisions. They're traveling at speeds of 4 meters per second with just millimeters of clearance between them. And this 3D grid is the world's densest automated storage system that we know of. Now, that wireless technology is communicating with each bot 10 times a second. Bots are also uploading their data to the cloud where it's analyzed by smart machine learning for preventative maintenance. So our air traffic control communicates orders to the bots over our own communications network. And any bot requiring preventative maintenance can be instantly replaced, no loss of throughput. To give an idea of the size of data we're talking about, each bot records about 1 gigabyte of data a day, so this could be 4 terabytes of data for an entire swarm. So historically, we've deployed our bot orchestration system on premises, running on local compute in server rooms in immediate proximity to our bot fleet, with a high-speed network to ensure the predictability and messaging delay required to achieve the optimal throughput. This is essentially a full private cloud with all the overhead that this comes with. However, given the success of our cloud platform, we wanted to see if we could run our bot orchestration system in the cloud. Pictured here is the architecture we designed. So using a site-to-site VPN between AWS and our warehouses and a network load balancer allows us to deliver the consistent latency requirements for this workload, and provided our fulfillment center is physically close enough to a cloud data center or a region. Although some parts of this architecture might seem like they're bespoke to this one application, because of our abstraction philosophy in designing the platform, we were able to just add these configuration options to our APIs so they could be just used by the teams that need them. And other applications or teams were unaffected and did not need to be aware of this migration. So that's been a little bit about our journey. And what I've shown you today is based on the products we've built ourselves internally over the years. But if you were to try and replicate these today, rather than building them from scratch, there are some available managed services that you could use instead that I want to recommend. So in order to have an application registry like ours, I would recommend looking into something called Backstage. This was created by Spotify. Backstage is an open source software catalog and a highly plug-inable developer portal that would allow you to build an UI for managing and discovering all the applications in your organization. Now, although it's attempting to be the worst named AWS service, Systems Manager Change Manager provides a service similar to our approvals product as well. And then if you are doing a big migration of a large Java or .NET workload into the cloud or into a containerized runtime environment, such as Kubernetes for the first time, coming from legacy VMs or from EC2 instances, then apt2container is a free command line tool that may help you with your initial containerization and CI/CD migration. Alternatively, build packs was something first conceived by Heroku back in 2011 as a way to transform your source code into a containerized runtime. And since then, they've actually been adopted by Cloud Foundry and other platforms as a service and joined the Cloud Native Computing Foundation in October 2018. There's a lot more that I would love to tell you about the last 10 years. It's been really exciting watching the growth in understanding of the platform engineering craft. We're excited to see where the next 10 years takes us. We're also hiring, so if what I've talked about today interests you, then search Mercado Technology Careers online to find out more. And that brings us to the end. Thank you very much for your time today, and I hope you've enjoyed our story. of our journey into platform engineering.
Hello, PlatformCon 2023. My name is Jeff Doolittle, and I'm very excited to be here to talk to you about technical empathy. In what is likely to be the least technical tech talk that you're going to hear this year at PlatformCon. Now, why is that? It's because I firmly believe that people matter more than technology. No amount of tools and technology are going to solve most of the problems that we face in our industry. Tools and technologies help, but ultimately what it comes down to is people, how we organize, how we work together, and I believe how we cultivate a culture of technical empathy in our industry. First, a little bit about me. My name is Jeff Doolittle, as I said, and my life's mission is that I help make good software professionals great. You can find out more about me and my writings and appearances about technical empathy and other topics related to software leadership by visiting my website, jeffdoolittle.com. I hope to see you there soon. So why technical empathy? Well, let me start by taking you down memory lane to a situation that I imagine many of you have experienced, as I have myself, where you're looking at some code and you're asking yourself, who wrote this horrible code? It's complex, it's hard to understand, it's not documented, it's just a mess. And then you discover this glorious thing called git blame for the first time. And so you type in git blame and you realize, lo and behold, oh, I wrote that code. Now, come on, you've had that experience before too. Unfortunately, I've had it more than once in my career in the early days. This reminds me of something I call the Homer Simpson principle. There's this episode of The Simpsons where Homer is holding a bottle of vodka and a jar of mayonnaise, and he's about to combine them and consume them. And Marge says, Homer, I don't think that's such a good idea. And Homer says, that's a problem for future Homer. Boy, I don't envy that guy. And this is why I say the Homer Simpson principle is also known as the don't hate your future self principle. You see, most of our challenges and opportunities are not technical. We've discovered the problem, and the problem is people, and the solution is people, and that's the problem. Maybe you've heard things like this before. We don't have time to design a clear, clean, useful API that properly reduces coupling. We have to ship it. Or maybe this one, who needs documentation? My code is self-documenting. Or the ever popular, it works on my machine. Or maybe you've heard this before, it must be user error. Side note, there are only two industries in the world that refer to their customers as users, the software industry and the drug trade. Another one of my favorites is saying that all APIs are HTTP APIs, as if there are no other protocols or transports that we can use to integrate different systems together. And I think another one that plagues our industry right now is Swagger sufficient, it's all we need. We'll just render open APIs and we'll publish them everywhere and everything will be fine. And yet in many cases, what we're really doing here is we're just taking mayonnaise and vodka and shaking them up together and drinking them and saying, that's a problem for somebody else in the future, which just might be you. So what does don't hate your future self have to do with technical empathy? Well, in my experience, sometimes treating your future self as someone else is a good first step toward thinking about the needs of others. You see, interfaces are everywhere. Right now, there are interfaces between your ears and the speakers that you hear my voice coming out of. Maybe you love good cooking, and when you smell the food that's cooking in the kitchen, there's an interface. There's interfaces everywhere. In fact, there are interfaces from the largest structures in our universe all the way down to the quarks. But we often run into the some assembly required problem, because sometimes our APIs leave much to be desired, because they don't necessarily meet the needs and requirements of the person who's trying to adopt them. You've probably experienced APIs like this before, APIs that put an excessive burden on the integrator. Maybe they're poorly designed. Perhaps the requirements are unclear. Maybe the objectives were short-sighted. And ultimately, a failure to encapsulate volatility in these poor APIs leads to brittle, fragile systems that are frustrating and costly to maintain and extend. But you might be saying, we delivered amazing world-class components like what you see here on the screen right now. But you know what the customer wanted? Driving. I mean, how many layers of abstraction are we away at this level from driving when we ship these things to a customer? Fuel pump, piston, spark plug, radiator fan. Look, these might be fantastic components, but they are way too many layers removed from the needs of the customer. Maybe there is somebody who could take these parts together and get driving out of it, but it would require a deep and broad knowledge and experience. You'd have to know what parts are missing. You'd have to have instructions, or otherwise you're going to guess or assume. You end up with extreme coupling to implementation details. When you're driving, you don't want or need detailed knowledge about what is happening in the fuel pump. And ironically, driving a Tesla is very similar to driving any other automobile because these details are hidden from you as the driver. Now, a mechanic may need to know what's going on under the hood, but the driver on the day-to-day basis doesn't. This is very similar to a lot of software applications where a front-end team talks to a thin HTTP shim over a database. A vast number of software systems are built this way. And what ends up happening is complex orchestration logic lives in the worst possible place, the front end of your application. Imagine if all the complex timing logic of your engine was built into the steering wheel, the accelerator, and the dashboard. So what do good abstractions do instead? They put the hard work where it belongs, on the implementer, not the integrator. Delivering raw components like these puts the burden on the integrator, but technical empathy provides a shift in mindset and culture that cultivates greater clarity of responsibility, increases the empowerment of both implementer and integrator, and ultimately helps build and maintain trust between software delivery teams. So I want to cover 3 topics in the time that we have left. And these are insights and observations. I don't have time to be completely comprehensive, but I want to look at the hard skills of technical empathy, the soft skills of technical empathy, and what I believe it takes to create a culture of technical empathy. And I encourage you to come up with your own ideas about how you can increase the technical empathy of the teams that you work with. So let's start with the hard skills of technical empathy. When I think hard skills, I think of engineering rigor. This means containing complexity in the systems that we build, not just letting complexity run amok or letting it be somebody else's problem like Future Homer. Another issue I see is this, that most software developers major in computer science, but that is not the same as software engineering. Computer science isn't bad, but just like I don't want a biologist performing brain surgery on me, or I don't want a chemist building an oil refinery, we need software engineers to be designing the complex cloud-native systems of the 21st century, and computer science programs often fall short. You see, you've probably heard the old adage, there's 2 hard problems left in computer science, cache and validation, naming things, and off by 1 problems. Well, I say there's 2 hard problems left in software engineering, information hiding and dependency management. Think about the cells in your body, for example. Think about how much information your cells encapsulate, how much information they hide, and how they manage their dependencies. And when things leak out of a cell or get into a cell that doesn't belong, well, that hits home pretty hard considering what we've all been through the last 3 years, doesn't it? So what does it mean to engineer software? It means beginning to look at a world where there are APIs everywhere. It begins starting to read about things like systems thinking and systems engineering from authors like Donella Matthews. We also need to look to principles like consistency, cohesion, and loose coupling. We don't want our systems to just be cobbled together with baling wire and duct tape. The hallmarks of a good design are consistency, cohesion, and loose coupling. And these lead to the holy grails that we all want of component reuse and composable systems. Another hard skill that we need to cultivate is design reviews. Now, I don't mean code reviews here. Remember before I said there are 2 hard problems left in software engineering: information hiding and dependency management. We should be asking ourselves, do our APIs properly hide information? Do they help us manage dependencies in a clear, consistent way that prevents things from leaking out to the people that are adopting our systems? You ever realize that the more powerful an API is, the more information it hides, not reveals? What's leaking? What excessive coupling might there be in the design that we're proposing? Another hard skill is a focus on what I call the other ARR. If you've been in the software industry, especially in startups, you've probably become familiar with the 3-letter acronym ARR, which typically stands for annual recurring revenue. But from a software engineering standpoint, the other ARR is automation, repeatability, and reversibility. Do you have test suites test suites for your systems? How automated are they? How about your deployment processes? Are they automated? Are they repeatable? Can you reverse things when things fail? Can you try again when things fail? These are engineering questions that we should be asking about the systems that we build. And finally, the often ignored documentation. My uncle Jerry was literally a rocket scientist. He worked for Sandia National Labs and Lawrence Livermore Labs. And later in his career, he ended up working for a medical device company to try to help them improve their software engineering principles. And what was happening was every single device that was built was a one-off with specific customer requirements that were involved in building each device. The device was shipped to the customer with no specifications and no documentation. And anytime somebody needed to work on that device, the company would have to send a technician out and they'd have to crack it open and guess at what was going on. Isn't it great that we don't have any software like that? Haha. And what Uncle Jerry said is, Jeff, we just don't know what we're building. We don't know. We have to send somebody out every time to find out what it was that we built and figure out what to do to fix it. Do you think that was efficient? Do you think that was cost effective? I bet it was incredibly error prone. And yes, this does in fact happen every day in the software industry. So those are the hard skills of technical empathy. Let's talk a little bit about the soft skills. As I said before, the problem is people and the solution is people. And that's the problem. This is true of technical design work as well, because API design is a human design task that requires the soft skills of technical empathy. First off, I want to say that these soft skills are in fact hard. They're challenging to cultivate. But I have found that when software engineers cultivate these skills, it vastly improves their ability to deliver technical empathy and to help people to comprehend what it is that we're building and shipping in the first place. It starts with a product-oriented mindset. You see, for every interface, there is a customer. Those auto parts that I showed before, sure, there's a customer for each of those parts. It's just not the driver. We need to begin to ask with the systems that we deliver and we want people to integrate with, how do we make it easier for them to integrate with them? And how do we create a product-oriented mindset where we view them as the customer? And that requires a customer, or in this case, an integrator focus. How do we make our APIs easier for integrators to adopt? How do we hide information and reduce coupling? How do we allow them to adopt the systems that we're building without rigidly attaching them to the things they're integrating with? This requires cultivating interviewing and listening skills, being able to understand the needs and struggles of others, and then being able to come up with creative ways to address those needs and concerns. I think it ultimately boils down to learning to hug the cactus. Ouch. But what I mean when I say this is, we take on the hard things so that others don't have to. This is the height of technical empathy. And technical empathy works best as a team sport. So as we close our time together, I want to give you some ideas about what it takes to build a culture of technical empathy. The first thing we need to do is we need to begin to build trust. And we do that when we make and keep agreements. Without trust, all manner of dysfunctions tend to result, such as hand-wringing, buck passing, and micromanagement, just to name a few. Healthy teams and organizations learn to make and keep agreements to build trust, and effective leaders build trust by making and keeping their own agreements. Once we begin to build trust, we can begin to clarify roles and responsibilities. We can begin to answer critical questions about the what and the why. One of the first and most fundamental agreements to make is agreeing to clarify roles and responsibilities. When people find meaning and purpose in their work, they become focused and committed to delivering value, and they can't do that if they don't know what their roles and responsibilities are. But when they do, their personal goals can begin to align with those of their team and of the organization as a whole. This cannot happen without clarity, and effective leaders work to ensure role clarity. And finally, once we begin to build trust and clarify roles, we can begin a virtuous cycle of empowerment. Because once roles are clarified, team members can begin taking steps towards mutual empowerment. I know what you're trying to do, you know what I'm trying to do, and we can help each other out. This process accelerates the growth of trust, leads to greater levels of clarity, and then continues in a self-reinforcing cycle of health. And effective leaders help cultivate an environment of mutual empowerment. I look forward to seeing how we can accelerate our platform engineering efforts by learning to cultivate technical empathy. Thank you so much. Enjoy the rest of PlatformCon 2023.
This is IDP's After School, a 2017 proto-platform story. My name is Johnny Dallas. I'm the CEO and co-founder of Zeet. I like to say that I've been doing platform engineering for the last 7 years, since 2016. Now, I run a company making IDPs easy and accessible for everybody. Today, I'm going to tell you the story of how I stumbled onto platform engineering. At the time, platform engineering wasn't really a term, and so we didn't quite call it that, but some of the underpinning ideas and problems that companies face every day that we now call platform engineering were very real to us at the time. So to start this story, let's set the stage. I mentioned earlier I was on a startup. This was a small team. This was a team of less than 15 people total. We'll go into the distribution of how that worked out later. And while this team was small, we had a really big ambition. We like to say that we were going to be $1 billion company or bust. And we were building Little League esports. We wanted to be the esports solution for high schoolers around the world to come and stream their video to our platform, and we would help them compete against each other. Now, to build this product, we had a very complex live video infrastructure stack. And we'll dig into some of those requirements in a moment here, but this is one of the key drivers for why we ended up needing to get into kind of the ideas of platform engineering so early. The infrastructure requirements for the product that we were building were really focused around video. I mentioned that we were building for gamers and we had this very large ambition. So that meant that we had to be everywhere that they were. Gamers are global. They are on every continent. They are all around the world. And so that meant that so did we. We had to be in every single pop that we could be in. We had to ingest video everywhere. Not only did we have to ingest video everywhere, we had to process this video very quickly. We would have an algorithm on the back end that was detecting events in the game. We had to be able to do this low latency video ingest at less than 15 milliseconds of total latency. Gamers, if you are one or if you know one, tend to play for very long periods of time. So not only were we ingesting video everywhere and having to ingest it at low latency, we would have to process long streams. And so making sure that there was always enough capacity for these streams was really critical. To quantify this a little bit, we would see users stream live video to us for 8+ hours at a time. And this video was not light. Not only did it have to be fast, and not only did it have to be stable, it had to be robust. We had an average of 7 kbps of this 1080p 60 fps stream that was coming into our system. Now, I mentioned that we had a small team. I want to break this down a little bit more because I think it sheds some really great light on why we ended up having to go and build a platform. The team was comprised of about 15 people, 10 of which were what we call application developers. This could be front end, this could be back end, this could be full stack. 2 people dedicated purely to infrastructure, 2 sysadmins, and 3 who were more focused on growth and product and not engineers in this capacity. Now, the real crux of the problem for us and the straw that broke the camel's back for our company was right when we started to take off, right when our infrastructure was really growing, we had our team shrink. Both of our sysadmins, within about a month of each other, retired and moved on. And this came at a really critical time for us in our company's story. Not only were we starting to hit some of this scale, we had to go far further than that. We had a mandate from our CTO to go from 1 AWS region to every single region in the year, 15 AWS regions that were available at the time. So we had a problem. Infrastructure is holding back our company, and we only have software engineers. What are we going to do? The solution that we didn't have the words for at the time was simple. Let's build a platform. Let's approach this problem with software engineering mentality. Let's deal with it like we do any other service, like any other product. So we started to plan this service. What does it mean? What do we need to have in place? What do we need to figure out before we can go and solve this problem for ourselves? The first thing that we did was lay out what the most important pieces were. We landed with 2 tenets, developer self-service and 100% automation. What we meant by developer self-service was because we had this team of 10 engineers who weren't all very infrastructure competent or really infrastructure capable or really infrastructure experts, we still needed them to be able to pull their weight. We needed developers to be able to deploy services, spin up new services, configure some of these higher level infrastructure pieces without having to go and talk to another human. And the 100% automation was really critical here. I mentioned earlier, I was in high school at the time of doing this, and I was the only software engineer that we could dedicate to solving this problem. I don't know if you have ever worked with a high schooler before, but they are not very reliable. I'm happy to attest to that. I can't tell you the number of times that I got paged in the middle of a final, and we really knew that we needed automation and systems more than people to solve this problem. So once we'd laid out some of the high-level tenets and we knew where we had to go spend our time, first thing that we set us out to do was let's standardize our infrastructure. And this was a pen and paper exercise. Let's figure out what are the repeatable blocks of infrastructure that can be used to define one region, and then let's figure out how we can scale that to 15 regions. We also knew that we wouldn't be able to do it all at once. The idea in DevOps, but also in people, of changing everything on a dime is very difficult. So we knew we had to figure out a rollout strategy. Lastly, this was 2017, and with a more product-focused than infrastructure-focused team, Kubernetes wasn't really on our radar. We'd heard about it, we knew that it was a thing, but we didn't have any maturity with it, and we weren't in a place that we could actually go and adopt it. So let's talk about how we standardized. The first step for us was to find a common standard runtime that we could build our product off of, or build our platform off of. Docker and containers were the clear solution for us, coming from a previous supervisor world. In addition to putting all our applications and services into Docker containers, we knew that we need to standardize the log ingestion and metric ingestion systems around them. If we couldn't see what was going on with our systems, how would this automatic platform be able to handle scaling up, scaling down, removing unhealthy nodes, things of that nature? We also standardize how application developers deal with their infrastructure, and specifically how they defined new services. We came up with a custom JSON schema that allowed these application developers to define build commands, run commands, auto-scaling requirements, things of that nature, so they could have control of their own application and hand off to this system. In terms of the rollout strategy and what we came up with there, we knew that everything would need to be able to be spun up in this platform. If we had done any manual actions, that would not scale when we were operating at the scale of 15 regions. And so we would bring everything up first in one completely automated region. If there was any manual steps that were required in that, we would shut it down and try again. Once we had that region up and running successfully, we would think about migrating DNS over, start sending some traffic to it, look at that, make sure it was healthy, and then and only once we had moved all production load balancers over, would we start turning off the old services. We kept them around for quite a bit of time as a backup, just making sure that if there was any incidents that occurred, we would be able to revert in an easy way. One forcing function that made this really easy for us to think about and really easy for us to execute on, we wanted to have a one-click way to spin up a new region. We had way too much to do and not enough people to do it. And so our CTO wanted a button that he could click that would spin up a new region, provision all the relevant infrastructure into it, automatically join the global control plane, and be fully functional from just that button click. I cannot tell you how many times that I clicked that button myself and got 99% of the way through, and some IAM role was broken, or some little script was broken, or some node failed, and we had to start over again. But this was a really useful way for us to make sure that our automation worked from end to end. Now, we don't have enough time to dig deeply into the platform that we actually built. If you're interested, we have a reInvent talk that I'm happy to share that I did back in 2018 about this system in far more depth. But what I can tell you is we had a Python event loop that hooked into the AWS APIs, namely Route 53 and EC2, that maintained the state, made sure everything was healthy, and managed all the auto-scaling. We used Terraform to standardize some of the infrastructure templates. The region, for example, all of the nodes and adjacent infrastructure resources that were created were initially created through a Terraform module, which then registered itself with this Python event loop and spun up additional resources. And we had a global control plane that centralized all the infrastructure operations into one system. This system handled everything from auto-scaling to provisioning of new nodes, and even handling the day-to-day CI/CD deploys. With this system, any engineer or team could register one of their new application definition models, and that would spin up a new service in as many regions as they defined. If they had a new Git push, we would take that and we would roll that change out to all containers across all regions, and the whole thing was done without any human intervention. This solution worked very, very well for us. In terms of, that's easy to say, of course, but let's get into some of the numbers. In terms of the impact of this platform and this system that we had built, we were able to go from a world of 20 incidents a week, constant downtime, constantly firefighting, constantly dealing with unhappy customers, to absolutely 0 incidents in the first 6 to 8 months after deploying this service. This was really important for us because these incidents, especially in a live video world, are pretty disastrous. If you drop video for even a few seconds, the streamers, the customers would complain, you would lose footage forever, and you could never really rectify that problem. We also measured our impact here in terms of efficiency. We saw that efficiency come in 2 different ways. One was cost. We went from a world of hundreds of thousands of dollars of monthly spend, an 83% cost reduction, thanks to the efficiency gains of having this platform constantly managing which nodes do we need, where, and how should they be being managed. Additionally, we were able to achieve the goal that we had originally around latency. We had a P95 latency of less than 50 milliseconds for all regions and all customers around the world. Not only were we able to improve the internal per region efficiency and improve the global uptime of the product and the company, we were also able to hit the scale that we needed to. We were able to scale to 15 regions and ingest more than 30 terabytes of live video every day. Now, I want to talk about how this helped the developers, because like I said, there was only one person building this platform, one engineer dedicated to it full time, which was me, and we were able to achieve some of these pretty impressive impact metrics. Not only was my job much easier, and I was able to relax a little bit more at school and not stress as much, but our developer team, who was working 24/7, would be able to create new services and change them at will. This reduced a ton of burden from me as the DevOps team, made it so that devs could go and spin up services whenever they wanted to and just do their daily job. Now, like I said at the start, I feel like we've kind of been in this platform engineering world for the last 7 years, and so I want to share some of the things that I've seen change in the last 7 years and some of the things that I have seen not change. First off, on what has changed. Platform engineering was not a thing when we started. It was a cool idea that we came up with internally, but we had no playbook. We had no best practices. We had no community. We didn't really know how to do this well. We made some stuff work. We would definitely do some things differently this time if we did it again. But platform engineering as a concept wasn't a movement, and it really is now, which is incredible to see. Secondly, the stack has changed quite a bit. I mentioned earlier Python. We didn't really use Kubernetes or have any interest in that. Now, building platforms, we use Kubernetes all the time. There's tools like Backstage, Crossplane, Prometheus. The whole cloud-native ecosystem has made it so much easier to get into platform engineering and build really powerful systems to enable both devs and DevOps engineers to operate more effectively. Lastly, in terms of the ecosystem, there have been some big changes in what cloud means. By the time that we got to the end of this system that we had built at our previous startup, we were in every AWS region at the time, and the bottleneck for us started to be AWS. We wanted to scale to more regions. We wanted to scale to more customers. We wanted to scale to more POPs, but we were limited by the cloud vendor that we had chosen. This is no fault of AWS. They do a great job of getting new regions spun up every year. But today, as we move into an increasingly multi-cloud world, what platform engineering means has changed there. There's also far more tools and more developers really who are thinking about this problem. It's been awesome to engage with everybody here in the platform engineering community and see how people are building and to solve these sets of problems. Now, as we end out here, there are some things that have not changed. Many of the core tenets that we adopted have stayed true. Treating infrastructure as a product, not a set of configurations. Feeling the pain yourself, putting yourself into the trenches, so you know exactly how to fix it. Find the first thing that you can do and do that first. And pushing power to the end user developers instead of centralizing it to a few people who know infrastructure very well. These core tenets were critical to us, and I think are still critical to the platform engineering community as it evolves into its current stage and beyond. Thank you for listening. I hope that you've enjoyed hearing about this platform. If you want to learn more, we'll be in Slack. Thanks.
All right, welcome to my PlatformCon talk today. Topic is measuring impact in platform engineering. Yeah, my name is Lambros and I'm a PM in platform here at Wise. So we'll start with the company Wise, what we do, what our purpose is, and then how we are organized in platform here at Wise. Then we'll look at why it's important to measure the impact, how we think of impact in platform. So what are our KPIs? How do we know we are successful, right? And then ultimately, of course, ideally, we want to quantify impact in some kind of monetary value. That would be the goal of today. Okay, starting with Wise. So the Wise mission is money without borders, instant, convenient, transparent, and eventually free. The company has evolved from being, say, mainly a cross-border money transfer service to a very comprehensive and compelling product offering like 50 currencies, different account types, business accounts, assets, interest. We even power some companies like Monzo or Stripe to make use of the Wise offering. It's become the one place to manage your money, really. Today we have 16 million customers responsible for 9 billion pounds of cross-border volume per month, 50 currencies supported, and we have 5,000 employees. Cool. Platform at Wise. Yeah, we are 15 teams, 90 engineers, 4 squads, and we have around 700 or so internal users. So those are engineers at Wise, scientists, data scientists, data analysts, and so on, using our platform. You can see here we have 4 squads. Basically, we offer storage, compute, networking, right? Developer tooling, make developers ship fast, SRE, tools to manage incidents, but also machine learning or data warehousing offerings. Cool. So why measure impact? Basically, it's 3 things for us. First of all, if you want to apply a product mindset to platform, right, you have to understand, you have to define what is the right thing to do, right? You have to have evidence, and this means you have to measure the impact of your work to actually come to a compelling strategy, right? For instance, should we improve documentation for engineers or reduce incidents from happening, right? That's something you have to define in your strategy, and you have to measure impact to get there. Also, we have to prioritize our work, right? We always have more ideas than we have resources. So should we reduce the build time of 5%, or should we increase our utilization by 2%, right? You have to make this comparable so we can actually prioritize the work. And then lastly, this is about investments in platform. So if we don't know what impact we make, right, we can't make good decisions of where to spend our money. All right, so now how do we think of impact in platform here at Wise? Our platform mission is build foundations that enable teams to ship confidently, quickly, efficiently, and without compromising stability. So this really informs our, let's say, 4 North Star KPIs: productivity, stability, efficiency, and risk. And those are what we think our biggest levers to make an impact on Wise, like on the Wise mission, right? So we want to enable teams to ship fast, right? Productivity, build a Wise that is reliable, right? Empower the mission zero, make sure we actually become eventually free, and do all of this in Wise risk appetite. So if you want to understand a little more about how we got to those 4 North Star KPIs and how we break those down in KPI trees, check out this blog post here. For now, I'm just going to use some simplified KPI trees for each of them so we can understand what impact means for platform. So first one is productivity, right? Again, trying to make teams more productive, save engineering hours, right? Bring Wise to its mission faster, really. So how do we do this? There are a few levers we have: lead time, onboarding time, developer happiness. This is what platform can do, right, to impact productivity. There's stability as well. Of course, we have to make sure customers trust us and can always rely on us, right? Again, platform here has 2 levers. You can reduce the number of bad things happening, incidents, right? Or you can try to recover from them very fast, minimize the impact. Again, platform partly owns this as well. And efficiency, as I said earlier, eventually free is our mission, right? So productivity is basically trying to keep the input stable, right, and maximize the output. Efficiency means we try to keep the output stable, minimize the input, so become more efficient, right? Platform, of course, we own all the cloud cost, vendor cost, and so on that we can impact as well. And then there is risk. Now we want to, of course, make sure risk stays in its risk appetite, and we control the risks and protect our customers and the business. There are a few risks that the platform owns, right, as well. Compliance, scalability, security, and by mitigating those risks or minimizing the impact of those risks, right, we can, of course, also make an impact. All right, so now quantifying impact in pounds. Why is this important, or any kind of other currency you prefer, right? So we saw what KPIs we measure and what we think we can do to contribute to the WISE mission. Now, why do we have to quantify this in pounds, right? A few reasons for that. First of all, it is the business language. So if we as platform tell our stakeholders, yeah, well, we reduced lead time by 5%, they say, congrats, but what does this mean, right? So we have to speak in the business language. Then there's the ROI, right? So without measuring the impact in pounds, you cannot know if the effort is worth it. We also cannot compare initiatives by their ROI, right? And lastly, again, comes down to investments. So if we don't have this common denominator for sizing ideas or opportunities, we can't compare them and we can't make good decisions of where to invest our money. So now question is, of course, how do we get from those North Star KPIs and KPI trees all the way down to actual monetary values and let's say pounds? We're going to go through each of those and understand in a simplified way, of course, how we do this. First of all, productivity impact. This, again, as we said earlier, usually is engineering hours or developer times that we free up, right, as platform. So there's let's say, a more naive approach to do that. You can just say, we saved one developer hour or one developer. What's the cost of the developer? Well, this is a cost saving, right? Well, we look at it differently. If we save or free up developer hours, we don't reduce our headcount, right? No, we use those freed up people to push the WISE roadmap forward, right? To accelerate the roadmap. So we want to really understand, well, what is the impact of an engineer that we have at WISE, and how did we accelerate the impact by saving them time? Example, right? Reduce the build time for Java engineers by 2 minutes. Of course, you have to know how many builds are there per day. Again, this is why we need the KPI trees that we saw earlier, right? You have to understand your user base, who is target audience, and you have to understand the impact of engineers at WISE. And you can then quantify that and get to £10,000 impact on productivity. So you may ask, well, how the hell am I getting to this engineering impact per hour? That's a good question, right? Well, you have to try to understand what is the impact an engineer has, like what is the impact of a new feature, right? Every quarter on average, for instance. This is something you have to quantify and then can use this in that calculation. Then we have also stability impact. Again, this comes down to two things. The impact of incidents per minute of them being open, right, or having a damage or financial loss, and the time it takes to recover from incidents. Impact important, right? It's not only something that happens immediately. Let's say if WISE is down for a minute, of course we have revenue loss because we can't support our customers, but there's also a longer term loss. So we always calculate the customer and the impact of incidents in immediate impact plus long-term impact, such as increased customer contact rate, which we can also quantify, right? So example, speeding up the time it takes to find the right on-call team by 1 minute. So the impact, let's say, of on-call incidents, we know is around £10,000 per average per minute, right? On average per minute. We know that we have around 2 incidents per quarter. Now, if we reduce this time by 1 minute, right, we can have a £20,000 impact on stability. All right, so then we have, So now you can already see, right, how we can compare those two ideas, right? We have an idea or an initiative in productivity and stability. Now we have that common denominator. We can actually make them comparable, right? And then decide what to work on first, or what to do if we only have time for one of them. So then we have efficiency. Efficiency impact is, again, mainly cost saving for us. Efficiency impact usually comes to a price though, right? So if you reduce cost, usually it means you sacrifice one of the other three North Star KPIs, let's say risk or productivity or whatever it might be. So you have to, again, quantify that and try to understand the negative impact. What sacrifice do you have, right? Example, we want to increase our compute utilization by a few percentage, right? Become more efficient. We know that the cost saving of this is around £20,000. But we know that if we become more efficient or high utilized, we can't, let's say, react to traffic spikes anymore, right? That rapidly. There's a risk of that. So £5,000 is a risk. So we subtract that risk and we get to the efficiency impact of £15,000. Also important here is that usually those kind of efficiency impact calculations have a compound effect, right? So it doesn't mean you have a one-time saving, but they usually add up. So if you want to do the ROI calculation, you can do this quarterly, yearly, or two years, and so on, right? To have those compound effect part of your calculation. And then we have risk impact. Now, risk is usually what we think of. What is the risk impact or the risk score in pounds before our idea or initiative is in place and after, right? So how do we quantify risk? Of course, it is in pounds at the end. We try to quantify risk as financial loss in pounds multiplied by the chance of this risk actually materializing, right? And if we can compare the risk before and after, we can then understand the impact of our initiative. Example, right? Let's say we have a risk that a bad actor is deploying a change to production, right? If this actually happens, we think it's going to cost us £50,000. We know that this risk today is likely to happen. So we do some work now, right? Let's say we improve our change management or whatever it might be, right? And this now becomes unlikely. So the impact that we had is the risk before and after, right? Is now £75,000 risk impact. Cool. All right. So takeaways. Well, there are a few things today we learned, right? First of all, measuring impact is important to apply a really product mindset, right? To platform, identifying what is the right things to do. How can we define a strategy? What are our biggest problems and opportunities? Then there is, of course, also the prioritization part of it. If we don't quantify impact, we can't prioritize our work, can't know what we have to do first. And then lastly, if we can measure impact and quantify it in monetary terms, it helps us make good decisions about platform investments. We advise think of impact in three, let's say, North Star KPIs, which are productivity, stability, efficiency, and risk. This is what we think is our contribution to the WISE mission. And we can quantify those, measure those, have KPI trees, and so on. And then lastly, well, we can use certain calculations. We can use math to come from those KPIs to actually a quantifiable impact, right? Which then helps us to talk the business language, helps us to get to an ROI, right? And helps us to make better decisions of where to invest our money. That was it from my side. Thank you for listening and enjoy the rest of PlatformCon. Thank you.
Hey everyone, thank you for coming to this session. My name is Ravi Devineni. I'm a Senior Director of Engineering for a team that leads Cloud and DevOps at Northwestern Mutual. I'm honored to be joined by Shantanu Singh, who's our Assistant General Counsel. We're here to talk about open source and how large fintech organizations can reap the most benefits from open source. Here's a quick disclaimer. All the content discussed here is the opinion and experiences of the speakers and not representative of a specific company. Please do not consider this as legal advice. A little bit about our company. Northwestern Mutual is a financial services company headquartered in Milwaukee, Wisconsin. We started as a mutual in 1857, established for the benefit of its policy owners. Today, 165 years later, we're a Fortune 90 company with more than 4.9 million clients. And Northwestern Mutual is the largest direct provider of individual life insurance in the US. We have high degrees of customer satisfaction with 97% of policy owners staying year after year. The agenda for today is we're going to talk about what open source means for a fintech organization and what are the various benefits and pitfalls and some of the ways that we have found useful to navigate these pitfalls. Shantanu here is a lawyer and I'm an engineer. With each of these, we're going to approach this from two different angles. We will bring two different perspectives, one from a legal standpoint and another from an engineering standpoint. We'll also talk about the lessons that we learned in this journey. We'll start with the benefits of using open source from a legal standpoint. Shantanu?
Thanks, Ravi, for the introduction, and thank you for inviting us to this conference, PlatformCon. This slide is going to discuss how open source technology reimagines property rights by fostering collaboration and shared ownership. This is from a perspective of an inclusive approach that disrupts traditional intellectual property rights that have a history of being exclusive and not premised on the concept of open cooperation. It's our perspective that open source encourages innovation across industries and bridges geographical, cultural, and disciplinary boundaries. As our world grows more interconnected, open source licensing provides access to resources and enables faster development and continuous improvement of products and services. Ultimately, embracing open source will lead to a more connected, creative, and equitable industry landscape and global landscape. And this is very true for fintech. Back to you, Ravi.
Thanks, Shantanu. The first and the foremost benefit from an engineering standpoint is that it's faster time to market. There are many standard problems that every company needs to solve, no matter what kind of applications they build, things like operating system, authentication, etc. Right? Open source provides ready-made solutions. This basically saves time. Saves time and hence it's cost effective. And it's transparent too. All of the code is out on GitHub. You can see exactly what you're getting. The power of the community is a major factor as well, right? There are a huge number of organizations that support open source software movement. Not only companies, we have thousands of passionate engineers contributing to solve all kinds of problems. And finally, recruiting. Every organization wants such passionate engineers, right? Companies using open source can attract such amazing talent. Now let's talk about the other side of the coin, problems with using open source. We'll start with the legal perspective first.
Thanks, Ravi. If we look at open source from the perspective of a bundle of sticks analogy, we'll be able to see how open source can create a very fluid and adaptable framework for intellectual property management. If you look at a bundle of sticks where each stick represents a right, like using software, modifying software, or distributing the software, and that one could selectively grant or withhold any of these rights and not give an end user the complete bundle, this concept can cut both ways. In a commercial environment, a stick is worth money. The proprietor of that software will give you sticks to do your work. Those sticks represent rights if you pay them a sufficient amount of money which they set. In open source, these same sticks, which represent use rights, distribution rights, modification rights, are provided not based upon a monetary incentive, but based upon what will foster engagement and collaboration for that project's success. This flexibility in open source nurtures diverse, thriving communities that can evolve to different needs and changing circumstances. Sticks can be taken away, sticks can be put back in. Rights, therefore, are adaptable. By enabling individuals and organizations to choose which bundle of sticks they want, open source projects can accommodate various interests, requirements, and objectives. Moreover, this analogy of a bundle of sticks can stimulate unique partnerships and collaborations, where certain rights are granted to different stakeholders even through the same open source project. This way, a diverse set of contributions from different sectors and disciplines can be provided. If open source projects in the future see that they can provide different sticks, which constitute rights, to different segments of contributors, a single project may have the opportunity to create a more diverse set of contributors based upon giving one segment a certain set of rights that may be different from another segment. This open source model emphasizes the importance of cognitive diversity based upon an understanding that different contributors may have different needs and insights that they can contribute, and therefore the same rights should not be allocated across the board. Granted, this is not a concept that is commonly associated with open source projects, but the nature of open source suggests that there is no real prohibition, but it's capped at the creativity of what the contributor and maintainers want as a culture or rules of engagement for their project. In conclusion, if we look at property rights through a bundle of sticks, we see that open source symbolizes the transformative potential of shared resources and collaboration through a focus on inclusion rather than exclusion. By reimagining property rights as a flexible and adaptable set of permissions, open source projects can unlock new possibilities and drive innovation, ultimately fostering a more interconnected and vibrant global community.
Thanks, Shantanu. From an engineering perspective, the biggest problem with using open source is the security risk it poses. There are thousands of vulnerabilities that exist in the open source software. All of these vulnerabilities are public knowledge as well. Equifax, SolarWinds, there's a lot of well-publicized cases. With a lot of these security vulnerabilities, right, the question really becomes, can we actually trust open source software? How reliable is the source? And many of these dependencies use some kind of versioning, and there's active development happening on many components. So the need for updates and patching is constant. If you don't change your application, essentially your application is becoming stale. Your application is becoming quickly vulnerable. And support also, right? If you run into some issues with some components, what do? We can make an issue with GitHub and hope it gets fixed, or we could contribute ourselves and hope it gets accepted. There's no active support with any of these. With all of these issues, right, it begs the question that, is open source really free? What is the total cost of ownership? But it's not all bad news. I mentioned many nonprofit companies working tirelessly to solve such problems, right? So we'll talk about a few of those solutions. So first, every company needs to know what open source software they have in use. Without that, they're flying blind. This is your inventory. Not just inventory, right, but a complete line of sight into what open source is being used and where, and what versions are we using, and how current are we with them. If a vulnerability gets detected, we need to be able to exactly pinpoint what parts of the company's code base is affected. This is the impact radius. So if you don't have an open source inventory, start here first. One way of doing this is to scan your SCM system. You can scan all the repos and extract dependencies and map it all out. Next is to obtain a software bill of materials. Software bill of materials, SBOM, is essentially a list of components that make up your software. If you precisely know what components are in your software, you can get a clear vision of the risk involved. There are various open source tools for generating. I've listed a few here. Each of them have their own specific pros and cons. In 2022, there have been over 25,000 vulnerabilities that have been discovered. This is basically 68 new vulnerabilities being discovered every single day. So we basically need to scan for these vulnerabilities that live in our ecosystem. And the scanning needs to be embedded into CI/CD pipelines with the ability to block release of a pipeline when certain high vulnerabilities are discovered. Many tools can help with this. There's a list there. Not an exhaustive list again. Each one of these tools have several pros and cons. You just need to figure out which one is right for you. And then you create your own block list, right? A list of components that must be blocked from entering your ecosystem. Once you do that, you have to centralize your ingress also. There should be a single entry point for all the open source dependencies for entering into your ecosystem. you can create a simple rule that blocks the dependencies if you have that, right? If they are on a list. Several tools support this feature like GitLab and Artifactory. Okay, and then there's a lot of legal aspects of dependencies also. Shantanu will talk about those now.
Thanks, Ravi. As this slide points out, there are a range of open source licenses that the audience here is familiar with, ranging from permissive, which has more flexible rights, to strongly protective, which have less flexible rights and put more obligations on the end user of the software or the contributor. Whether you're a fintech project enabling open source software compliance within your organization or any other type of organization working on software development or technology development relying upon open source, it's critical that there are a few points you understand as a lawyer supporting that team. You have to understand the product's functionality. And the reason why you have to understand the product's functionality is to determine if there are any dependencies of that functionality on open source. And even if you could clear that, you also need to understand your product's deployment and technology as counsel for your product team. That will help you determine if there are specific network protective licenses, such as Affero GPL version 3 that you should consider. And then work with your team on the technology side to foster greater understanding of open source, as they are the first line of defense. And the more you can educate your product team if they do not have a firm understanding of open source licenses, the more enhancement of your compliance program will be more mature and protected if the licensing requirements are understood. One way to do that is have lawyers as product designers. You move away from written legal analysis of open source issues and more to translating legal requirements into product features. What does that mean? Can help your engineers understand that they can develop product features into compliance tools or functionality. The reusability benefits of open source and the standardization of open source will actually make your compliance program less administrative and more programmatic. An example to illustrate this concept of lawyers as product designers who are looking at legal requirements and translating them into product features would be understanding a company's risk tolerance for open source and then translating these risks into detecting any variables in the license that can be flagged with scanning tools, whether it's for a licensing risk or for a vulnerability detection. As open source becomes more ubiquitous in all sorts of industries, not just in fintech, the ability to have programmatic scanning will be a great force multiplier for compliance in any open source usage in an enterprise.
So in all of this process, there were some key lessons that we learned, and this is the crux of our message. Open source has so many pitfalls that if an organization comes into it unaware, they could be facing some serious consequences. Organizations, especially fintech ones, need to be approaching open source very consciously. Having an enterprise policy is a must. An enterprise policy that outlines what is your stance on open source, what is your acceptable usage policy. All of this helps tremendously. Once you have a policy, that's a good start, right? But a policy is only a document. A document doesn't really do anything. There needs to be some strong governance around this. Next, automation is the key. There are thousands of dependencies that teams use to build software. There is no way a change committee or a team can review all of them, right? The process needs to be as automated as possible. Automated governance is the only viable way to implement a governance process. And finally, Shantanu will speak about the critical part lawyers play with all of this. Shantanu?
Thanks, Ravi. How can lawyers or a law department be deliberately engaged in DevOps? Translating cybersecurity expectations in terms of what constitutes effective risk management can be translated into the rules that are in the DevOps pipeline or your CI/CD pipeline for granting or denying deployment of code into a production environment. You can also do that from the perspective of licensing, making sure that code that is deployed is not outside of your risk tolerance of what type of licenses your organization would like to have and allow. Thank you again, PlatformCon, for inviting Ravi and I for this presentation. We greatly appreciate it and enjoy the rest of your presentations.
Hi, I'm Aaron Erickson, CEO of Workspace, where we make AI-powered people software for software organizations. And I'm really happy to talk today about one of the topics close to my heart, platform development. Some of my background is I was a VP of engineering at New Relic. I was a senior director of product at Salesforce, where in both those roles, I led significant platform efforts around building developer platforms. And today we're going to talk about some of the lessons I learned in what I call the 7 deadly sins of platform development. We're also going to talk on some virtues about platform development as well. So let's get into it. So let's talk about one of the first sins, so to speak, in bad platform development or problematic platform development. And by the way, a lot of these are confessions, not lectures. These are all elements of things I've done, mistakes maybe I've made some version of in the past that I wish I had done a little bit differently. And one of those I'll call the sin of gluttony. Thou shalt not cause cost to spiral out of control due to lack of cost controls or forcing the wrong tool for the wrong workload. So one of the ways this can happen, and there's some stories I could tell you, but I've seen companies where almost a third of revenue got eaten by cloud costs, even when people costs were maybe only 1/10 of revenue. And that makes me very, very sad. And I think about what some of the root causes of those kinds of things are. And it's really kind of two things. One is just kind of gluttonous use of resources when just adding more resources to the pool doesn't necessarily help anything. But resources get added because, oh, well, we just need to solve this reliability issue. So let's just throw more compute at it. Or sometimes just because we're choosing the wrong kind of instance or not making really kind of critical trade-offs where maybe a smaller instance would work well most of the time, but for reasons of, just kind of, I don't know, lots of different kinds of reasons where somebody might worry about, do we have enough compute power in any one given instance? We might choose a bigger one, for example. Regardless, this is a big area, especially this year, especially in 2023, where we are seeing just, cost being a factor again. And, right now, money isn't free. I don't know that it ever was, but certainly in 2023, having just spending whatever you want on cloud, those days are over. So we have to engage in cost control as one of our more important things that we think about. The second deadly sin of platform development is lust. Thou shalt not engage in a new technology just because everybody is lusting after that technology and lose focus on customer value. Who here in the audience has heard something about AI in the last year? You probably have. Everybody's a buzz about it. It's super exciting. And so everybody kind of has it. Oh my God, we got to get GPUs on our platform. We got to build LLMs. We got to do this, got to do that. My answer to that isn't no, but my answer to that is let's be a little bit skeptical. Let's not just pivot the entire organization to this new technology because it's super cool or everybody's doing it without really understanding what is the customer value we seek to bring to this. And are we the right ones to bring that customer value? Maybe there's ways you can do the experiment with some of these newer technologies, either outside your platform or in a very much focused area, without having to necessarily turn the ship all the way around to be able to chase switching over to entirely new kinds of GPUs instead of CPUs almost everywhere, just because you see this on the horizon. This might be applicable to your business. I would say if you are primarily an AI company, you might be doing this right now, or you might be evaluating these choices. But if your platform doesn't really need to change for this, and you just kind of see this new kind of sexy technology, on the horizon, it's not the main thing you should be doing. I know everybody's excited about it. We've gotten excited about this kind of stuff before. At one point, if you weren't doing Kubernetes, everybody thought something was wrong with you. And now we kind of see maybe that isn't always exactly the right path. Same thing goes here. Don't lust after technology just because it's new. There must be some other kind of bigger reason that has to do with customer value, not just your customers or your platform, your developers and other stakeholders, but your end customers as well. It's really, really important to think about the consequences of doing some of this stuff. Let's talk about another one. Greed. I don't think anybody in this audience is greedy. I really don't. But sometimes we do things in organizations because it's more expedient to, say, get promoted or kind of do what people just say around a vanity metric, where the reality is maybe you should change or challenge the metric in some organizations. I've seen a lot of platform projects where they chose an uptime metric and they chose it in a manner that has no customer value whatsoever. So for example, I literally saw one company measuring uptime by whether the health check URL returned a 200 HTTP code. The health check URL, which is always going to return 200 unless the health check service is dead. And I think one of the reasons they chose that was, well, it kind of helps the uptime numbers go up a little bit more in aggregate for the organization. There's all sorts of other kinds of bad usage of metrics where it's just not the right thing to focus on. A lot of times, you might focus on even one of the really good metrics in the DORA report, say release frequency, but outside of the context of some of the other ones. And if you don't think about release frequency paired with things like change fail rate, you might opt for one metric, overemphasize one metric at the exclusion of the other one, and thereby cause some other kind of problem. Is it greedy to choose bad metrics? Not always, but a lot of times the reason we don't challenge those metrics is because we're afraid of what it might be for our politics in the organization. Our job isn't to just put ourselves out on the line to make dumb, politically bad decisions, but it is to build enough political credibility as leaders so that when somebody has a bad metric, we need to challenge them on a bad metric. We can challenge that in a manner where we might spend a little political credibility, but it's for the greater good of the organization. And it may mean you take a little bit of risk with getting that promotion. That is a virtuous risk to take, and the people around you will appreciate that. Even now in this environment where it's gotten a little bit more politically risky sometimes in environments where there's layoffs and whatnot. Hard thing to do, easy thing to say, right? Here's another one though: sloth. Thou shalt not solve for only one set of stakeholders without balancing the needs of security, cost control, and developer experience. It is very easy to get centered on one of those three without really focusing on what do we really need to do for all three at the same time. You'll talk to a developer and they'll say, oh my gosh, all these security checks along the way, they slow me down, they hurt my ability to get cycle time up, they hurt my ability to get release frequency going, but they're still needed. They may be needed for audit reasons, they may be needed for compliance reasons, but I want to take the stance that a lot of the people putting these in, they're not all doing this to make your job harder. Sometimes there's really important things that they care about as well. Maybe they haven't done a great job of explaining it to you and as well as you might want to understand it, but it's still there. It's important for you to kind of understand a little bit more deeply and with a mindset of curiosity when you talk to folks. Cost control, we talked a lot about that before, big theme of this year. But also, let's not forget developer experience. This year, again, it's one of these years where people are worried about security and cost control, maybe even a little bit more than developer experience in some places, maybe not so much others. But it's not going to be that to the exclusion of the other things, even in the most vibrant of times or the most challenging of times. You're still going to need to think about developer experience because it's the developers that get the product out the door. It's the developers that build the experiences for your customers. And if they can't get new stuff out the door, it's going to hurt the financials of the company. So you got to have energy to be able to get all three of these things at the same time and not engage in the lazy thinking, which really just kind of solves for the metric of the most recent stakeholder group that you talk to, which is sadly a common pattern, including myself. I've done that before, and it's still bad. Wrap. Oh, wrap. Thou shalt not choose a platform based on how your prior platform failed you without understanding the trade-offs involved. Now, sometimes this might be for an existing platform. Imagine for a second, they have an incident in your data center, and it turns out to be some bug in Kafka that somehow manifested. Or it turns out to be some newer technology you brought in, but you've been using for maybe a couple of years, not too long, but a couple of years. And suddenly something else breaks. It makes everybody mad. And so instead of having a rational, okay, what could we have done to avoid this? How do we work around the limitations of technology? The decision's made, get rid of it. Get rid of it. It's bad. It's terrible. almost every time I've seen a decision like that go down, it was a bad decision. It was a decision made in anger, and decisions like that made in anger sometimes result in even more churn. You put your whole team through another migration, through another set of kind of technical tasks that have to be done to maybe try some other kind of technology, which, by the way, is going to have its own failure modes. Most of the time when you kind of swap out one technology for another, sometimes it makes it better. I'm not going to, sometimes that actually works. But a lot of times it's just, you don't know what you don't know, and you don't know the shortcomings of this supposedly better technology. If we are going to change, maybe change a more boring one, maybe one that's more understood versus less. So I've also seen people make the mistake of, in this RAF mode, go to something even more cutting edge or bleeding edge, and then suddenly have even more problems, despite whatever the vendor promised would solve their problems in the new, kind of shiny product. So, avoid wrathful conversations. Envy. Thou shalt not engage in a platform effort just because that's what the successful companies do. I've seen a lot of people think that they need to be Google. You're not Google. You don't need Borg. You don't need the same scale they have. Almost nobody does. And this goes for companies that are large that wish they had something like Heroku or Vercel or something like that. You may have requirements that way outstrip what one of those smaller platforms are capable of. This is the key to understanding is, the envy you have for going big or small at a different scale than you are can cause some really bad decisions. And I think there is a sense of, okay, well, the successful company does this. If I emulate them, I'm going to be like them. If we do what Google does, we're going to be like Google. No, that's absolutely, obviously bunk, right? You're not going to do that. Being Google means you have a business model that requires a scale. Don't put the cart before the horse. Scale the platform appropriately for the organization that you have, and maybe look a couple of years out at the projections, but don't build scale just for the sake of scale. This is almost kind of obvious at this point, but I continue to see people, still have this problem. Pride. Another one. Thou shalt listen to your customers when they disagree, and especially when they give you critical feedback. Feedback is a gift. We all know it. It's almost a cliche, but that's when I listen. That's when I get the most valuable stuff out of people, even when they're angry at me or something doesn't work. I'm using that to make the product better. I'm using that to understand what pain we're not hitting, see if that correlates across a broader customer cohort. And that gives me, the energy to fix the problem. If you get prideful, if you get defensive, customers see that and they suddenly see you as somebody that's not somebody they'll logically talk to about problems. And they just won't tell you more. Now you'll have all sorts of feedback that you don't receive. And now you're flying blind in terms of understanding what you need to fix in your platform in order to make everything better or really improve the situation. So we've focused a lot on the sins, and there are plenty of them. I don't know that we've covered them all, but there's also some virtues, and these are usually kind of, think of these as the other side of the sin, so to speak. But let's kind of go through them in order. Humility. Don't fall in love with your priors. All of us kind of have our things that we've been learning in our career. And it's good to use your experience to think about how do you perceive a problem, or how do you, come to thinking what are the right solutions for the problem. But also, sometimes the answer is I was wrong, or I don't know, or, what, I thought I knew this, but, I had this strong opinion, but it's weakly held. You've given me better evidence. So I'm going to change my opinion. I'm going to be humble and think about maybe I don't need to switch over to this new technology just because some bigger company does it. Or maybe what worked at my prior company doesn't work here. Gratitude. Like I said with the feedback thing, when customers give you feedback, thank them. When they give you critical feedback, thank them. Be grateful that we have the opportunity to get to do this work. This is an exciting time to be alive. It's an exciting time to be in tech. And every day that I get to serve customers in this manner, or I get to talk to people about platforms, is one that is a good day for me. So I'm going to have gratitude about that. Patience, and the right kind of patience. Be impatient about things that are not making progress towards getting your platform done, but be patient to understand in the big picture that not everything is going to be done in a day, a week, or even sometimes a year. And understand that, especially when you're in a big organization, the act of getting everybody aligned and moving towards the solution that everybody in your group knows needs to happen is going to take some convincing. And that's not going to happen just because you snap your fingers, or even if the CEO of the company says, this is what we're going to do. It still takes some patience to get everybody aligned, even when the biggest stakeholders say you must align. Diligence. Talk to customers, and then talk to them again. Talk to your FinOps folks, talk to your security folks. These are, if you're a product manager, this is what you're doing. You're always understanding these things. You're always getting their feedback. You're synthesizing it so you have a solution that at least meets as much the needs as you can. And then using your political capital to help them understand why you can't do everything that they want all at once. Generosity. The team that built the prior platform aren't idiots. Maybe they are, but they're probably not. They probably had a separate set of constraints that you don't have awareness of that frankly you might need to pay more attention to. You be very generous with your praise for your priors, people that were there before you, even if the decisions they made back then don't make sense to you right now, because you don't know all the context of what they had back then, or the budgets they were operating under, or the headcount that they had. Temperance. Temperance is this idea of managing your costs and being very clear about making sure that you keep things within the cost window that you have. Budgets are tight this year. They're probably going to be tight for maybe a couple more years, and we need to be kind of aware of that. Lastly, chastity. This is about security. Ignore it at your peril. Trust is hard to earn. It's easily lost. When you put out, when you have somebody like a platform that leaks credit card information, it's not going to be great for your company. And even if your company forgives you for that, your customers are not always going to be as forgiving. With that, thank you. Again, my name is Aaron. My email is here. I'd love to answer any questions anybody has, and I hope to see everybody at a forum soon. Thank you. Goodbye.
Hi everyone, thank you very much for joining my talk, and I'm gonna discuss values in tech. So for a long time, I thought that all the times that I saw companies talk about companies' values, it's just an arbitrary thing or something that they need to state for legality reasons, but not really something that is measurable, that I have something to do with it in my day-to-day. Until I started making decisions based on my values in my professional life and really understood how important values are in a professional setting as well, and not only on your personal life. So in this talk, I will show you a way to leverage values in your professional life, so you'll be more equipped to choose your next job, to evaluate your current job, and to understand why being aligned with your values will help you in having a successful career without sacrificing happiness or peace of mind. So first of all, hi, my name is Ina Fish. I'm a senior DevOps engineer. I have 15 years of experience in tech. I have a lot of things to say about myself, but I have only 15 minutes for this talk, and I have a lot to cover, so let's get right to it. So what are values? It's the degree of importance of something or an action. It's basically a broad preferences to reflect the person's sense of right or wrong and what ought to be. So basically, values are the core engine that derives principles, behaviors, and actions. And representatives of values are equal rights for all, excellence deserves admiration, people should be treated with respect and dignity, stuff like that. So why are values important? Because they create a desired future. If you know what you want, then it is the first step to getting it. Also, it makes a sense of direction and purpose, because values could and should be a guiding compass in your personal life and in your professional life, as I will show you in this presentation. And basically, when we are aligned with our values, we tend to be more happier, confident, and fulfilled. But then you can say, wait, isn't values the same as principle? So actually, no. Principles are rules or beliefs that govern our actions. Values are qualities or standards that govern our behaviors. And basically, principles are based on our values. So let's understand what drives our decisions, because it's all related, right? So first of all, emotions. You take decisions, and we want to take decisions in the best way, and we need judgment for that, right? And judgment is based on a lot of things, and we all know that emotions cloud judgment. So having emotions interfere with the decision making will probably result in a decision that we will regret taking. then we also have opinions, right? Because, hey, when was the last time that you bought something just because a friend recommended it to you, or even took a job just because a former colleague told you, yeah, it's a great company to work for, right? Opinions. So always take into consideration where the other person is coming from, which is not always aligned to where you come from and what you care about. And also sometimes people will consult based on what they care about and will not try to ask you what you care about or try to place themselves in your shoes. So you need to think about that. Information. So information is a good starting point to any decision making, but not everything can be facts alone, and not everything is black and white. And we really need to color information with our principles and values to make sure the decision is the right one for us. And also information could sometimes be biased, right, by opinions. So we need to be aware of that as well. Then we get to principles, and we said that principles are rules or beliefs that govern our actions, which is pretty good to decide based on that. But we need to get deeper than that. We need to understand and uncover why we have these beliefs and rules, and this will help us make better decisions. And last but not least, values. So this is the core of it all, our values. And when we use our values to make decisions, we make a deliberate choice to focus on what is important to us. So it is okay to have a job, but if you aspire to have a career, then you need to own it. And I heard a lot of stories like I was approached by this company, it looked good, so I just went along with it and went with the flow. So I believe that if you do want to have a career and you do want to navigate it to fulfill your aspirations and your goals, then there is a great importance of owning your career rather than just go with the flow. And also in terms of opportunities, they are important. And a lot of people believe that if opportunities come knocking at your door, you should seize them. I say seize them, but only if they help you and go along with your needs and goals and direction. Otherwise, they could just potentially steer you away from them. So you should decide which values are important to you and let them lead your way. So let's understand values in terms of company, aka company culture fit. This relates to your job hunt and day-to-day as well. So if a company values delivery, they will want to recruit people that put delivery as their first priority as well. And if a company values collaboration, then maybe pair programming is a norm and they will want to recruit people that are collaborative as well. And it should be the same for you. You need to make sure the company's culture fits your values and your needs and perspectives. And when values are shared, they build internal cohesion in a group. So in terms of really understanding what is company culture fit, let's understand the organizational perspective towards it. So a culture fit is the likelihood that someone will reflect and or be able to adapt to the core beliefs, attitudes, and behaviors that make up your organization. So culture fit is a thing, and if you ignore that, you will find yourself struggling to prove yourself, to shine, and even to feel at ease in your day-to-day. You'll experience conflicts, inability to set things in motion, or to harness people to help you with your projects and tasks. The employee perspective towards company culture fit is this. Company cultures are like country cultures. Never try to change one. Try instead to work with what you've got. So either you work with what you've got, and if you can't work with it and it makes you unhappy to try, then probably you should find another place that is suitable for you. So, okay, values are nice, but how does it relate to my day-to-day as an engineer? So this is an example of my own, of one of my leading values, which is collaboration, but actually recognition goes into it as well. I acted upon collaboration in my my previous job, and there was a program where other employees can basically grant me the collaboration tag and explain why. And a lot of people tagged me with this tag in a certain quarter, and that's why I got this recognition for my company. They had a program called Cheers for Peers. So that's basically it. Don't try to read what it says. If you really want to read it, you have it in my LinkedIn profile. So why am I telling you this? Not because I want a pat on the back or to tell me where to go, but I show you this because I want you to see what happens when you are aligned with your values and when there's a culture fit between your values and the company's values. You get recognized and you get appreciated. And yeah, not all companies have these programs, but there are ways for you to check that your values are fulfilled. So Practicality starts with the understanding that technology is not everything. You really should add your values to the set of considerations when choosing your next workplace and when you evaluate your current workplace. So on job hunts, you need to really remember that you interview them as much as they interview you. So don't just ask about technology stack and project roadmap and stuff like that. Also ask about things that will help you understand if your values are being valued and implemented in the company's day-to-day, and I will cover these kind of questions later on. Yeah. So in your day-to-day, I suggest this approach to have a lighthouse or a float point of view approach. Basically, to not drift with the flow of your day-to-day, but really raise your head above the water once in a while to make sure that you are steered towards your desired direction. So when I say retrospectives, I mean don't wait for performance reviews to evaluate what's going on. Do retrospectives with yourself. Decide on a cadence to have these retrospectives. It could be each month, 3 months, 6 months, whatever suits you, and make sure that your values are in check and you are keeping true to them. And when doing the retrospective, don't decide to stay in a current workplace just because the tech stack is cool and you have interesting tasks. Consider values fulfillment as well, because let's say you do have great tech stuff, but you suffer while doing that because of other stuff like micromanagement, or every task is done the hard way because there's no collaboration or knowledge sharing, and well-being is damaged because production on-call is noisy and there's no priority to fix that, or even it's okay to call someone on his day off and it's not even urgent because this is the company culture, right? So what's the point? So you should really have these retrospectives, and I'll give an example of mine. I mentioned the value of collaboration as the main value for me. So my retrospective in terms of collaboration will look something like that. I will ask myself, did I have pair programming tasks at work? Does my team leader support or encourage that? Do pull requests are only a please review kind of things, or please review, and they want me to review and not just approve and put a stamp on it? Do people tend to help me and I'm able to help them? Or the culture is more like fly solo and figure it out yourself kind of things. So this is one example that you can do with yourself, and I'm gonna share more questions that you can ask based on other values that will help you with the retrospective. So in job hunts, you can ask in an interview and also search on Google, what are the company's core values? Because if they are public about it, it could suggest they feel strongly about it too, thus letting it be their guiding compass. You can ask how do you measure a company's core values? Because if a company declares its core values, they should have a way to measure it. Same as performance reviews. If a company measures your performance and their performance, so business and financial wise, then they should measure their performance cultural wise as well. You should also ask general question, what is success in your book? Because based on the answer that you will get, you will be able to tell what is important to your interviewer. And important means probably values, even if they don't portray it as such, but important is how our values are being conveyed. And you should ask them value-based questions. So for example, for personal growth, if this is the value that you care about most, you should ask if personal growth plan is in place and if it's implemented. For communication value, you have a question of sitting arrangements. If the ICs sits with management, if there is open communication between everyone, and I have more questions about communication that you can ask in a bit. And a bit arrives now. These are examples that you can ask yourself for these values that I'm gonna share with you. So for communication, check the channels, Slack meetings, and how communication is conducted there. Is it okay to ask questions if the feedback and communication is positive or only when something is wrong? Feedback, is it ongoing or only on performance reviews? And if the one-on-one is only for your team leader, or you can say things as well. Postmortems, are they blame or learning? Fixed, are the Slack messages are just fixed, check now, or they elaborate and say the issue was X, I did the change that Y. Integrity, so can I speak my mind and say if something is wrong? Is there trust, macromanagement, or micromanagement? Can I say I messed up, or do I need to cover it up? Are my managers accountable for the words or promises? And do I have autonomy on my work hours? If so, it means that I have a way to express my integrity of not slacking around. Personal growth. Are there predefined tracks for non-managerial growth like ICs or tech leads? Is it encouraged to attend or speak at conferences like I'm doing just now? Is there a mentorship program, and are others willing to mentor even without a defined program? And is personal growth a priority as much as delivery? Because a lot of companies have this model of our people come first. Is it for real? Innovation. Is it encouraged to suggest new tools and bring up new ideas and tasks? What is the value of maintenance work versus the volume of work on new features? Do we have extracurriculars activities like hackathon or demo days or open source contribution days? Ownership. So is it expected to do things in an end-to-end manner? Do we have dev-centered culture? Does dev care and focus about code alone, or also ask about things that are peripheral, like monitoring and tests? And are you independent on your tasks and you have design responsibilities, or you just have the task queued up and you just need to implement it, and that's that? Leadership. How do I perceive leadership, and how are the leaders in my company if they are embodiment of that? Do leaders know their employees and colleagues personally? Do I look up to or appreciate the people in leadership roles? And what does it take to be leaders in a company? Well-being. Is there an understanding of flexibility for personal issues? Are people getting contacted on their day off? Production is stable or not, if it's putting out files or not? Do I have autonomy on my work hours as well here, because it is related to well-being? And does the company work in a hybrid setting? And knowledge sharing. Sessions for knowledge sharing exist? Yes, no. Is writing documentation an integral part of the team's day-to-day? Do we have time to write blog posts? And also communication of fix, check now, blah, blah. It's also about knowledge sharing, because if they share the knowledge or not. So you now can ask myself, okay, you can ask me, I can ask all of these questions, but hey, they want to recruit me, so they'll probably lie, right? And how sad that everybody lies. So in my experience, as long as you ask very specific questions, it will be very hard to lie to you. For example, describe me your house. You would say it's white, it has a fence, 4 rooms, that's it. You will prettify the truth. But if I'll ask you specific questions, like what are the sizes of the rooms in your house, and is it close to an airport or stuff like that, then there's no way out, no prettifying the truth. It will be a straight up lie, which you will find out very soon and can bail quickly with little to no drawbacks resulting from this decision to be there. But also you can find someone that worked there before and ask them, and they'll probably be able to spill the tea. So to sum things up, technology is not everything. Values can and should help you navigate a career in tech that best suits you. So now it's time for you to start thinking, what do you value and what are you gonna do about it? Thank you so much. If you have any questions, you can reach out through any of these platforms, and I'll be happy to help. Thank you.
Hi there. In the next 15 minutes, we will tell you how we started creating a self-service infra provisioning platform, the challenges we faced, and how we stepped up our game in order to build an improved platform we use today. So, who are we? I'm a platform engineer that focuses on infrastructure as code and bringing good software engineering practices in the world of system engineering, based on my previous experience as a software engineer. I'm passionate about provisioning fit for purpose and grid software architecture and provisioning.
I'm Karan. I'm a software engineer who focuses on DevOps and platform engineering. I try to bridge the divide between development and production. When I'm not busy with infrastructure, I'm learning about Rust and finding budget-friendly ways to run personal stuff on the cloud.
Who is Bol.com? Well, Bol.com can be best described as a retail tech platform. Through the help of our 51,000 partners, we are able to offer over 34 million items for sale to serve our 30 million clients in the Netherlands and Belgium.
As engineers, you're probably more interested in the technical stats that enable Bol.com to be successful as a business. We migrated from our on-prem data centers and chose Google Cloud Platform as our public cloud vendor. We have more than 3,000 projects in GCP with over 17 GKE clusters. This enables us to serve over 200 IT teams, and to date we've made over 1 million changes to our infrastructure using our self-service tooling. With that in mind, let's kick it off with how we got started with self-service and the cloud. How does Bol.com do self-service IT? Introducing RTDT. It's just a backronym for Reproducible Resource Deployment Definition. You can think of R2D2 as a web interface that allows you to create GCP projects. It is our infrastructure as code tool and allows engineers to provision resources in GCP completely self-service. This means that you can join Bol.com tomorrow as an engineer and use R2D2 on day one with no intervention. R2D2 takes YAML as input that is heavily inspired by Kubernetes. And because the input is YAML, we can support our engineers with the GitOps workflow through our integration with GitLab. That means that you can either use the web interface to quickly get started or hook into Git if you have a more mature project that wants to rely on the GitOps workflow. R2D2 helped realize Bol.com's journey to the cloud, and we have been using it in production for more than 5 years. But as with all things, we noticed that R2D2 started to age. It has been increasingly difficult to keep up with the innovation of Google Cloud. This is because we have to implement the logic in R2D2, and where necessary, create abstractions. It has no community, so even though we use Kubernetes like YAML, our engineers can't make use of Helm or Customize. It is also hard to troubleshoot. You cannot Google your way out of an error, and I'm pretty sure you won't find hits on Stack Overflow about it. And finally, no matter how much Kubernetes or GCP knowledge you have from a previous role, you first have to get acquainted with R2D2 when you start at Bol.com, making onboarding hard. All of this means that as a platform, we have become a bottleneck for innovation for our engineering teams. We had a problem and we needed to find a solution.
How are we paving the way forward? We've seen that one of the major pain points in R2D2 is abstraction. While researching the market on infrastructure as code tools, we discovered the kept tool and this wonderful quote that summarizes the abstraction issue perfectly. Namely, even a thin abstraction obstructs the ability to leverage the ecosystem of tools that can be used with the built-in Kubernetes resource types, and it closes the door to other automation. And even though this quote was specific to Kubernetes, we realized it rang true for building a platform for our engineers. So our first task was to evaluate the options on the market. But the more we looked, the more we realized Kubernetes was staring us in the face. This is because of something called the Kubernetes Resource Model, or KRM for short. KRM is a declarative, always reconciling design pattern that all Kubernetes resources follow. KRM also means you can customize and extend Kubernetes beyond the native resources you get with it. If you do so, you have one way of managing different types of resources, and you get to leverage the rich ecosystem of Kubernetes. The use of KRM to extend Kubernetes is really a growing trend in the industry. Let me phrase that in a more concrete way. We wanted a way to not only manage our workloads on Kubernetes, but also the infrastructure that we run on Google Cloud Platform. So it was around this time that Google announced Config Connector. Config Connector is a collection of custom resource definitions, or CRDs, and controllers for all the GCP resources one can provision. Config Connector builds upon KRM and allows you to define your infrastructure as objects in Kubernetes. Config Connector will continuously reconcile these objects, making sure your GCP infrastructure matches your declared state. If you look on the example on the slide, you will see that much like you would define a deployment in Kubernetes using YAML, you can define a cloud storage bucket in the same way. All the standard Kubernetes fields are there. Think of an API version, kind, metadata, and spec. This has numerous benefits for us. Firstly, Kubernetes becomes the single platform for both the workloads of our engineers and for managing our own infrastructure. It is similar to representing a bucket in Terraform. The basic idea is to represent your resource in a declarative format and be able to have them saved in a code repository. The improvement over tools such as Terraform is that now you do not need an extra tool next to Kubernetes to manage the resources. The Kubernetes control loop does it for you. Secondly, we are able to leverage Google's innovation power and no longer need to incorporate their updates into custom tooling. And finally, Config Connector has public documentation online. The source code is available on GitHub, and support requests can be directed to Google support engineers. This has a massive benefit for the onboarding of new engineers. And even though Config Connector simplifies infrastructure provisioning quite a bit, the whole flow still requires significant effort. For example, when using a resource in GCP, one needs to enable the resource's APIs, create IAM role bindings, etc. And ultimately, we needed a way to simplify this flow. Enter Kept. Kept is an open source tool. It's part of the Google Container Tool Suite that manages KRM resources in bundles called packages. Simply put, Kept can package, transform, and deploy your KRM resources. Let's put Kept into practice. Assume you want to make sure that the names of our cloud storage bucket are prefixed with the name of the namespace. With Kept, we can create a storage bucket package that includes this transformation. If you look at the YAML on the left-hand side, you will see the sample storage bucket provisioned by the Config Connector documentation. On the right-hand side, you can see how Kept has transformed the underlying cloud storage bucket resource. But we all know infrastructure isn't as simple as the resource by itself. We need to ensure that the IAM role bindings are configured as well. Here you can see how we offer a storage bucket Kept package that includes all the bits and pieces we needed to provision convenience to our end users. Obviously, a cloud storage bucket by itself is not useful. So what we are doing is offering popular blueprints to our engineering community. By composing these resources together, we can create blueprints from Kept packages for our Java engineers in the form of microservice blueprint. Or in the case of our machine learning engineers, we can offer an ML application blueprint for Python workloads and Vertex AI. Let's quickly recap. We are relying on KRM to use Kubernetes as our platform foundation, Config Connector to provision GCP resources, and Kept allows us to offer building blocks that we can compose into popular blueprints. Our next challenge was how do we lower the barrier to entry of our platform? This is where Backstage steps in. At Bol.com, we are adopting Backstage to be our developer portal in the IT landscape. With Backstage, you can select blueprints to get started. In this example, we are going with the microservice blueprint. First thing is to select a name for our application, give it some description, and select the team who will own it, and finally select the location for the repository. Under the hood, Backstage will use Kept to render the package and apply it to Kubernetes. The source code, of course, is also pushed to GitLab repository that we selected from the start.
This is all great, but you might be asking, what about new GCP resources? Let's say Google just released Data Fusion, and you want to store all your training data there. You are very excited about trying it out, but there's no Kept package nor a blueprint. What can you do? You can take an existing blueprint and create the Data Fusion Config Connector resources in Kubernetes by referring to the Config Connector documentation. As a platform, all we need to do is make sure that an intake has been done for Data Fusion and the necessary policies are in place. Policies allow us to enforce mandatory legal and compliance guardrails. We don't have time to cover it in this talk, but if you're looking for a policy enforcement engine, be sure to check out Gatekeeper from Open Policy Agent. As a platform, this means that we can deliver new capabilities in days versus months. End users can refer directly to vendor documentation, and because we ditched abstractions, our end users can endlessly tweak the resources, packages, or blueprints to suit their needs. So in closing, did we solve our problem? We are now able to offer different golden paths for our Java and data science communities through blueprints that match their respective use cases. Our end users have the choice of getting started via the wizard in Backstage, or they can apply the blueprints directly on Kubernetes using Kept. Because the blueprints are ultimately resources in Kubernetes, they are free to examine and customize the resources for their unique situations. We no longer have any abstractions. If the blueprints don't suit their needs, or they want to take the unpaved road, They can directly use config connector resources on Kubernetes with the help of Google's documentation. Ultimately, everything is enforced by the same policy engine, and Kubernetes offers a single platform. We managed to remove our abstractions without compromising on security compliance. We managed to lower the lead times on adding new capabilities to the platform. And finally, we are slowly adopting platform engineering at Boulder.com. Thank you very much, and please let us know if you have questions.
Hi, folks. Thanks for joining the session. I want to talk about working backwards because it's something that has really changed the way that I approach any kind of improvement effort, any kind of implementation, any kind of adoption of new techniques or change management. I really think it's valuable. And so part of this is about establishing a clear target. And then most of it is really about navigating towards that target by leveraging a roadmap that I found extremely valuable. So let's dive right into the material. So what are we going to be talking about? We're going to be talking about the challenge at hand, an example challenge that we'll use to kind of frame this. And then we'll get into the target. So how do we identify a valuable target? How do we understand it? And then we'll understand how to leverage the roadmap to actually navigate towards that target. And then I'll leave you with some resources that'll help you take this on yourself and learn more about it. So let's talk about the challenge. In a lot of organizations, what I do is something called outcome mapping to really figure out what do we want to do, right? And that comes from collecting information from a bunch of different stakeholders. It's getting people in a room, getting people on a Zoom, and putting their ideas, their thoughts, their questions, their pains onto a collaborative space. And then what we do is we work it all together to understand what is the most valuable thing that we can do to move forward. And so in this case, what we're going to start with is releasing more often, right? Very common driving force behind platform adoption and tooling and enabling developers. But it's just an example. This could be any target outcome, right? We want to understand more about this. The challenge is really understanding what to do about that, right? So once we have a target outcome defined, we're going to look at benefits. So what is this actually for? What is the value that's provided? Why should we do this thing? And so this really gives us clarity on what is valuable about the target outcome for different groups, right? We have external customers, we have internal stakeholders, we have partners, we have individual contributors, we have leadership, we have middle management, we have all these folks who all want something for different reasons. So this allows us to get all that together. Maybe we vote on what we all think are the most valuable things. This is a very simplified representation, but this can be a final copy of something that starts out very messy and we just vote and discuss our way to something very clear. Then we want to understand what are we going to trip over on our way to our target destination, right? So talking about obstacles is really valuable to just highlight things that we need to make sure we avoid or we address to maximize our odds of success. And then in terms of what to do about this, we could talk about how we get started, right? What are the things that we're going to do? Sometimes that's assessment, sometimes it's mapping more things out. Sometimes there's a little pilot or experiment that we can run. Maybe it's a survey. But we lay all this out, and all of a sudden, we have a high degree of clarity and confidence in the target that we're setting for ourselves. And how do we make sure that we actually achieve that target, right? So if we're talking about releasing twice as often, that's bringing me to thinking about the flow of work, right? Or you might have heard of this in the context of value streams. So how do we understand where the constraints are in the entire process beyond the visibility that we have inside of maybe tech or one enabling team, maybe from the perspective of a business architecture team? We can't really see where the constraint lies in the workflow because we're not in it. We're not spending time in it. So what we're able to do is really think about this in terms of holistically representing a value stream, understanding the flow of work that's involved. And that comes from looking at customer satisfaction backwards, right? Working backwards in the workflow through all these separate activities that begin with a business hypothesis, something we think is really valuable. And this flows out through the workflow to customers. And then we iterate back through and learn, and we adjust and we adapt over time. But really, by looking at this end-to-end workflow, this value stream is really how we understand a couple of things really clearly. First of all, we understand that what we're doing is for customers, right? The workflow is all in service of customers, whether those are internal customers or external customers. And that critical to delivering that outcome is the workflow. So it's really important to think about these things in terms of value streams, because value stream management has been a thing for 100 years focused on this exact problem. And there's a lot that we can borrow from in the context of building a platform that enables a improved flow of work and improved delivery of value. Because we've been doing that in the physical space for decades and decades, and we've been doing this in knowledge work for decades as well. But this is starting to really, really take off. So how do we actually act on this insight? How do we actually address the flow of work and that target outcome that we've set? Releasing twice as often, or improving quality, or driving down incidents. That's where the roadmap comes in. So starting from wherever we are, we can look at assessing our current state. I'm going to share a tool that you can use to do that very effectively from a high level, talking about value stream management. We're going to set that target. So our vision for the future might be releasing twice as often. It might be fewer incidents. It might be higher customer satisfaction. It might be a combination of those things, in which case we might want to prioritize, right, and get really clear about which one we're going to target first and what's going to, what we're going to get to eventually. Then what we want to look at is what are the things that are going to deliver that vision, right? What are the workflows that are involved in delivering that target outcome? So in the case of releasing twice as often, maybe it's a single product team, maybe it's multiple agile teams, maybe it's an agile release train, maybe it's multiple project teams. It could be any number of people, teams, or groups, but by setting the target, we can understand the scope of that, right? What's involved in delivering that target outcome. And then we can organize representation from all the stakeholders who are involved there. So we want to get leaders involved. We want to get contributors to understand where the pain points are currently, where the opportunities are. We get them together. We map out the workflow. We understand what does the current state look like? Where are the bottlenecks? Where are the constraints? I've got other talks about this. So if you're interested in that, I'm all about value stream mapping. You can find a ton of information if you just search for my name on YouTube. Then if we want to scale this up, automate it, make it continuous, we can connect tools into a value stream management platform. So we can use a dashboard for that. We could use a common tool like Jira and just try to create a dashboard that collects metrics on the performance of the workflow. But we've got to start pulling in data if we want this to be automated. Unless you want to be mapping on a regular basis to understand performance, collecting the data by connecting tools is really the way that you kind of automate that and make it continuous. That's going to allow us to inspect the workflow and understand where the constraints are, where the hotspots are, where we should focus our energy. And in terms of platform adoption, that's going to allow us to focus on the things that are actually impacting workflow, the things that are actually impacting outcomes, the areas where we're not meeting our security objectives, where we're not creating value for customers, where we have excessive delays or too many handoffs or too many dependencies. All this can be inspected in terms of workflow, which is ultimately what customers care about, how long it takes to get things that they want. So this is all kind of framed in the context of what's really valuable to the business and really valuable to customers and really valuable to really anybody who is interested in the success of the organization. So you'll find that it really drives better conversations when you're talking about things that ultimately matter to the most important stakeholders in the business. After inspection, what can we do? We can act on what we discover, right? So we can change the way that we're working, we can do different things, we can improve what we're doing, and all that can kind of create this virtuous loop where we can continue to inspect and adapt. But overall, this kind of follows a classic pattern, like an OODA loop pattern. So observe, orient, decide, and act. In this case, we're starting with orientation. We're starting with understanding the landscape, setting a target, and then understanding what to do and processing the feedback from our actions. So all this goes back many, many decades to really scientific practice of continuous improvement. But hopefully this provides you a framework that is really clear, where you build off of initial momentum, definition, clarity, all the way out to full automation and continuous improvement. So this has really been about envisioning for the most part. I find that that's a part where folks really get stuck or they set off in the wrong direction. Working backwards from a target outcome and understanding that outcome together with everyone who's involved is really the secret sauce to getting started in the right way. Otherwise, you could spend a lot of time wandering around, wasting time, focusing in the wrong places. And a really clear target helps you with everything that follows downstream. It helps you to identify the right scope. It helps you with getting the right people involved, and so on and so forth. So if you're interested in getting started, so the second stage of the roadmap was assessment. I was part of a group that created this value stream management assessment with comparative agility. You can go to their website and fill that out for free. And they have a charge to fill it out as an entire team. But when you fill it out with your whole team, you get data on everybody's perspective on workflow and continuous improvement and all these aspects that are important to value stream management. And that's going to really help you sit your platform adoption on a sound foundation, right? Value stream management has been a practice for large scale continuous improvement and optimization for decades and decades. It's really starting to take off in the software world, but you'll find that it really gives you a strong foundation to not only think clearly about what to do about workflow and value delivery, but also a really solid foundation and language to talk to business folks, leaders, your peers, your teams, with terms and a lexicon that really resonates, that really matters to customers and business and all the things that we're actually trying to do. And also beyond this, the roadmap itself was developed through the Value Stream Management Consortium, which I'm a board advisor for. We also were the creators of the assessment. We create a lot of material, resources, training on value stream management. And we're building out information around value stream management and platform adoption and implementation. We're working on integrations and interoperability right now. We have a working group. So if you're interested in large scale continuous value delivery and this area of practice, you can hang out with me there. You can scan the QR code and check it out. I think you'll really enjoy it if you're really interested in large scale impacts of things like platforms and continuous improvement. Thanks very much for checking out the session. See you at the conference.
Hello, I'm David Sandlands, Principal Solutions Architect at Puppet by Perforce, and I'm here to present the findings of the 2022 State of DevOps Report, Platform Engineering Edition. The State of DevOps Report has been released annually since 2013 and has had approximately 40,000 people surveyed. Over the last 4 reports, we have seen slower growth of organisations identifying as highly evolved, growing 10 to 18%, with the majority of organisations remaining at the middle level at around 80%. DevOps has become so prevalent within many organisations they're not even using the term anymore, since it's simply the way they work. But what is meant by DevOps can actually vary so greatly between these organisations. With these two things in mind, the value of surveying across the organisations has reduced over time. As a result, we've chosen to stop doing reports on the broad concept of DevOps and to focus on specific impactful topics. Last year's report showed that the adopting automation infrastructure as code does not create highly evolved DevOps practices alone. And a focus on improving organizational structure, team identity, and interaction between teams with a common attribute of the highly developed DevOps organizations. It was therefore decided to focus this year's survey on platform engineering, which has been tracked for several years by the report and has been shown as a clear pattern that more mature DevOps organizations use platforms, with 65% of highly evolved organizations using platforms against 40% of those at the lower end. The report aims to review platforms and their use in detail to understand the adoption and approaches across industry, while I will also aim to provide relevant experience from my time working creating platforms and supporting customers with their platforms. This year's report had its survey conducted online from September 14th to October 25th, 2022, and respondents were gathered through 2 approaches, a snowball sampling method and a professional panel. Snowball sampling is a process in which respondents are encouraged to share a survey with their networks, causing the sample to grow like a snowball rolling down a hill. Promotion was done via various sources, emailing lists, social media, and some of our partners. The professional panel reduces our sample bias, maintaining a quality engagement membership of various levels of practitioners, all recruited via non-profit methods. We also included a control group of similar participants who do not have platform teams at their organizations for comparison. A balanced geographical spread was achieved with a mix of small, medium, and large organizations, and although as expected, the technology industry was the largest responder, a solid mix of sectors was polled, as well as a cross-section of roles of these 438 respondents. The first finding was most platforms are relatively new. Only 19% respondents reported that platform teams were established more than 5 years ago. Large-scale platforms have predominantly been the domain of the relatively new big tech companies, and the reality is there aren't that many of those companies compared to the much larger set of enterprise companies now developing their platforms. This feels similar to when DevOps itself was first being adopted, and some might worry they weren't a Google or a Netflix, and they were behind with the trend. But exactly as now, the adoption by larger enterprises followed these big tech companies. For most, the time is now to adopt platforms, with 70% seeing platforms created at the right time, 23% believing it was too late, and only 6% reporting too early, highlighting how few teams regret the adoption of platforms. Looking at the main reasons for creation of a platform team at these organizations, they're unsurprising. The need to increase the speed of delivery, featuring most at 22%, followed by the need to scale at 18%, and engineering's taking on too much work, featured along with various points around duplication of work, cost control, and then influencing factors such as consultants or leadership wanting the practice to be delivered. The key goal of the platform team being problem solving at 54% reflects how platform teams aim to prevent other teams from having to keep repetitively solving common problems in isolation. The rest of the answers of the key goal of the platform team can be seen around enabling the use of the platform, with education and empowerment of developers and product teams featuring prominently at 47% and 40% respectively. 46% then answered setting and promoting best practices was key. What we're seeing here is more people-centric approaches naturally following on from the previous DevOps implementations we saw, where enterprises were too technology-focused over people and stalled their DevOps journey at a middling level. Looking now in terms of the purpose and structure of the platforms, what we can see from the capabilities and services offered by the platform is the provision of infrastructure for developers is key, with deployment, operation, and monitoring and security being identified. But merely providing developers with the ability to provision infrastructure, although a necessary step, is not sufficient. Teams must be able to deliver value to their users independently. And that's where these things being developed together in a workflow that ensures that from the moment they receive their infrastructure from the platform, they can actively perform actions and do not have to go out looking for manual steps to truly enable themselves. Looking more at the structure of platforms and how many platforms organizations have, the majority, 57% of respondents report they have between 2 and 4 platforms, while 30% have 5 or more. This indicates platforms are emerging from multiple areas of the organization. This can happen in a number of ways: organically from value stream developer teams who are looking to share solutions with each other, from advanced operation teams with a trusted reputation in their organization, or from a top-down approach by progressive management. We believe this number of platforms depends on the context, and everything should not be forced onto a single platform, or this could hamper development. It can also be seen that 82% of platform teams are centralized. And what we mean by centralization here is that a platform team supports various business units across the organization, as opposed to just a single business unit. This pattern of centralization seems increasing over time, with 52% reporting increases of centralization and 36% of those already with a centralized approach believing the platform would be better if it was even more centralized. With decentralized teams, we see 37% who believe it would perform better if they were more centralized as well. And in this case, it's both users and operators of the platform teams reporting this. So this is not just operators looking to get a greater control, this is users looking for better performance. Although there will always be cases that decentralized teams are required, with certain jurisdictions requiring legal separation, such as geographical requirements for work to be performed by citizens of a certain nationality within the country, or for splits between sensitive departments, such as the trading arm and the retail arm of a bank. Looking now at the benefits of platform engineering in terms of DevOps adoption and the development velocity, it's been overwhelmingly positive. 93% of respondents reporting that the platform team adoption is a step in the right direction, and 94% agreeing the concept is helping the organization better realize the benefits of DevOps. Within this, it's noticeable that 53% of organizations that have been using platform engineering for more than 3 years report speed has improved a great deal, compared to 35% of organizations that implemented platform engineering within the last 3 years. Creating this level of change this quickly in large enterprises is impressive, particularly when we compare it with previous efforts with Agile and DevOps, where some organizations spent 5 or 10 years achieving very little organizational-wide success. This pattern of the lifespan affecting the confidence is seen again when survey respondents are asked about the future and how platforms will meet their goals, with a major boost from 56% completely or very confident the platform will meet its goals, going to 73% after 3 years. This is unsurprising given how cyclical our industry can be, that confidence increases over time. But there's still a high degree of confidence in platform engineering ability to meet organizational goals, regardless of how long the platform team has existed. It's also important to consider with this to get true buy-in from developers and operators. They've got to really believe the platform is something that will be lasting and will be developed, not something which will only have a couple of years' interest before leadership moves on to something new and something is more fashionable than platform engineering. We can also see it's a major challenge for organizations to create optimizations outside of single teams. So it's really impressive to see 30% of respondents believe the whole company is best served by platform engineering. Now, it's unsurprising to see that after that developer teams are the next best served, with the focus of platforms improving the developer experience. Looking at the relatively low score of 14% for infrastructure teams, we should understand the fact we don't deploy infrastructure just for its own sake, but to deliver value on top of it. So it's not a surprising result. Again, the lifespan of the platform has a huge impact, with organizations over 3 years old reporting at 36% that the whole company benefits compared to 25% at under 3 years. Looking now at the core issues and priorities of platforms, it can be seen that setting expectations and creating awareness of the platforms is key. Even in organizations which have started with rudimentary platforms for deploying infrastructure, the expectation needs quickly reset once they've worked with modern platforms, and especially when they can do direct comparisons with services such as public cloud. I personally experienced outrage at the first outage of the IaaS platform I worked on, which, despite being recovered well within its documented SLA, far ahead of how the old platform performed in terms of reliability. But in the absence of us having those full discussions with users to set their expectations of working pattern and performance and stability, they saw the system as something which should have been working near 24/7. And as highlighted by the 32% of correspondents angry with the lack of communication around changes to the platform, they will rightly assume how the platform works today is how they should invest their automation and integrations with the platform. And this can also be seen in the resistance to the platform team adoption being another top problem. As we already discussed, there can always be a fear that the platform will just be a temporary focus, which is not worth the developers investing in. Fortunately, we can see in terms of the priorities for platform teams over the next 12 years, they seem to directly answer these problems, with efforts to increase awareness of the platform capability as a top priority at 47%, and setting realistic expectations for the platform team's role at 44%, and then working on further to expand automation and features of the platform and following industry trends all highlighted, which should allow the platform to be continually evolved to meet developer and user needs. Now, the challenge that can be seen from the problems and priorities is all around how is the platform truly manage the product. With only 66% of respondents strongly or somewhat agreeing their platform engineering team has a product owner who can evangelize the platform service, this would seem to be a major challenge. This is reflected in the fact 43% of respondents are very or somewhat concerned the platform team will not evolve quickly enough. Treating your platform as a product is a key tenet of modern platform engineering. Yet while this is generally well understood, the data tells us that organizations are underinvesting in product management skills and their platform teams and capabilities. More worryingly, nearly half, 48% of respondents agree that senior management of their organization does not understand the value of platform engineering. And a similar degree of respondents themselves, 51%, admit they are sometimes equally confused about the concept. This points towards an underinvestment in the product manager role again, which requires good skills in effectively disseminating information throughout their organization about the platform. So while we have clearly seen early and positive starts for platforms and platform engineering, there's no room for complacency. Young platforms should expect rapid growth as they're evangelized, and if the platform team is not well invested in, this could result in stability issues and communication problems and a struggle to keep evolved. As was previously mentioned, industry and company cycles can affect the focus on product. There can be a huge temptation by management to view platform as technically delivered and not needing this ongoing investment and spending. I've already seen successful platform managers face redundancy as complacency sets in and the platform is assumed to be something that can be delivered, something that has been delivered. If platforms fall back like this to this fully technology and project-based view, they will fail to evolve and fail to meet ongoing customer demands. And this would remind me of my own old-style platform experience I worked with when we had to receive project funding for every major OS release or change the key components to keep upgrading our platform, and it was a never-ending struggle to stay evolved. Now, of course, the most key of all to understand platform engineering is that it's not new, and DevOps isn't dead. This platform approach is not at all new, but the surge in its popularity is, particularly in the enterprise space, with so many large companies having experienced the struggle to gain the full benefits of DevOps across their organizations, and platform engineering proving itself so able to deliver very quickly. This is what's resulted in the argument that DevOps is dead and that the modern platform engineering has replaced it. We don't see it this way. DevOps has always borrowed from other movements such as Agile and Lean, and platform engineering is just another one to add to that list. So a full copy of the State of DevOps report can be obtained from Puppet's website, the listed URL. I'd like to thank our sponsors for their support of generating this report, and I'd also like to thank you for your time today.
Hi, welcome to our talk on how to make a business case for your internal developer platform. I'm Andrew Gunch. I've spent the last 4 years as the Director of Engineering at AdHoc. I oversee platform engineering teams here at various government agencies, including having started and led the va.gov web platform. Before AdHoc, I worked at Google for a number of years, leading technical projects across a variety of platforms, including streaming media platforms, cloud UI platforms, and API platforms.
And I'm Kendra Skeen. I'm the Director of Product for AdHoc's Federal Civilian Business Unit. Previously, I was a product lead for the state of Georgia's enterprise web platform, and then I spent 3 years supporting the VA's Lighthouse API platform. I'm now supporting product teams across our federal civilian programs in areas such as GSA's Search.gov and the U.S. Office of Personnel Management. This gives me a good view into a variety of customer environments and challenges that teams face. So a little bit about AdHoc. We're a modern U.S. government contractor whose mission is to empower customers to deliver digital services that promote the general welfare. We see digital services as technology that enables effective interactions between organizations and the people they serve. You're here today because you already love platforms. You know what a platform is and the value an internal developer platform brings to your organization. You're already thinking in terms of scaling impact, solving problems once, and managing reuse. But sometimes it can be difficult to justify platforms to management, especially if they only see it as extra overhead that's not directly building your business's applications. So, how do you justify and explain the value of investing in an internal platform? We'll use this time today to talk through a range of justifications and arguments for platforms that we've seen resonate with senior management, such as CIOs and other leadership, across our experience with public and private sector organizations. The justifications we'll dive into today are around scale, cost, risk, and governance. But when thinking about which ones to pitch to your leadership, this is where knowing your audience will be critical. What's important to your leadership and how do you speak to that? For example, in AdHoc's work with government agencies, we've often found that risk, compliance, and control are more important to stakeholders than cost savings. But in your private sector business, it might be that velocity of shipping features and cost of implementation are most important. So you're going to want to mix and match and use the justifications that are most helpful to your case.
When we look at Puppet's recent State of Platform Engineering report, we find a few nuggets that we can lean on to understand what motivates most organizations to platformize their technical stack. In particular, when we're thinking about how you frame a business case for your platform strategy, we can use the findings from this report that about 60% of the reasons for creating a platform speak to some level of speed of delivery and scale as top priorities. So let's talk about how you can pitch scale as a differentiator. We already know that scale is a core function of platforms, that platforms are about solving problems once and having teams build on that common infrastructure. Even though this is a core concept of platforms, there's a few slight variations on how you can pitch that to management. First, you might talk about how a platform can increase the velocity and effectiveness of individual application teams. Because your users aren't starting from scratch, they get to use common infrastructure. And that means they're already further along when they get started. Because of this, you can scale the number of teams moving things forward more quickly. Next, you could talk about it in terms of increased velocity of the overall organization. Specifically that the more application teams the platform supports, the more those savings for time and effort spread across teams, and your platform's effectiveness multiplies. Finally, you could pitch scale in terms of talking about how platforms enable your teams to deliver more business value quickly. Because your platform team's taking on more of the common infrastructure, this frees up your development teams to focus just on business value by removing distractions around infrastructure and operations. Now, depending on your environment, you might be able to estimate the amount of time teams currently spend at the bottom of the stack, and therefore make a case based on the time and effort you'll free up per team through implementing a platform. One way we've seen this justification developed is to survey application teams and ask them how much time they spend struggling with tooling, infrastructure, and deployment tools, compared to how much time they spend working on their primary application. So using that data, if you can then show that implementing a platform will reduce that load, you can argue that you'll free application teams to focus their attention on the business value of their applications. Next, we're going to show you a pair of slides that we've used to convince technical leadership of the value of investing in more platformization through talking about scale like this. First, we analyzed this client's software ecosystem to learn how application development was happening there. We found that application teams were implementing a lot of basic infrastructure themselves. They were setting up their own deploy pipelines, they were doing their own monitoring and metrics collection, etc., in addition to their main focus of building their own app. We also found a lot of common infrastructure needs that weren't implemented at all. Things like secrets management and log aggregation that teams were left to their own solutions for. We showed the client this diagram that shows all the infrastructure an application team ought to have to deploy and operate their applications in production, and then talked about how little infrastructure their platform team was currently providing. This highlighted how much infrastructure each application team was having to manage themselves for their apps, and often implemented different ways across their 50 different app teams. After that, we contrasted this future vision of what it could look like if their platform team instead took on more of that common burden by owning shared tooling and providing that tooling as a service to the application teams. This helped us illustrate what it could look like if their application teams were able to focus on just delivering business value. The message resonated with our stakeholders, and afterwards it motivated them to decide to grow their platform teams.
Next up, let's talk about cost. If cost savings is important to your leadership, there's a couple of angles that you can use to pitch your platform. On the one hand, you have cost savings through the scale that Andrew just talked about, reusing infrastructure across application teams. So the more teams you have sharing that infrastructure, the more you save in build costs. On the other hand, you can use the centralization your platform brings to create opportunities to help with cost. That might include applying cost monitoring and controls across your existing applications. So if cloud resources are centralized, you gain visibility across your enterprise to see where cost hotspots are, and then you can address those. Centrally managing cloud resources and how access is handed out allows you to set up restrictions on more expensive services, or to make sure billing alerts are configured so you know when a team's spend starts to spike. Infrastructure centralization also gives you opportunities for global cost optimizations. For example, at one client where developer working hours were consistent each week, we found that we could turn off unused cloud development resources on nights and weekends and save up to 30% on the bill for various AWS services. We couldn't have done that without the central lens of a platform team that helped us identify that opportunity and implement that saving strategy across the enterprise.
Next, let's talk about risk. One thing we found particularly effective in pitching platforms to management is framing around risk mitigation. Depending on your organization and its history, management might be worried about different kinds of risk. Successfully shipping products first, like, can you actually get your applications built on schedule? They might be worried about operational risks around infrastructure changes, like, do your deploys and releases happen safely? They might be concerned about reliability risks, like, are they confident that their systems can stay up under load? Might be worried about security risks. Are systems resilient against intrusions? And are best practices being used for secure architecture and design? And finally, they might be worried about compliance risk. Maybe that's things like accessibility, or maybe the business has specific compliance requirements they need to meet. This is where to listen for what risks worry your executives most. What things do they say that they don't want to end up on the front page of the New York Times? Once you're thinking about that, well, how do you articulate how platforms can help mitigate these risks? For shipping risk, we just talked about scale and velocity. You established an infrastructure stack that you know will meet the needs of application teams and made it possible for teams to reuse proven components to help them build and deliver as quickly as possible. Operational and reliability risks are addressed by centralizing infrastructure for things like deployment, monitoring and alerting, cloud and infrastructure management. The division of responsibility you get from a platform helps make sure you're keeping your focused expertise on those areas in your platform team, instead of expecting application teams to all be operational and reliability experts. For security risks, you can make a similar argument that centralizing security-sensitive infrastructure, for example, things like identity and authentication systems, lets you concentrate your org's security expertise on the systems that need it most and have the whole ecosystem benefit. Again, doing that centralization rather than expecting all your application teams to be security experts. Finally, compliance risks are best addressed with governance, which Kendra will talk about more next.
Going back to the 2023 State of Platform Engineering report, people said that two of the key goals their platforms support are around security processes, which Andrew just talked about, and setting and promoting best practices. Both of these fall under the umbrella of governance. Governance is the set of standards, tools, and processes used to enforce policies on products your organization develops. Some examples include making sure accessibility standards and security processes are followed, establishing consistent visual designing and theming across applications, or making sure vocabulary is used consistently in user-facing products. This is where platforms come in. When application teams are already using common infrastructure and services, your platform provides opportunities to hook policy and standards enforcement into the product development lifecycle. You can bake it right in. So this is where you can consider what may be important to your CIO. Are there compliance risks that your company is uniquely exposed to that they want to mitigate by making sure applications are following key rules? Or is consistency in visual design, user experience, or even API services across products a key priority? Does your organizational leadership feel overwhelmed at the prospect of managing best practices across teams? These are all things that can be addressed with platform governance, and that can help you pitch platforms as a tool to achieve your leaders' other goals. If you're interested in more on how a platform can support governance levers, look for our other PlatformCon session on a carrot and stick approach to raise the bar on application quality. where we'll dive more specifically into how you can use a platform to support your governance.
In conclusion, you can think about which of these 4 concerns we talked about seem like the biggest pain points in your organization, or which ones resonated the most with you as we talked about them. Those are the things to lean on when you build out your business case. Again, it's important to know your audience. The justifications that worked at one company or with one manager won't necessarily work at the next. Hopefully this all helps you think through how to move your organization forward on their platform journey. If you've got questions or comments, you can find us in Platform Engineering Slack or reach out on LinkedIn. And be sure to look for our talk on using carrots and sticks for application quality. Thanks so much, and we look forward to hearing from you.
Hello, everyone, and welcome to Shift Left, Build It Right. My name is Andrew Duckett, and I lead the developer experience practice at Discover. I'm joined today by Javier Alvarez, one of the engineers leading the delivery of Golden Paths. Now, to start things off, I'll set the stage with our journey and one of the problems we face in our developer experience. And then I'll hand things over to Javier to talk about what we're doing with Golden Paths and how we believe they help. He'll cover some of the practices we put in place so that a small team can scale to meet the demands of hundreds of engineering teams. And wrap up with the impact we think this has had so far, what we think is next, and some takeaways. But before we do that, I wanted to take a minute and talk about what goes on in a developer's mind every day. In the past, before we began our cloud journey, many of these decisions were a little bit easier. And while we may not have loved it, we leaned on technology stacks like Java EE to guide us. Development teams handed many of these non-functional concerns and planning to operations and infrastructure teams. Now, don't get me wrong. We believe the shift to self-sufficient autonomous teams empowered by things like cloud platforms and self-service is valuable. One of the things we don't often talk about is the amount of cognitive load this now places on individual teams. So what do? They each build little knowledge bases to make themselves more effective. Teams created their own documentation, patterns, practices, and little silos, sometimes in GitHub wikis, SharePoint, Confluence, take your pick. And while the information was good, it was difficult to find and rarely consistent. I imagine some of this sounds familiar, right? So we created a place where developers could share knowledge through original content created by Discover subject matter experts. We've got documentation, code patterns, tutorials, and other resources for upskilling, reskilling, and continued learning. We call this place the Discover Technology Academy. Finally, all of the resources and information is in one place. And this is a huge step for us. But the problem we now face is putting the pieces all together. So I'm going to hand it over to Javier and talk about how we think Golden Paths can help.
My name is Javier Alvarez, and I am a principal application engineer working in the Golden Paths team. As the platform evolved, so did the number of contributions as well as the different opinions about building things at Discover. Having many contributions is great, but having too many options and different opinions about how to build something could be overwhelming and not very efficient. Although this presented a challenge, it also offered an opportunity to reduce the cognitive load of having too many options and help developers in their journey of creating amazing software. Hence, we thought that something like Golden Paths could help. But what is a Golden Path? As stated by Spotify, a Golden Path is a step-by-step tutorial that walks you through the opinionated and supported way to build something. At Discover, our Golden Paths are the source of truth to help developers accomplish a specific engineering task. These paths should be to create something, such as an API, a React web app, or a backend component. It could be anything that I wanted to create, and so we think of these as higher order workflows consisting of a collection of step-by-step tutorials that we stitch together to create comprehensive developer journeys that we call Golden Paths. Golden Paths can help us in the following ways. They can simplify getting started to minimize the cognitive load, so we can stop reinventing the wheel and let developers focus on higher objectives. They can turn rumor into recommended, so we can stop rumor-driven development, where the only way to find out how to do something is to ask your colleague. They can also help to reduce fragmentation and inconsistencies by making sure that the tools and services on the path are aligned with the organizational standards and best practices. Our strategy for creating golden paths is guided by the open source principle of trust, transparency, and collaboration. We need the community of developers at Discover to support and participate in the creation of golden paths. So we lead with transparency. Without transparency, it is really hard to grow a community. So we work to provide meaningful context about where we are in the process, how we got here, and where we are going. Having a consistent golden path that provides the information and materials necessary for teams to do their best work enables these teams to collaborate and build upon each other's ideas and discoveries, so we can make more effective decisions and understand how decisions affect us, which can lead to better paths. As part of building this developer community, we want to empower developers to help themselves and participate. This starts by following golden paths to complete tasks, realizing what doesn't work, and submitting a fix in the process. We want our golden paths to be supported by a consensus of members in the community, where we foster productive dialogue about the best way or tools to complete a task. The developer journeys at Discover do involve many different products, and each product team has created their own documentation and standards on their product pages, which they maintain. However, we recognize the need of a single source of truth for developer journeys. The challenge was that Golden Paths team cannot be experts on every area and keep all these paths current and valid. To solve this, we have developed a contribution model that provides a framework for distributing the responsibility that comes with the lifecycle of Golden Paths. But to implement our contribution model successfully, we needed buy-in from our leadership team and sufficient level of technical expertise and experience. And despite these challenges, we were able to secure sponsorship for our Golden Paths team, and through active collaboration with the community, we are driving the evolution of our product. An example of this model could be around teams' responsibilities. So you could say that service provider teams, which are the experts in an area, will be responsible for their individual steps for their products, whereas Golden Path team would be responsible for the overall experience of the paths and any gaps in the documentation. Golden Paths team will also evaluate and archive Golden Paths that are outdated based on technology strategy, product direction, and community needs. And for critical services such as secret storage or API management, it is important that the information is kept up to date by the service provider teams. The contribution model provides clear boundaries of where the responsibility lies within the stakeholders, and it defines the information architecture for Golden Paths that enables our product to scale as other teams start to collaborate and add new capabilities. So, as with any other initiative, we wanted to assess the impact of Golden Paths and make sure that the outcome is valuable to our customers. Before Golden Paths were implemented, an engineer looking to build new things at Discover would need to visit several product pages that had different standards, processes, and forms to be submitted. Then they would ask a colleague how to submit those forms, and if any form was submitted incorrectly, it would cause delays on the process. We have already launched 5 Golden Paths, and we have estimated that an engineer can save 10 hours per component by using the Golden Paths, as they provide context and detailed information on how to build specific things. Now, you could scale this calculation to a company with 500 engineers. You could multiply the savings per component by the number of components each engineer creates in a year, and then multiply that by the number of engineers in the company. For example, if an engineer creates 10 components in a year, the company will create 5,000 components in a year, and each component will require 10 fewer hours of work. Hence, 5,000 components multiplied by 10 hours saved per component equals to 50,000 hours saved per year. And to ensure that our teams are equipped with the knowledge and skills to make the most out of these paths, we're developing a learning module around golden paths that will be integrated into Discover's product team's sprints. So, what's next in our journey? Now that we're working to capture the truth of how the process works, our next stops in our journey are simplification. We want to identify opportunities to automate and streamline our processes. We want to focus on self-service through the scaffolding of apps, services, and ready-to-use templates that contains embedded patterns and policies. We want to reduce the time to hello world to just few clicks so we can let engineers focus on delivering features. To summarize, our takeaways are: reuse and don't reinvent. Use proven solutions as a foundation for new developer journeys. Move towards open models of working. This allows teams to collaborate more effectively towards a shared goal and develop shared expertise, which can lead to long-term sustainability of the paths and better collaboration. Leverage the community. Prioritize the needs of the developer community to initiate new developer journeys and capabilities, but ensure that these journeys are aligned with the technology strategy. And finally, start somewhere. Improvement doesn't have to be an all-or-nothing approach. Starting somewhere, even with the small changes, can lead to big improvements over time. I hope that our experience in this journey inspires others to embrace the power of collaboration through innovative platforms. Thank you for listening, and you can read more about Discover Technology at technology.discover.com.
Welcome to our talk, Yes Sir, I Can GitOps, SDLC Automation in a regulated industry, where we're going to be covering some of the challenges that we have encountered on the process of automating many of the pieces of our process and how we have overcome them through a platform-based approach. My name is Juan. I'm working as a tech lead for the DevOps platform engineering team here at Banking Circle. Been doing that for the last couple of years. Before that, I spent another 2.5 years also working within the domain of DevOps in a different financial company.
And my name is Darius. I'm a team lead in our DevOps organization here at Banking Circle, having a lot of fun with Juan, building a DevOps platform. Before that, I spent 4 years in another financial institution. So I have around 7 years in the finance area, 6 of those in data, and the last one focusing on DevOps at Banking Circle. Now, I assume that most of you haven't heard of Banking Circle. That's because we are a somewhat new bank in the hood. We got our banking license 3 years ago, and all in all, we have been around for about 10 years. And then the question is, what do we do? The simple answer is that we do payments infrastructure. So we make sure that if somebody wants to transfer payments across borders, we do it cheap and fast for them. Now, when we got the banking license, there are many rules that we need to follow because we are in a regulated environment. And as many of the other banks, when you first have to apply the finance regulatory rules, since we don't have a lot of changes, then we applied the good old solution of throwing bodies at the problem. What this means is that we apply the typical pattern of I have a development team, and then the developers write the code, they hand it over to the testing team, they test the code, then they give it over to the QA or the release managers, and finally it goes into the operations team. Now, this is required because we have a rule called segregation of duties, which means that the person that writes the code cannot be the same one that operates the code or deploys it in production. We can also summarize it as the 4I principle, We need at least 2 people involved from different parts of the organization. Now, when we had a smaller scale, we were around 180 in total in the entire organization. It wasn't that difficult because we had 2-3 changes a day, so people could handle those handovers, and it was a lot easier to coordinate. But the organization grew. We are now at about 500, and we aim to deploy as frequently as possible. And the challenge with the previous setup is that it doesn't scale well. First of all, it takes a long time to onboard colleagues to have the different roles. So the tester needs to understand what's being developed. Then the QA and the release manager needs to understand all the stakeholders and what's being developed and what's being tested, so on and so forth. And then at the end, it's handed over to operations that maybe doesn't really know what's even there because they haven't been part of the process. Now, we are in the fortunate position that we have a lot of smart colleagues around that are very creative. They want to make their life easier. And with the approach of having all the operations centralized where all the deployments are going through, doesn't help them get what they need if it's a nice to have. It's something that can maybe save them half an hour a day. And what happens then is that they get creative and they come up with individualized solutions across the different teams. That maybe somebody does a manual deployment, somebody else does a YAML pipeline, another person says, okay, here's my code, please deploy it by putting it on this specific server that will then be picked up automatically at some point. That's one of the challenges. And the last one is that if you have things that are centralized, let's say an agent for your deployment pipelines, and a development team needs a library or something small, if they can't get the help from the centralized team, the operations team, then they will maybe find a way how they can sneak a small piece of code in a pipeline that actually installs that library for them. Nobody actually knows about it, and then they're happy, but that can break somebody else's flow because that library messes up with somebody. So that is what we call shadow ops. And now I'll let Juan say a few words about the solution we came up with.
Yes, thank you. The first idea in the solution was that we need to standardize all of this. As Darius was explaining, having individual solutions to the same problem doesn't scale very well and also requires knowing what is going on. So we decided to have, let's do one thing, let's do it well, and then let's share the thing that we are doing. Let's standardize that across the organization. Then, because we always do the same things, we can put a lot of focus on automating those things so that we don't always have to repeat the same steps in a manual way, but rather we just execute whatever is there because it is always the same steps. This also allows us to look at it from the different stakeholders that are relevant to the process. We can ensure that what we are doing is secure. We can ensure that it is compliant with all of the regulations that we have on top of us. We can check the governance of the process if it needs to change, if something needs to adapt for a new team to onboard it, for example. The relevant people are looking at that process and are approving whether or not changes should be allowed or if there should be happening in a different way. And of course, this process is designed by the subject matter experts. If we are talking about pipelines, we can put the guys that know more about pipelines to work on them. If we are talking about infrastructure as code, we can put some infrastructure engineers to look at the process, at the code that we are writing for that. That is then shared with everybody else, and then they can benefit from that. But it was not enough to centralize it, because what we also want to do, or what we wanted to achieve, is that then people actually use that process that we are centralizing. And that's where we came across the platform teams and the platform-based ways of working. So what we are doing is packaging those processes into little blocks where things are not only automated, but also they are offered so that they can be consumed in a self-service way. And then each of the stream-aligned teams or each of the development teams can consume these blocks, which again can be pipeline templates. It could be a specific repository to take care of something. It could be infrastructure as code modules. It could be many other things. They put them onto their process, and that allows them to build this golden path. That allows them to have a process where there is no manual intervention unless absolutely needed for regulatory reasons, and when there is no handover to another team so that that team takes care of something else. Instead, everything that should be compliant, everything that should be secure, everything that should happen in a specific way, it's coded into the process.
And now, if we are to take a concrete example, if you remember back in the beginning of the presentation, we talked about the handovers from team to team. Now, one example that we have is these automated changes. What this means is that we've removed a lot of the people that were involved in the process, replaced them with a flow that's defined more or less the same for all pipelines. That first you build, then you test, and then you deploy to various environments. And then we need to satisfy the 4I principle, or segregation of duties, as it's called. And that's where we put right before production an approval from the product owner. Now, the beauty about the solution is that the product owner works very closely with the development team. They talk on a daily basis, but he's also sitting in a different part of the organization. So we do have the segregation of duties that the regulators ask us for. And then from a pipeline, what we do is we get the product owner approval. Then once he approves, we have a stage that goes into our ITSM tool and creates the change ticket. We deploy, we validate in production. And then we have another stage that goes back to the same ticket and says this was fine or this was not fine. It failed for whatever reasons. The beauty about it is that the stages that we're interested in, the ones that connect to the ITSM tool, those are independent from the actual production deployments and the validations. So it can be whatever you want in there. If you deploy Azure App Services, if you have PowerShell scripts, if you have Ansible, we don't care. From a platform perspective, we give you these stages. This is the framework that you need to follow. And then the developers are happy and they can deploy very fast. And then the product owners are also happy because they're empowered to approve and release when it makes sense for the business.
Another successful example of a part of the process that we have implemented with this platform-based approach is our GitOps feature flags. When we are releasing code, we are decoupling the deployment of that code and the release of that code by using feature flags. So basically, following the arrow that Darius was showing before, the code is deployed. We also do this in a non-disruptive way using blue-green deployments to ensure business continuity. But then the functionality is not yet released because it's behind a feature flag. And then it is only when the feature flag is flipped that that functionality is released. What we are doing with these feature flags is defining them as very simple JSON files that we keep in a Git repository. This means that whatever is in that Git repository becomes the single source of truth. The main branch specifically of that repository contains all the flags for the different services that that team is using, and then their current values. This also means that anytime that there is a change in this repository, there is a change in the source of truth. Effectively, there is a release of a particular functionality. And this is logged as a commit because it's still a Git repository. So suddenly we have a log of every release where we can see what has been deployed. And the contributions to that main branch can only happen through pull requests because they cannot happen directly. This means that there needs to be a particular person that creates this pull request. And then there's a different person, again, typically the product owner, that approves this pull request. So we have the 4I principle. We are decoupling who is requesting the release with who is approving it. And all of this is logged naturally as part of this Git repository, just because that's how it works. The moment any change is introduced into master, we have a pipeline that is updating the flags and that is actually releasing the functionality. But there is no extra approval needed on that part. What we are using there is the automated changes. Yes, they are logging into our ITSM tool the fact that we are releasing something, but there is no need for anyone to approve that process or to put any more blockers throughout that. And the beauty of this, again, is that it is a platform-based approach. So we have one repository that includes all of this. Any team can clone that repository, introduce their specific parameters, their specific flags, their specific set of approvers, and then they just would be reusing the same solution that we have based on Terraform that everybody else is using. They would be interfacing it in a very simple way through JSON files, and everybody would be doing this in the same way.
It's been a few months where we've been running with these two cases throughout the organization, and we have learned quite a few things. The number one and most important is that people really matter. It's all about the people, people, people. First of all, we need to focus on the user experience. Like, we want to make people's life easier. They should be able to deploy easy and fast to production. And the developers need to be happy, the regulators need to be happy, our internal audit need to be happy. But the thing is that once we have rolled out the automated changes or the GitOps feature flags approach, then we also have to go back and hear, like, okay, how is it going? Like, is it smooth? Is the process okay with you guys? Are you stuck in something? Do you not understand, like, the approvals, maybe how that work and why we have done these specific stages? So there's always an ongoing conversation. Because we want to share it out as a platform, the beauty of the approach is that once we onboard a team, then they talk to their neighboring teams. And if somebody hears, like, hey, I heard that you guys are doing that automated changes, which is really cool, can we also get on it? The thing is, they can help each other because they talk together, they talk frequently, and we are sitting in the platform engineering team preparing the tools, but then how it grows, it's organic. So they can help each other. And it's not dependent only on us to implement it, but also on the teams helping each other. But for this, it's really important that we focus on the documentation, on the public relations part, that we actually go out and we present it. So that first team actually figures out that there is something they can work with. And then as a small conclusion for our lessons learned, it's all about the people. Like, we need to listen and work to them. Then the process is important, that it needs to make sense for various organizations. And then the product comes last, as the technical implementation is not that complicated.
Yeah, and in conclusion, the fact that we need to be compliant, the fact that we need to be secure, the fact that the process needs to be standardized, doesn't mean that it needs to be slow, that there needs to be a lot of people involved in it, or that things need to happen manually. It's actually the other way around. The process becomes more stable and more secure and more compliant because everything is coded and automated. The best way of scaling this so that everybody is following this process is putting it in this self-service way, having a platform-based approach so that everybody can benefit from it. And yes, what we have discovered is that, yes, sir, we can GitOps. Thank you very much for listening, and enjoy the rest of your PlatformCon.
Hello, my name is Brian Leatham. I'm a senior software engineer at Netflix, and I'm here to talk to you about the developer portal we're building out for our Netflix engineers, specifically how we're leveraging end-to-end workflows as a mechanism to attract users to our developer portal and to keep them coming back. The problems that we're solving with our developer portal, they're not new. They're probably really similar to the problems that you folks in turn are solving with your developer portals. They include things like product discovery, knowledge and support. So we have a number of products and experiences for our engineers as they manage a software throughout its software development lifecycle. They can work with many different tools across many different UIs and have a disconnected experience between those UIs, between those tools. Not all UIs are going to use the same design patterns, the same component implementations. And folks are not able to leverage or build up and leverage a muscle memory as they flip between tools. Documentation for the tools can be out of date or missing, isn't easily searchable and discoverable. So this is something that we're trying to resolve for users. Finally, the goal of managing multiple services and software is a capability we want to provide. Our platform tools to date tend to focus on a single software experience. They don't target multiple softwares or target the use case of a team that owns many services and has to end up repeating actions many times over their fleet of software for the different services that they own. So to solve these problems, we developed the Unified Developer Experience Strategy. This goal is to solve a number of these concerns. The strategy is multifaceted and forms some guiding principles for us as we bring these experiences together. So things like a common information architecture and design patterns across our tool suite will improve the usability of our tools for our users. A common context and a set of shared services between the tools will allow users to take the context, take what they're working with them along between tools, and not have to reset that context at every entry point into a new tool. Lastly, we recognize that branding is important. And so we chose to name our developer portal the Netflix Console, a rather unbranded name. And we want to focus on the capabilities of Console rather than individually branded products within it. In order to get a usable portal in front of our users in a timely manner, we targeted an MVP, a minimum valuable product. So what's the smallest thing that we could build that would actually provide value to our customers? We wanted to start with a connected experience, right? So we have a number of tools. If we could bring them together through a common front door, provide context to our users, allow them to do some initial exploration and discovery of the state of their system, and then from there transition into the existing tool with deep links to pick up the context to where they're coming from. And that way give folks a unified entry point into the tools that they work with on a daily basis. Finally, I want to add that our MVP was built with federation top of mind. We wanted to leverage our provider partners in their contributions to the console to help us scale out across all aspects, across all tools that we have in our platform offering. To do that, we leverage Backstage plugins on the front end and a software catalog for federated GraphQL in the back end. With our MVP, we deliberately chose not to simply lift and shift experiences into our console. Rather, we wanted to rethink the abstractions and take the opportunity to act on a backlog of user feedback, providing our users with a better experience with the new console MVP, rather than simply pulling things together. A good example of this is our reimagined abstraction for our Spinnaker pipelines. We created this timeline view, which shows the execution of a number of pipelines associated with a piece of software, where we can quickly at a glance see when they're executing, identify failures, and give folks the ability to dig into a particular pipeline execution, understand what happened, and from there link out to Spinnaker and other tools where they can troubleshoot or get more context of what's going on. So we built our console MVP with a number of such experiences. We put it in front of our users and we got some feedback. While users were overall impressed with our unification approach and a sense of excitement for the possibilities, our users didn't feel our MVP was compelling enough to pull them away from their habits and routines they have in existing tools. They already knew where they had to go to accomplish the task that was at hand, and console wasn't providing anything new above that, aside from this unified, this connected front door. So we found ourselves with this cold start problem. We needed console to be the place where developers are to attract more provider contributions, yet we needed enough critical core functionality to bring those users in. We weren't getting the sticky user sessions, the returning customers with the connected approach we'd taken so far. So we decided to amend our approach to target end-to-end workflows. These are journeys that can be completed completely within console and are solely available within console. They're not workflows or journeys that can be accomplished in another existing tool. So then as users come back to console to complete these end-to-end workflows, they'll discover the other connected experiences we provide, give us feedback, help us improve console overall, and make it more valuable for our users. We identified 3 mechanisms to introduce end-to-end workflows in our console. The first one I want to call out is creating new workflows. Perhaps the most obvious choice. If you need a new experience in console, let's create one from scratch. The second one is to lift existing workflows from other tools and bring them into console. And then the third avenue for introducing end-to-end workflows in console is the fleet management capability. So bulk action workflows that allow users to manage multiple applications at one time. So let's dive into these in more detail and talk through some examples. So new workflows, as I said, they're the obvious choice for bringing workflows into Console. They're a great opportunity to solve cross-organizational concerns and associate Console with an altogether new experience. However, it is a costly approach. It requires a lot of design and implementation time. One of the new experiences we provided in Console is our campaign and migration tooling. So the goal of the project was to address organizational tech debt by providing tooling and holding teams accountable for the software that they own. We gave them a set of migrations that they had to work to bring their services, their software up to date, up to a current state. And we tracked their progress and gave them tools to see work outstanding to complete these migrations. We also gave tools to the leadership team so they could look at their organization and understand where they might need to dedicate more resources to complete these migrations. So far, this effort has been tremendously successful, bringing in more than 500 monthly active users. The second approach I want to talk about is the lift and shift approach. This is a strong pivot from our initial strategy where we insisted on rethinking the abstractions around an experience before bringing them into Console. However, there are some criteria that had to be met, and this approach doesn't apply evenly to all experiences. For instance, the technology used to implement the experience has to be compatible with our Console. For us, this means the design system and the component library, and the backend APIs have to be compatible. For instance, we leverage a lot of GraphQL in our Console, so experiences using GraphQL are better aligned. And finally, the abstractions need to be sufficiently self-contained in the system that they're coming from to be able to survive the transplant. But when it can be applied, the influx of users you get is immediate. You're taking users who are already using a workflow and you bring them into Console. We're able to leverage existing communications and notification streams to redirect traffic to Console. One great candidate for this lift and shift strategy is our managed delivery experience, initially built into Spinnaker. So it was developed using our Hawkins design system and speaks directly to a GraphQL backend. So it was a great fit for lifting into Console. As the sole provider of managed delivery experience, users will be directed to Console through the Slack and email notifications that they get when they need to perform actions like manual judgments or investigate failed environments. Observability tools are another example of a set of experiences we were able to lift into Console. With our observability tools, we integrated them using Webpack Module Federation to bring the experiences into Console at runtime. So Module Federation is great. If you haven't heard of it before, think of a SPA, single page application that retrieves a set of bundles from a front-end server to render the experience for the user. As they navigate through the application, the browser will download additional bundles with modules and components in them to flesh out the application experience. With Webpack Module Federation, we enable the browser to get those Webpack bundles from different front ends. We pull down the modules and components, mount them in the application, and we give users a single page application experience that is served by multiple front ends. So while it still required technological alignment on the design system and build tools, for instance, we still need to be using the same Hawkins design system and component library, it requires no movement of code like the managed delivery use case we just talked about. Lastly, we looked at fleet management and bulk operations as a mechanism to introduce new workflows in a Console. Here you see the overview page for a software collection. This enables users to assess the state of their software in their collection at a glance. There we provide these overview cards that give them the ability to see all the software in their collection and then drill down into more detailed pages showing more information of the software in that state. Here's an example of the managed delivery experience that we talked about in the collection view. So here I have a number of software available in this collection, my team software. And then I'm showing folks the state of the environments of the delivery for those softwares. Before console, this isn't something that was possible. This multi-software, this collection view. Users were only able to find this information one software at a time. The last experience I want to call out is our new ownership experience. It's an example of both a new workflow, something we developed for console, as well as a multi-software or bulk operation workflow. So improving software ownership is a cornerstone to many of the experiences we're building out in console. Campaigns, migration, and team software pages all rely on accurate ownership data to deliver an optimal experience. With the ownership experience we built into console, we've given users the ability to claim software, to give it to another team, or to flag it for review. I don't know whose software this is. You go figure it out. This is all done through a series of bulk management workflows, whereas before console, ownership could only be done one software at a time. So what's next? In our journey so far with our develop portal, we've tackled the manage and observe views, giving folks the ability to assess the state of their software. In this coming quarter, we're going to tackle the discover group, help folks identify the tools and services available to them to build out their software and to maintain it. And lastly, we want to get to the create and modify verbs. Thank you for sitting through the session. I'll be available in Slack after this to answer any questions or hear any thoughts that you have on the topic.
Hey everyone, welcome. My name is Rainis. I am a software engineer on the platform infrastructure team at Affirm. And in this session, I'll be talking about where we went wrong in building a self-service platform on Kubernetes. For those of you who don't know, Affirm is a buy now, pay later service. And if any of my coworkers are watching this, no, this doesn't mean that I think we did a lot of things wrong in our platform. In fact, I think we did a lot of things right. But I do think the most interesting lessons are taken from where we went wrong. So with that, first I'll be talking about a little bit of background and give some context on what our infrastructure looked like before Kubernetes. Then I'll talk about some of the principles that we focused on when building out our self-service platform on Kubernetes and what that platform looked like. Next, I'll be touching on the problems that we solved as well as the problems we created. And finally, what we're all here for, which is the lessons and the takeaways and what we can take from that in developing our future platforms or iterating on our current platform. So a little bit of context. Obviously, this is a very simplified model of what our infrastructure looked like, but we run a lot of our infrastructure on AWS, and we were using EC2 instances to run our services, and these EC2 instances were grouped by AWS auto-scaling groups. We were also running salt stack to configure all of our EC2 instances, and so we'd create salt states that then we would push to the rest of the EC2 instances to actually configure them. There might be a few issues that could come from this model, but for the purposes of this, I just want to focus on a few. The first is that creating a new service could take months. If an application developer wanted to create a new service, they would create an infrastructure ticket, and then an infra engineer would get assigned to that ticket, and alongside their other work, they would work to spin up that infrastructure. This could include spinning up load balancers, setting up target groups, security groups, the EC2 instances and the ASGs, creating new salt states, then running those salt states. There was a lot of work involved in setting up a service and a lot of back and forth between the application developer and the infra engineer. And this could take months. Obviously, nobody wants that, and neither party was happy with that. Another issue we had was that scaling was slow and manual and required the infra team to go in, learn about each service, and then set the desired replicas for each service. This is a lot of work and required a lot of the infrastructure team to learn about the specifics of how each application run to determine what the scale needed to be. And then finally, I alluded to this before, but doing anything required going through infra. Even something as simple as viewing your machine logs required submitting a ticket, waiting for an infra engineer to then send back a file with the logs that you were interested in. So with Kubernetes, there are a few guiding principles that we thought about. One is that we wanted everything to be self-service. We wanted people to be able to do everything on their own. We didn't want infrastructure to be a bottleneck. We also wanted them to have the autonomy to change their service as they saw fit. We wanted them to be able to configure their service in different ways, have the flexibility to set up or change their infrastructure, tweak certain things depending on the needs of their particular service. And then with these two things, with self-service and autonomy, we knew we had to implement plenty of guardrails. We wanted to make sure that no one service could impact the other, and that no application developer could either advertently or inadvertently affect some other service. So with self-service, the first principle, one of the things that we did to work on that was we created templates. So we knew that for each particular service, there were a bunch of Kubernetes files that would define that service, from the deployment, from horizontal pod autoscaler, to pod disruption budgets, etc. And so we created templates for those resources. And then the application developer would fill out a configuration file with a bunch of input fields. And then we would take the configuration file, those inputs, along with the templates. We would use Mustache and Customize to then create the final Kubernetes manifest. And then those manifests would be the ones that would be applied. So with this, we allowed application developers to just fill out basically a bunch of input fields, pass that onto our templates, and then create Kubernetes manifests. We also, as I mentioned, wanted to give application developers autonomy. So two ways that we did this was, I mentioned this before, defining the inputs to those templates, but we also gave them the ability to add their own custom Kubernetes manifest. So if they needed some other service or some other way of defining the deployment that was different than what we had, they could do so, and they could just add their own Kubernetes resources. We also created certain custom controllers. So one example of this is we created an AWS IAM controller. This was before AWS had its own ACK controllers. And this controller allowed service owners to define the access needed for their service, and it would create the corresponding IAM role. So we were trying to automate any of the creation of external resources. And then finally, we set up some guardrails. And some examples of this include using Open Policy Agent Gatekeeper to restrict a bunch of things or validate things. So we were restricting image repositories. We were preventing collisions of URIs of different public services so that each service could define their own public URIs without colliding with any others, and keeping those unique. We were validating configs or fields in the horizontal pod autoscalers against pod disruption budgets, and more. We were also obviously using Kubernetes RBAC, and we also created a custom controller per namespace that would add resource quotas, create role bindings from a teams list, and kind of set up a bunch of other limits and configurations that we felt was necessary. So obviously we solved some problems, but with any new system, we're also creating new problems. So some of the things that went well is we were using industry standard tools to provide guardrails. And we're doing a pretty good job of making sure that no service was impacting any other service. We also were automating the creation of external resources. You can recall the AWS IAM controller that I mentioned. That's just one example of us trying to automate the creation of external resources so that application developers could work within Kubernetes and didn't have to go into the AWS console, didn't have to go into any of our other infrastructure knobs to turn those. They would just had one place, one platform where they could change or create resources. And then users of the platform also had the freedom to customize their application as they desired. There were a lot of input fields that they could modify, but in addition to that, they could also just create their own Kubernetes resources if the templates that we had built did not work for their use cases. So all of that was great, but our platform actually didn't end up being built for the most common customer. Obviously, our customer here is the application developer. And when thinking about what our common customer was, it was a product engineer whose priority is shipping new features. And they want to ship features as quickly as possible, as easily as possible. They're not necessarily worried about the infrastructure that those features are running on. Of course, there are always exceptions, and for certain things, some of that is required. You have to think about that performance. But the reality of our situation was that the majority of product engineers wanted to focus on the shipping new features. And our common customer was also someone who didn't have much of a Kubernetes background. In fact, most of the company didn't have a Kubernetes background, and we were all learning as we went. But this was something that we didn't fully appreciate or think about when we were designing the platform. So some of the problems. One, there were too many knobs to turn for this common customer. Most people who used it didn't want to change all of the input fields. Some of them didn't even know what to set as some of the input fields. So that really became an issue for us. Our platform also required use of Kubernetes, and it required some Kubernetes knowledge. So at first, we actually were doing a lot of work to try to educate people on Kubernetes, and we thought, this is the way forward. People should learn the ins and outs of our platform, not just how to use it, but they should learn what it's running on. They should learn Kubernetes, and we created videos. We had a lot of documentation. We held office hours. We did a lot to try to spread this knowledge, but the fact of the matter was that our common customer didn't have this knowledge to begin with. And we were also giving them too much autonomy. Most people actually didn't want to change all of those fields. They wanted something that was easy to set up and so that they could quickly build new features. So with that, some of the takeaways. One of the things that we learned from this experience is building a shallow interface. So what do I mean by that? I mean that users should be able to get started as quickly as possible. We need to provide defaults everywhere so that a user doesn't need to set all of these inputs in order to just get started. If we want, they can then change that later, but to start off with, there should be defaults for everything. And users should be able to start small, but then go more complex as desired. So with this last point of starting small and then going more complex, you might be thinking, okay, well, you're kind of telling me to just do both. Keep it simple, but also giving them flexibility. It seems like it's a hard thing to achieve. So how do we achieve this balance of having something that's simple, that's easy to get started, that's not a burden for the customer, and that provides standardization, but also gives them some flexibility, some finer-grained control, and allows users with more complex use cases to also take advantage of the platform. My approach to this is to provide a shallow interface, but then give a shovel for the rest. So what does that mean? That means that the simpler approach is going to work for most of the cases. And in our case, that was probably over 80% of the cases really just needed the simpler approach. And so they just needed the shallow interface. But we still need to provide some sort of escape hatch for other users who need, who have that special use case or who want to have finer-grained control over the infrastructure of their service. Essentially, this is because people who want the flexibility will figure out a way to get it. So the main thing was building for those 80% of the use cases and simply having an escape hatch. For us, there was no need to build out all of these features for those complex use cases. That was something that we could work directly with the people that had the more complex use cases. And honestly, the people who do have those cases are also the people that are more likely to go under the hood and learn the intricacies of the platform and are able to contribute to the platform to make those use cases possible. With that, that's how we were aiming to build a shallow interface, but still providing a shovel for the rest. And that's it. Thanks so much for listening, and reach out to me if you have any other further questions, and hope you enjoy the rest of the conference.
Hi, everyone. Good morning, good afternoon, and good evening. Thanks for attending PlatformCon 2023 and the session on a blueprint to platforming Kubernetes operations, where we'll talk about the key challenges when it comes to building platforms on top of Kubernetes and how we can overcome those challenges with different design considerations and just some general thought leadership. So when we talk about 4 key challenges that every enterprise needs to figure out, the first one is cluster lifecycle and upgrades. The second one is standardizing software add-ons across a cluster fleet, for example, making sure that they're running on the latest versions. The third one is multi-tenant consumption and RBAC, especially when you're running a shared services platform between different development teams. And of course, the fourth one is developer self-service, especially as you're building out your internal developer platforms, making sure that there's a great DevX that's powering the Kubernetes experience. So let's look at how we can solve some of those key challenges and how we should think about these. So today, developers are being blocked by a lack of self-service capabilities. And when we think about this, we have the CFO, for example, who's saying we need to save on costs, use shared clusters. We have your security teams who are saying we need to make sure teams are compliant, isolated, don't step on each other. But the problem is there's a lack of ability to bring those governance capabilities into developer self-service, or they're not being thought about in tandem. And so what happens is the developer still has to go through a complex ServiceNow ticketing process because ultimately DevOps is required for implementing those governance capabilities. And this can take days to weeks. Whereas the ideal process should be that developer says, I need a namespace for my application. They use an internal developer portal, for example, something built in Backstage, to create a namespace with one click. And all the policies, for example, cost, security, resource quotas are embedded right in place. And so what we see here, and this process, of course, should take seconds, right? So what we see here is a requirement that developer self-service has to have governance capabilities required. And governance is meant to enable developer self-service. It's a yin and yang. And so when we talk about this yin and yang, essentially, for developers, when it comes to Kubernetes, they want to be able to consume and provision infrastructure, for example, cluster as a service, namespace as a service through a friendly interface, but they expect the resources to be always available and scalable, and they don't want to have to know the underlying infrastructure details like node groups, AMIs. That's not their concern. They want to be able to provision apps, test code changes. That's their ultimate goal. For platform engineers, for example, though, they need to deliver a shared services platform on Kubernetes for all internal users. And so they have to have the ability to impose company-specific requirements around add-ons, cost management, without impacting the developer experience. So let's talk about how this model can be achievable. We'll start off with looking at a Kubernetes Kubernetes platform architecture. So when we look at a Kubernetes platform architecture, we first see that it serves multiple internal stakeholders, not just developers, but SRE, security, support. FinOps is something that's been gaining a lot of trend. For example, how does a FinOps measure different costs for Kubernetes resources across different business units? A Kubernetes platform should be able to support the necessary front-end interface that makes your internal stakeholders successful. So whether that's Backstage, a UI for FinOps, a CLI, or a GitOps for SRE, ideally a robust Kubernetes platform should be able to support multiple interfaces and have the API contracts be the same. Then you have your backend, and your backend contains, of course, the infrastructure components, and of course is powering a great developer experience with catalogs, templates, docs. But of course, you have to also solve for the day two components. So you need SRE capabilities for troubleshooting, you need observability for logs, and you need to support the shared services platform side of things. So you need security and governance capabilities, for example, multi-tenancy, network policies, and of course, supporting different services around Kubernetes like registry and secrets management. So all of these are needed, but the key thing is start with what is thinnest viable based on your organizational needs and use a platform as product approach to measure success and know what capabilities you have and build it in a roadmap style. Now let's look at those 4 challenges that I was talking about earlier and talk about some design considerations on how we can solve for these. So the first one is cluster lifecycle without disrupting developer operations. Some of the key requirements here are, of course, being able to perform cluster lifecycle and upgrades without disrupting developer productivity, staying up to date on the latest Kubernetes versions, potentially even using custom AMIs when as necessary, for example, in EKS. Now, let's take a look at a potential design consideration with rolling upgrades and infra GitOps. So for example, let's say I have a 123 cluster spec in Git that represents a current cluster that I'm running. Rather than performing the upgrade on that specific cluster, which is done by a lot of platform teams today, can we consider another design? Let's use a rolling upgrade strategy in GitOps. Let's start by just tweaking the Kubernetes version and copying and pasting into a new cluster spec. So for example, now I have a 124 cluster spec, and you could have pre and post lifecycle hooks defined, for example, saying, hey, when a cluster is deployed, run a kube bench, run a deprecated API check to check for compliance, to check for those deprecated APIs. That can be as part of your GitOps automation as well. Next, what about the workloads that were deployed in this cluster? How do we make sure it gets deployed to the new one? Once this EKS cluster is run, the trigger is kicked off, etc. So the key thing is you can use a labeling strategy. So for example, let's say your workloads are marked with a prod label that is on this, and that's a cluster label that's being used on the 123 spec today. You could have some GitOps automations or some pipeline triggers to say, hey, when any cluster is deployed and it has a specific cluster label that matches this exact cluster label, make sure all workloads that are also referencing that label get deployed to the new cluster. And so now all the pods that were running in the 123, the same workload manifest and spec is deployed to the 124 cluster, maybe via Helm or any other operation. And then you can just delete the 123 cluster spec. And that in GitOps, and that will trigger, of course, the delete of the 123 cluster in your system. So notice how you can use infra GitOps for a rolling upgrade strategy. Now, as you consider GitOps as part of your strategy for cluster lifecycle, you should also think about whether you need Git to system sync or system to Git sync, especially if manual changes are made in the UI or CLI by, for example, your security team or other stakeholders. Do you want to write those changes back to Git so Git represents the source of truth in the platform? Or do you even need a two-way system sync? Those are requirements that should be gathered by platform engineering teams as they're building out the platform and GitOps capabilities. So that was a first example of how we can do cluster lifecycle and upgrades and think about not just app GitOps, but infra GitOps as a way to solve for some of these challenges. Now let's take a look at the second challenge of standardizing software add-ons. Imagine you're an IT professional at a large organization. I like to use this analogy. So typically, you have your VPN software, productivity software, antivirus. That IT defines that standardized set of software. And as a user, I can't modify that software and delete it. I'm not allowed to, right? And you want to be able to make sure as an IT organization, you can push that software out to different laptops that are running different OSs, whether it's Windows or Mac, doesn't matter. And then you want to be able to track that laptop fleet, have continuous audit, make fleet-wide updates, grant exceptions when needed, make sure nobody's doing something out of band, etc. So how do we solve for this? Because if you think about it, the same thing needs to be done for a cluster fleet as well. So when we talk about multi-cluster standardization and software add-on management, some of the key requirements, of course, are restricting which software add-ons are deployed to clusters. You want to be able to use software and versions that are vetted and tested by platform teams. Being able to update a cluster fleet at once to avoid any discrepancies, and being able to audit and catch any drift in software when tampered with. So the first thing is you want to use a blueprinting strategy. Store the declarative spec in Git. Maybe you can use a custom CRD and have basically a mapping of software add-ons to the latest versions that you want to be able to run. And you can also embed security and compliance policies that come with specific software. So for example, Cilium, if you wanted to use cluster-wide policies, you can, and you have all your clusters reference, for example, default, deny, ingress, you can have those policies embedded as part of your software add-on templates. Next, you want to be able to automate and standardize your add-on deployment processes. So you can use GitOps, and you can have multiple pipelines running in parallel to be able to deploy this software on multiple clusters. But even when you're running in hybrid cloud, for example, in AWS and VMware, you want to be able to call into one API in your platform, and then underneath the logic of how to install on AWS and VMware is taken care of by the API. So that way you're not maintaining multiple scripts, you're not having any discrepancies, etc. Finally, of course, audit everything. Always have a way to audit, because that is something that you need. Platform engineering teams or your security team will come to you and it's like, how do we demonstrate compliance, and how do we demonstrate this to our customers? And when you audit everything, you can measure things like which software is being deployed the most, which software is being touched or tampered with, and use those metrics to build drift detection and drift checkers. So if something is going out of band, you can include some automation to say, hey, don't allow this to happen. Don't allow Istio to be deployed from my clusters ever by a specific user, for example. And so this is a design consideration on how we can solve for multi-cluster standardization and software add-on management. Let's look at the challenge 3, establishing multi-tenant governance and connections to Kubernetes RBAC. Now, the key requirements for this are being able to tie organizational roles and responsibilities to Kubernetes RBAC. You have operators, you have developers, they should be able to do different things in Kubernetes, but those permissions can be different per environment. Maybe you have a dev cluster, maybe you have a prod cluster, and those may require different types of access and permissions for different types of users. And then you want to make sure isolation boundaries are maintained, and teams should not be able to step on each other. So I want to talk about one consideration around your identity providers and how you should map those to Kubernetes RBAC. So let's say you're running Okta, for example. What you want to do is, instead of having individual user mappings, use IDP groups. So you can have a developer groups, operators groups, and then you want to map those to Kubernetes RBAC and define access rules for different types of environments using labeling or other mechanisms. So for example, developers may have namespace read-only in prod, but they are able to create namespaces in the dev cluster. And operators have cluster admin privileges everywhere. And this can be done using role bindings in Kubernetes. Finally, you want to implement those RBAC controls. And of course, you want to have every API call and kubectl call to Kubernetes audited. And as you can see, those permissions are getting seen here. Now, the key thing is doing all this IDP integration, SSO can be a super challenge. And so what I recommend is looking at an open source project called Parallels, which is a way to enable this kind of secure Kubernetes access and to be able to integrate with your identity providers. Now, challenge 4 is building the developer experience. We've solved for a lot of the governance challenges. Finally, now we're talking about internal developer portals and the developer self-service. So the key requirements is that developers need a simple way to provision Kubernetes infra for their apps. They want to be able to use the standard Kubernetes interfaces such as kubectl, and they want to abstract away from infrastructure and not have to know the intricacies. The first step always to figure out is what type of Kubernetes access do you want to give? Do you want to give cluster as a service or namespace as a service or full-fledged environments as a service? And then figure out what is going to be the platform governance layer, what templates, what blueprints are these specific services going to use. So for example, when a namespace gets deployed via namespace as a service, it has the resource quotas, it has specific labels that are always necessary for the developer to be on that golden path. Then you can leverage Backstage or IDP software that point to dev-specific environments with all the info they need for app lifecycle. So in this example, you can see that we implemented at Raffle, they can download a secure kube config, they have access to basic metrics, etc. And so that's really important that the developer should be able to play in their specific background from a development point of view, from an app lifecycle point of view. They shouldn't have to worry about all different namespaces if they're just working within one namespace, for example. So just at the end, want to talk about, so Raffle actually, as a company, we power these 4 key enterprise needs for Kubernetes management. And we've done this with many customers across, Fintech, high tech, healthcare. And if you want to talk with us, feel free. And if you're dealing with a lot of these challenges, feel free to message us on the Slack, or feel free to message me on LinkedIn or via email. Thank you so much, and I hope you enjoyed this presentation.
Hi, my name is Karan and I'm working in Moss. Moss is one of the leading spend management platform in B2B segment based in Berlin. Today we are going to talk about data pipelines using Debezium and Kafka. Let's jump into it. In a microservice world where there are hundreds of microservices working behind a product, every microservice has its own database, which can be of different types like SQL, NoSQL, etc. as per need of their applications. From developers' perspective, services running their own databases and generating tons of data. While from the data science perspective, data is there in the data warehouse and analysis will be performed on top of it. Now the question is how to bring tons of data from multiple databases to data warehouse in real time. And one of the solutions is to create data pipelines using Debezium, which we are going to discuss in detail. So what are the data pipelines? Data pipelines are used to perform data integration. It is a process of bringing together data from multiple sources to provide a complete and accurate data set for business intelligence, data analysis, and other applications. There are multiple approaches to create data pipelines. Let's go and see one by one what are those. So first of all, one of the basic pipeline is called as ETL. ETL was created during a period of monolithic architecture, data warehouses, and relational databases. Batch processing was enough to satisfy data management requirements, and due to this, it is slow, time-consuming, and resource-intensive process. In a traditional ETL pipeline, you process data in batches from source database to a data warehouse in mainly 3 steps. First step is called as extract, the process of reading the data from different types of sources. Then the transform, converting the extracted data to a particular format to be stored in a data warehouse. Conversion also involved enriching the data using other data in the system. Then the third step is called as load. It is the process of writing the data to a data warehouse. Well, it looks simple enough. So what are the challenges in it? ETL performs data processing in batches, which can take hours or even days to finish, we cannot achieve data in real time, and that is one of the bottleneck of ETL process. They are designed for relational databases, needs own engines for performing data transformation, enriching, duplicate data cleaning, data integrity check. All this has to be performed by own engines. They are less flexible about type of source and targets. So when to use ETL? If you have a legacy infrastructure and a monolithic setup and batch processing adequate for your business needs, keep it simple and stick with your ETL setup. Let's see the second one. So there is an alternate process called as ELT, like extract, load, and transform, in which you first extract the data and then you immediately move it to a centralized data repository. After that, data is transformed as needed for downstream use. This method gets data in front of analysts much faster than ETL while simultaneously simplifying the architecture. It becomes possible due to cloud infrastructure and rise of cloud data warehouses, where the cloud's processing power and skill could be used to transform the data. But there are some challenges. First of all, be aware that you will be dumping raw data into data warehouse and you have to run transformation using cloud resources. So when to use it? If you find that your transformation process can't keep up with all the source data coming in, consider using ELT. Let's go to the third one. That is called as data pipeline with stream processing. Process often includes real-time data, such as web analytics data from a large e-commerce website, CRMs, databases, social and advertising platforms. In these cases, you cannot extract and transform data in a large batches, but instead need to perform ETL on data streams. Meaning, while client applications write data to the data source, you need to clean and transform it while it's in transit to the target data store. This can be achieved with Debezium and Kafka. So there are multiple components involved in it. First of all, the data source. It can be any database or storage bucket or any other source from which data need to be collected. As you can see in the picture itself, data source can be like S3 bucket or cloud storage, MySQL, Postgres, MongoDB, or Hadoop. Any kind of database can be a data source. Then the centralized component is Kafka Connect cluster. Kafka Connect is component of Kafka for streaming integration between Kafka and other systems like databases, cloud services, search indexes, key value stores, etc. So Kafka Connect cluster is having two subcomponents. One is source connector, another one is sync connector. Source connector is a Kafka Connect plugin which listens to source events and posts them to Kafka. And sync connector is another Kafka Connect plugin. It consumes messages from Kafka and sync data to destination. And we are also using Kafka here, which serves as a message broker for the pipeline. Kafka will handle the storage and transport of the change events captured by Debezium. Then at last, there are the data store. Data store are the destination, a data warehouse where our data will be stored and available for analysis. So data store can be anything like BigQuery or again S3 buckets, Elasticsearch, Redis, Prometheus, Hadoop, JDBC. So you can choose your source and destination as per your requirement and can create the streaming pipeline. So let's look at sample data pipeline. So here we are taking example of a sample data pipeline with most common scenario where data is coming from multiple databases and we need to collect and store it in Elasticsearch for further analysis. So here in the Kafka Connect cluster, it will be again source connectors will be there, sync connectors will be there. Source connectors will be one connector per database. And then since our destination is Elasticsearch, so we'll be using sync connector for Elasticsearch. Then as a source database, we are using Postgres. And you may have one or multiple databases depending on your setup. So let's go to each component one by one, how the processing will look like internally. So on the left hand side, there is database. which logical replication enabled. So technically, logical replication is a write-ahead log on disk, which holds all events that change the data of the Postgres database, all events like insert, updates, and deletes. Postgres replication is normally used to synchronize data between two Postgres instances, master and replica, but can also be used in cases like ours. PostgreSQL uses subscription model with publisher and subscriber for the implementation of logical replication. So the instance creates a publication, and one of the subscriber to the stream of the data changes simply by subscribing to the publication. When you commit a change, so what happens when logical replication is enabled? When you commit a change to the database, now it will not only write the data, it will also write a record in the so-called vol file. And vol file contains a list of recently made changes. Then there is one more component called as logical decoder, which uses an output plugin to convert Postgres write-ahead logs into the readable format and stream data changes to external consumers. So this is the functioning of a database. Let's go to next step. So here, now the Postgres instance is configured to produce a stream of data change events. Now we need to subscribe to it. And for this, we use a Kafka source connector called Debezium. The Debezium Postgres connector acts as a SQL client. When the connector receives changes, it transforms the events into Debezium events that include the log sequence numbers of the event. The Kafka Connect process asynchronously writes these change events in the same order in which they are generated to the appropriate Kafka topic. In summary, it takes 3 tasks: handle communication with Postgres, transform raw events into JSON, and publishes them to Kafka. Here you can see an example of a transformed JSON event. Debezium emits events in a rich format that contains all of the information about the captured data change. So you can see here in this JSON example that the type of operation is U. U means for update. Then the source metadata also will be there. The timestamp of the event processed by the connector, state of the row before and after. So the payload you can see before ID name and updated, and then after ID name and updated at the timestamp. And the Debezium calls this structure as envelope. So in this step, source connector is able to create the envelope from the CDC events. Let's go to the next one. So here, how this message looks like in Kafka. A Kafka event has a key and a payload. The key is derived from the primary key of the row, and the payload is what we saw on the previous slide. We can have additional Kafka configurations like retention period, ordering with a partition, etc. So it again depends upon what kind of a Kafka cluster you are having, and you can configure as per required. So here it is Kafka is just a store, and then the same message will flow to sync connector in the next step. The Kafka Elasticsearch sync connector is used to stream data into Elasticsearch. Now we need to transform the message from Debezium based envelope format to raw format so that other applications can understand and accept the data. For this, single message transformation SMT helps us. You can use SMT on the source connector to transform the message before it is written to Kafka, or you can also store the source connector's richer envelope form of the message in Kafka and use it SMT. Okay, so it's upon you. You want to put the SMT in the source connector or in the sync connector, but here we are using in the sync connector. Both options work, and it just depends. So you can do various operations with SMT, like extracting a field, inserting a field, masking the data, or converting the timestamp. So here we have inserted some of the fields from that record, like ID, name, updated it, and then we have inserted a field called tag with value as employee. We have also updated the event and updated at timestamp in different format. So all these transformations you can apply on the sync connector. Okay, and at the end our data is transformed and it's reached to our data store Elasticsearch and available to perform analysis. This whole process happens at near real time, and you will not see any delay for large traffic, as well as due to large traffic due to Kafka capabilities to work with huge volumes of data streams. So what are the advantages of this process? First of all, real-time data streaming. It handles all DML operations. Potential for supporting many sources and target data sources. Message transformations on the go. We don't have to put in our data store and then perform the transformation. It is highly scalable and fault tolerant due to the capabilities of Kafka. This is a glimpse of Kafka Connect universe. There are like hundreds of connectors available, which you can use as source and sync connectors and can flow the data through them. But there are also some downsides. So what are they? First of all, enabling CDC and DB take up additional space for the WAL files. If you obviously it has to maintain the WAL file, so it will need some space. CDC can only be enabled on the master server. It requires a primary key on every table. Schema change sync is only partially supported, and truncate operation not yet supported. So these are some of the downsides, but I would say those are best practices also. So if you're following the best practice, then the downsides will be omitted. So if you would like to give a try, then demo application is available at the repo with sample configuration. We have discussed here example with one source and sync connector, but you can play with different connectors as per your need. That's it for now. Thank you very much.
Hello everyone. I want to start with sharing one of my biggest frustrations with you. Imagine you're going to do a code review because a colleague of you opened a pull request. And it's actually already like the 5th pull request that you're going to review this week. You start doing the actual review and you find yourself pointing out some common coding guidelines or subtle bugs that you find in the code. Well, this is not really a problem, but if you have to point out the same common coding guidelines or subtle bugs in every PR that you reviewed this week, it actually gets pretty annoying because you might wonder, can we actually automate this? I'm wasting my time doing manual work while we should actually enforce these common coding guidelines over our code base. Well, my name is Rick Ossendrijver and today I'm going to show you how we can actually automate this. We're going to talk about automating away bugs with error-prone in practice. I'm a software engineer in the Java platform team at Picnic. Picnic is an online supermarket where you can order your groceries in our app, and we drive around in the electric vehicles that you see on the slide, and we deliver the groceries at your place. We are in the scale-up phase, and we serve over 3 million households spread over 3 different countries, namely the Netherlands, Germany, and France. And currently we are still heavily expanding. So let me give you an example of what I just talked about. So let's say the colleague opened a pull request and another colleague comes in and says, hey, I thought we agreed on using method A instead of using method B. Well, as you can see, there are some votes here on the comment, and this could easily trigger a whole new discussion about whether method A or method B is actually better, while in this case of checking whether the string is empty, they're equally good. So this is a stylistic issue, but having a discussion about this is okay, but having this discussion multiple times in various different PRs, pull requests, is actually becoming a problem because we don't want to waste our time on these things. So we need tooling to help us with enforcing these standards. Well, internally within Picnic, we have a few of these tools. For example, we use a formatter to format our code by using the Google Java format, which is fairly opinionated. And we also have some static analysis tools like Sonar Cloud and Checkstyle that point out bugs in or possible bugs in our code. But this is actually not enough because we want to do a bit more. The tools I just mentioned can only detect some bugs or violations, and they say, hey, here you have a violation of this rule. But we can do better than that because we can use ErrorProne. ErrorProne is an open source tool. It's a static analysis tool for Java, and it can not only find and detect bugs in your code, but it also can provide a suggested fix for the violation that it found. So it says, hey, you have an error here, and this is the way you can fix it. And if you run ErrorProne in patch mode, it can automatically apply the suggested fix in your source file, which means that if you enable ErrorProne with a specific ErrorProne check, it can run over your whole code base, find all violations, and automatically apply a patch in place, which means that your whole code base will automatically get fixed for this check that you enable. And that concept itself is a really powerful thing. So out of the box, Google provides over 500 error-prone checks. But there's one downside to these checks, because writing a check on your own can be quite complex. But the guys at Google thought about this, so they created another tool on top of error-prone. And that tool is called Refaster. So Refaster is a templating DSL that you can use to specify refactorings using templates. So you have before and after templates. And in a before template, you specify what code you want to match. And in the after template, you specify to what code you want to rewrite that. So let me show you an example to make things clear. Here we have a method that matches on any arbitrary string expression where equals is invoked. So on the left here, there is an example where you see equals, but if we apply this refaster rule in patch mode, it will automatically get rewritten to the content that is provided in the after template. So in this case, that is .isEmpty. So on the left again, we see that if we, what would be the result of applying the refaster rule on the .equals? Well, it will automatically get rewritten to .isEmpty. One of the things it can do is the following. So let's say that in your company you have a few colleagues who are really fan of making it clear when something is immutable or when something is mutable. So the colleague really wants you to add the final keyword everywhere, and in this case you can see that it clutters the code quite a bit. Well, what they did at Google, they created a var bug pattern that says, hey, we are actually going to flip the default. Instead of having to add final to every constant variable, we want to flip the default by saying, hey, we need to annotate non-constant variables with @var, which allows us to drop all the final keywords. Because on the right, the default is actually constant variables. Variables are immutable unless they have the @var annotation, which makes it really clear when something is mutable. And when something is immutable, you just can omit the final keyword because that's the default. Okay, so here, this is a clear example of how you can use ErrorProne to completely flip the default of your code base. Another thing that it can help with is API changes. So a fairly well-known one is the optional .get. At some point, the optional or else throw was introduced, but the most code bases already heavily used optionals and therefore also the .get operator. But it's actually recommended to use the or else throw instead of the get. Well, running this refaster rule over your code base will rewrite all occurrences from .get here to the or else throw. So let me tell you something about ErrorProne within Picnic. We have a lot of teams, and the code bases of these teams have one common parent. And in that parent, we have the common configuration of all our static analysis tools. So also the one for ErrorProne. This is important because we set up in our CI in such a way that all these checks are enforced over our whole code base by managing all these settings in our common parent. So we use a tool called Danger, and this is an example of an error that it can give. Well, what happens here? Well, someone writes some code and creates a pull request, and our CI will do a lot of checks and try to see if there are any errors. Well, in this case, the CI will run the patch script, and in the patch script, we run error prone in patch mode. This means that if there is a violation of one of the rules, there will be a change because the patch is applied in the actual source file. If there is a change, it means that the developer needs to take a look and see if this is a valid change and needs to actually apply the change, because it's really important that the developer stays in control of the changes that we are applying. We don't want to just commit this to master or main without having a developer check this out. But this is as a result of this setup, we get something that's really important. If we enable an error prone check and we have applied it over our code base at least once, then we can assume that this bug cannot occur in our code base ever again, because we fixed all occurrences, and Danger will make sure that this never occurs again. So let me give you an example of how you can actually start using this, because we have a roadmap for that. Let's say you have your normal code base, and this can be a common parent for all repositories, but let's say you have a repository and you start with enabling two things. Well, with adding two things, namely error prone and a way of easily setting it up that you can run error prone in patch mode. This is with some command line flags. In Maven, we use profiles for this. But after you set this up, you reach like level 1. This is the baseline. So you have error prone and you can run it in patch mode. You start with trying out a few of the error checks. Let's say you run error prone with a simple check that you know everyone within the team will actually like. Because what you need to do is you need to make other people enthusiastic about the changes that you are introducing as well. You can start with enabling all rules in one go. Well, there are over 500 error prone checks. This will give you the feeling that your whole code base is rewritten. This is too much risk and is too much to review by other team members. So you need to tread lightly. You need to think about which checks you want to enable and which you do not want to enable. So you start creating a pull request and you ask, hey, can you review this pull request? And you do this a few times until you are sure about the quality of some checks, and you start enabling them by default in your build. And you can repeat this process from level 2 to level 3 till the point where you enabled all error checks by default. But let me give you an example of how such a PR would look like, because it's actually pretty easy to review for others if you make all the pull requests very topical. So here you see that I checked out an open source repository and I applied the unnecessary final bug checker. What you see is that all unnecessary finals are removed, and it's actually a fairly simple PR to review because all the changes are really similar. And this is the idea if you create a PR just like this. And you can repeat this process quite a few times for all different bug patterns that are out there. So once you actually did that, you can go from level 1 to level 2 and so on. But let me give you some insights into how we actually did this within Picnic, because there are a lot of teams and we cannot simply enable all bug patterns in one go. So we had to also invest time and make sure that all the developers are on board with the changes that we are introducing as well. because we can say, hey, we enabled 10 new bug patterns, and this you just have to like it, and this is now the way in which we write our code. We need to ask developers about their opinion and see if they are agreeing with the changes and whether they think it's actually a clear and good improvement to do. Because otherwise they simply won't approve it, and they will have they will give a lot of pushback. So this to overcome this, we started opening pull requests in all our other teams' repositories ourselves, and we started to gather this feedback. So in total, we created a lot of pull requests in many different repositories, and here you see some of the changes, some number of these changes. And the thing is, you might ask now, okay, how does such a pull request look like? Well, we created pull requests that are separated in various commits, and in every commit we enabled some specific refoster rules or some specific error-prone checks to make it easy for others to actually review these changes. While they are very similar, it's still a lot to review and a lot to take in. So by making it topical, it's really a lot more easy to review these changes. And you can imagine that using this tactic for on a lot of teams, it will also generate quite a lot of feedback. And sometimes we got quite a lot of pushback on specific rules. Well, we wanted to, not everyone can agree on the same rules, but at least we needed to settle on a rule and make sure that everyone settled and that we could enforce it over our whole code base, because consistency is way more important than everyone agreeing on the same rule. So what we did to tackle this problem, we sometimes created Slack messages with a way of voting for all Java developers. So we said, okay, we have 3 ways of writing almost exactly the same code. Can you please indicate your preference by voting on one of the options? And based on this on these votes, we would actually roll these checks out over our whole code base and apply this as the new default in our code base. So this was the short version of this presentation. If you want to see a longer version, there is a YouTube link here. Thank you for your attention.
Throughout my career, I had the opportunity to witness developers and leaders get frustrated because of security-related processes that were designed in a non-scalable manner. I wanted to break this cycle by bringing practical examples on how platform engineering can play a key role on bringing security in your development lifecycle and helping you release hardened applications. Hi, my name is Martin Illuminati, and I'm a director of platform engineering. I'm going to be walking you through on how platform engineering can provide all the necessary means to apply security at scale while maintaining a positive developer experience throughout the development lifecycle. We're going to be going through 3 main phases in the SDLC. We're going to be going through the code, build and deploy, as well as the monitor and operate phase. Even though I'll be going through tools and configurations, what I'd like you to take out of this presentation is the potential positive impact that addition or changes in the existing process that you might have can have within the overall security posture of your company. I will be adding links to the code as well as tools that I will be mentioning in the description of the video. Additionally, for these changes to have a broader impact, you may want to understand what is the current threat landscape that drive your risk areas within your infrastructure and application. In our case, we're going to be looking into secure cloud configuration, container security, secure development, and dependency management, linked into Python, Docker, Terraform, and AWS. Something to keep in mind while we go through is that the cost of fixing a defect within each of the LCSD phases increases. So the earlier it gets detected, the bigger the savings are within remediation. And with that said, we're going to start with the code phase. And for that, we're going to be answering the question, how can platform engineering help the developers detect and correct vulnerabilities when coding with a positive developer experience? And that has to go both for the infrastructure and application related code. The first approach that we can have is to leverage IDs that developers use, being VS Code the most used. Using extensions is a simple and effective way to highlight potential mistakes and provide real-time feedback on how to get it corrected. And that is exactly what we want. We want to give developers a quick feedback loop that they can action it quickly and without too much interruption. And for that, we're going to be jumping on a quick demo around VS Code extensions. So we want to enable developers with a curated list of extensions that can help them find vulnerabilities in real time, so where they're developing. One way to accomplish this is to create an extensions.json file for VS Code with the list of recommended extensions that they might be able to use. If these extensions are not installed, what will happen is when they open the development environment, a pop-up will appear that says, do you want to install the recommended extensions for this repo? Which is say install, and we're going to accept all the recommended extensions, and that will start the process of installing them. You might already have a process for creating new projects, like Backstage. So this might just be one more file that Backstage would be creating within your new repository. In my example that I have, what I'm going to be doing, I'm just going to be creating a new Terraform file. Let's just name it PlatformCon. Yes. And I'm just going to paste a piece of code that I have, which is quite vulnerable, as you may see. But the idea is that in real time, you get the feedback of what are the vulnerabilities that might have been noticed within the code. So those are all highlighted. Also, which is something nice about this particular extension, is I can I'll let you just classify them, but this will be something that you will adjust depending on the language that you're using for development. The other approach that we can take is to provide pre-commit hooks. Pre-commit hooks are scripts that are automatically executed before a commit is made. This allows for automated checks. So when a developer runs git commit, the pre-commit hooks are executed, and if they run successfully, the code is actually committed. What's important to highlight is that we want to only have pre-commit hooks that are highly performant. That means that they execute quickly, and this is to avoid degrading the developer experience. In our case, we're going to be using it for a few tasks, so for secret detection and for software composition analysis. So pre-commit hooks can be described through a file as well, which is the pre-commit config.yaml file. This also allows us to provide this file with all the configuration when a new repository is created. In our case, we have one hook that is dedicated for detecting secrets, another one for detecting or doing a dependency check, and a third one for doing linting on YAML and Python. The list of available hooks is quite extensive, really, but if there's no one that matches the needs that you have, you can also create your own hooks, which is pretty simple and pretty straightforward. In our case, what I'm going to be doing, I have the Terraform file that I changed in the previous demo. I have an app that has been created, and I'm about to make a commit. The app itself has a config.yaml file, which has AWS secret and key right there in plain text. Note that the extension is just telling me, hey, you should not be doing this, but let's say that I will ignore this. I'll not take a look into the notification, so it's just committed anyways. And I also have a requirements.txt file, which is just the Python dependency. So just gonna make a commit in here. So commit test Commit hooks, and I'm gonna make a commit. So now all the pre-commit hooks are actually executing, and it's telling me, hey, the pre-commit hook detect secrets actually failed. So I'm gonna open the log, and I'm going to go through this. The first one, which was the detect secrets executed, is telling me, hey, you have AWS keys in there, so I'm not going to let you commit because of that. And the second hook, which is for dependency check, it scanned one package and found 5 vulnerabilities into it related with URL lib, which is an outdated version. This one is the one that I should be using, so I'm going to make those changes in here. And instead of having keys, referencing it. Save this. Make all the changes. And what I can also do is just, instead of running it through VS Code, I can just run it locally. In terms of validation, everything passed. Everything should pass now as well. Perfect. Moving into the build and deploy phase, we're going to be answering the question, how can platform engineering help developers avoid vulnerabilities to be deployed into production? So the code is now committed, it's pushed, it's sitting in a repository. It would be natural to expect that a CI pipeline will be actually executed against that code, which is exactly what we're going to be leveraging. As a quick refresh, these are the risk areas that we identified earlier. And these are the controls that can be put in place. So we have just checking the infrastructure as code, scanning the containers, doing SAST, and software composition analysis. Now, leveraging a pipeline to make validations has the advantage that we can run tasks that might be a bit more resource intensive that we couldn't run before because of the potential degradation of the developer experience. In general, if you identified several points of analysis in terms of the risk that was identified earlier, you might want to analyze them all where possible within the build phase, as this is the last step before the new code gets actually deployed into production. In our case, we're going to be committing code, which is going to be getting to GitHub, which is what I'm using, and then a series of build steps are going to be executed, and a set of validations are going to be done. So like any CI, GitHub let us have the different CI steps defined as code, in this case under the GitHub Workflows folder, the main YAML file. Just going to be a quick walkthrough on this. We have the container scanning step that we were talking about that has Trivy to make the scan itself, infrastructure as code scanning done through CFN now, software composition analysis that we're going to be using Gripe, in SAST that we're going to be doing with Bandit. Now, naturally, the deploy step will be dependent on the execution of all the other 4 different steps. Now, if we look into GitHub, this is the result of the last commit that we did. Logically, because we haven't scanned containers before in any of the other parallel steps, we found that we have an issue. We open it up. And it's just telling us that we're running an outdated version of Alpine in this case, which is true. And we have 8 high-risk vulnerabilities. So going back here, have my Docker file, which is being analyzed, and it's telling us that yes, it's an old version of it. So if I'm gonna be looking into this, the 18, so that's gonna be, this is gonna be the last version of it for Node. Perfect. Updated, no image. I'm just gonna make a quick commit. Perfect. Changes. And have the action running. Perfect. So we have the test that actually passed, and we have all the steps that were successfully executed with a deploy step that ran and went through. So this demo covered the basics on running security validations within a CI pipeline. This topic was covered much more in depth in Abiram's talk from 2022. So if you want to take a look to it, I'll put the link in the description. Now, moving into the monitor and operate phase, we're going to be answering the question, how can platform engineering help detect and remediate undetected or new vulnerabilities within production environments? So that we're in the monitor and operate phase. And for things like secure cloud configuration and secure development, it can get into a little bit of a gray area with your security operations team. However, there are a few things that platform engineering can still help. One of the examples that we went through is a library which a vulnerability was detected and it had to be updated. That's URL-lib 1.23. But that's just one outdated dependency within one repository. You usually have multiple dependencies within the same repository, and you also have multiple repositories that you have to maintain. So this can get really messy really quick. For that, the best solution is just to have automated dependency management. One of the tools out there that does this job really well, it's Renovate. Renovate does a few things. One, it checks all the dependencies in your project. It automatically creates new pull requests for all the dependencies that were detected to be outdated. And there's also the option of automatically merging the pull request based on conditions. So for example, if the version that was detected to be outdated, there's a new version and there's only minor changes, so there's no breaking change, it can automatically pull the request based on the conditions and do the merge. Just a little bit of how that will look like. So I have Renovate integrated in my project. It will, these are all the pull requests within the project. So it will create a number of pull requests for the different dependencies. As an example, this is one of the pull requests. It's just highlighting that it goes from 29.05 to 29.1. So the only thing that the developer will have to do is just to merge the pull request pretty much. So last but not least, we can just simply have automated scans being executed against our code. In my case, I'm just highlighting SonarQube as one of the options. The way that I'm achieving this is by having actions within GitHub that run recurrently towards my repository. It actually generates a pretty report that specifies what is the current state, how's the current state of the overall code, if it failed, compared with a quality gate. But what's important is that actually generates a notification that highlights if there's anything new within my repository, which this is something actionable and not just a long report. So as a quick recap, we went through the code phase where we learned about using IDE extensions and pre-commit hooks for security purposes. We also went through the build and deploy phases where we added validation steps within the pipeline before it gets deployed. And we also went through monitor and operating on how to automate the maintenance of our code. So thank you so much for listening and for attending PlatformCon. I hope you have learned something new that you can apply.
Efficiency and platform engineering. How do these terms intersect? We are talking a lot about efficiency, mainly now that we see several layoffs, restructurings, and a pessimistic market. Parallel to this, IDP, Internal Development Platform, and platform engineering has been gaining more relevance. Look at the growth of our community. So, why are we talking about platforms in the context of efficiency? Platforms can be a powerful solution to the problem of achieving greater efficiency. I am Juliano Martins, Senior Tech Manager at Mercado Libre. We built a platform called Fury, which supports almost 15,000 developers, an average of 10,000 daily deployments, more than 26,000 microservices and their entire infrastructure and services. With our platform, we are very efficient, whether in terms of costs, performance, or resilience. But it has not been an easy journey, and for that, I am here to share some lessons we've learned. I have to start with our journey. There is a lot of learning here. Mercado Libre was established in the late 90s. On the vertical axis of the graph is the number of Mercado Libre employees in IT. Our infrastructure was a monolith written in Java. However, as the company grew, we reached over 100 developers and started having problems keeping growing. For example, many developers changing the same source code, high coupling, and short deployments that generates outdates. In the mid-2000s, we adopted the microservices architecture to give developers greater autonomy and gain agility. This process was gradual. We started to break the monoliths into another monoliths, and so on until we reached an ideal size that could really be called microservices. Already thinking about divisions by business unit. Developers had absolute freedom. This gave us some troubles, but gave us a lot of agility, an excellent time to market. These troubles are related with governance that has been severely compromised. We were inefficient in terms of costs and security. Things depended on individual developer actions who had a high cognitive load. Total freedom has created some pitfalls for us. How do you keep scale this way? It was necessary to create something to catalog our services, provide centralized and controlled mechanisms for building and deploying applications, standardize development stacks, monitoring and apply security and costs policies, among other features. Do you realize I just described some characteristics of an IDP? Exactly 8 years ago, our platform was born to help put things in order. At that moment, we didn't ask some questions that we will do today. The concept of IDP was not widespread, and the term platform engineering was not even used. If we were to make the decision today, we would ask ourselves, should we build an IDP from scratch? Should we buy a complete IDP? Or should we purchase specific products and compose our IDP based on them? I don't have the answers, and I don't believe there is one answer for everyone. However, before asking myself these questions, I consider whether the moment is right to invest in an IDP or not. Many companies do not have a well-defined and established product. Despite that, they put a lot of effort into technical issues, which are important, sure, but they should have a good MVP of their product first. We will likely see these companies failing. Therefore, a tip is that there is no silver bullet. Understand the platform concepts and apply knowing how to distinguish the right moment for your company. don't fall in love with technology. As nerds, we have this natural tendency. But returning to our journey, the first features of our platform brought immediate gains. We focus on developing services or functionalities that will improve the user experience, that avoid repetitive work, or that standardize actions. Quick wins always help us to gain executive support, which is important to invest in a platform. It's not intelligent to start with a revolution and making something very big. Going by small parts, automating small things, and showing the benefits is the right way. If I were to buy or make something, I would first ask myself, where are the biggest opportunities here? What are the opportunities to seek efficiency, governance, and optimization, whether in terms of costs, security, or performance? And then I look for quick wins to address these opportunities. Having made that decision, which is very particular, we started discussing the transition. How was the transition to our platform, Fury, or at least to the services that we started to build at that time? It was gradual, as the platform met user requirements. In no way was the platform imposed, at least it should not be imposed. We established motivations for people to start managing their microservices on our platform. The benefits are tremendous. When developers understand that a platform leaves them free to solve problems that matter, reducing their cognitive load, the migration is natural, and the developers become platform evangelists. This platform acceptance process should be natural. The facts will help you with this. The benefits of a platform are already evident in the literature. Clearly, some trade-offs must be discussed on a case-by-case basis. Remember, there is no silver bullet. Okay, I talked a little bit about the process of building and implementing the platform. Now I want to talk about another problems. Today, almost 15,000 developers use our platform. But not everything is wonderful. We do have dilemmas and problems. There are many things to consider in the event horizon. The image is an Easter egg. If you identify us, tell me. I'd like to highlight 3 points that everyone should keep in mind. First, freedom. Total freedom or controlled freedom. This is an eternal trade-off that we have to deal with. A platform will abstract a lot of work from developers. It can also limit many choices like language or services they can use. What is the proper measure of abstraction or limits? There's no obvious answer. This is closely linked to the nature of your company. If you have a technology team, if your developers have DevOps knowledge, for example, it might even be a cultural issue you can decide whether to change. Here at Mercado Libre, we have something very close to no-ops. Developers care about the business, solving the problems, not scaling a server, for example. Business itself already provides enough challenge because regardless of using a platform, the concepts to create a good application are necessary. You must know how to create a resilient and a performative solution. Doesn't matter if you have a platform or not. You need to know 12 factors, solid, clean code, you need to know very well your language, etc. Developers must understand that they are in a bigger picture and that the company's interests are vital. So, controlled freedom helps ensure an excellent level of security compliance and efficiency. Second, support and training. You have to support and train people, as well as having good documentation. People reject the unknown by nature, survival instinct. Therefore, working hard on evangelization is crucial. Good support is also essential. For example, Imagine that a developer has a problem with the platform and manages to work around the problem using another solution. He will not use the platform. Here at Mercado Libre, we have a specific area for knowledge management and subject matter experts in addition to support. The area dedicated to knowledge management has created bootcamps that our junior developers participate in and thus start production much faster. We also have specific acceleration tracks and many knowledge exchange events. The subject matter experts support developers on various items, from using platform resources to larger problems, such as defining a good architecture for a solution, which service is best to use in a give problem, performance tuning, etc. Remember, you will need to invest in support and training if you don't want to see your platform die. 30. Your platform won't handle all cases. Developers are creative. You need to plan for what will be outside your platform, creating proxies, or using tools to monitor. What the platform cannot handle is necessary. Many problems for a business are very likely to arise in this scenario, which naturally has a lower level of governance. Depending on the nature of your platform, what can be out of it could be third-party solutions, innovation cases, or unsupported technologies, and so on. You need to understand the scenario in this universe and provide subsidies for the evolution of your platform. For example, recurring scenarios could be a good use case for your platform. At Mercado Libre, about 20% of our infrastructure is created outside our Fury platform. We call this the off-Fury world. Therefore, we created tools based on infrastructure as a code that allow us to have an excellent level of compliance and understand what the user is doing, avoiding leaks, drifts, or vulnerabilities, making sure, for example, that users are applying service packs, patches, etc. We also generate many metrics that allow us to make decisions. I told 3 points no, but one last message. I could have talked thousands of points here. You can read hundreds of books on how to build a new Google or a new Apple. But you won't make a new Google or Apple if you just follow everything. Why? Because there is a very big variable that a few are concerned about, that is building a strong culture and being faithful to it. So, the last tip is to consume all the content we share in this event, but do not forget the main thing, the culture. How you manage people and build teams. And for that, there is no magic formula. In this short time, we talked about our journey and some learnings. Having built our platform was an excellent decision that we made. Fury supported us to scaling efficient. In addition, it allowed developers to focus on building the best products. When we imagine that how our growth would have been like without a platform, it's clear that we achieved much greater efficiency because of it. Imagine more than 10,000 microservices, all their interactions, security issues, etc., being treated individually. We would not scale. With our platform, we apply security paths in minutes. We change policies or make decisions at scale with one click. The developer goes from zero to production in 4 steps, with zero cognitive load. But again, let's remember the cultural issue that I just mentioned earlier. Forget good technology without good culture. If you want to know more details about our platform, I invite everyone to watch a more complete video that we recorded for the Platform Engineering YouTube channel. Please be inspired by our ideas and create your own innovative solution. Thanks for watching.
Hi, I'm Nathan Harvey, a developer advocate with Dora and Google Cloud. Welcome to PlatformCon 2023. So, why are we here? Well, we use communication and automation to achieve velocity and reliability to make customers happy. Sometimes we call this DevOps. But, the same might be said about SRE, or SAFe and its agile counterparts, or even platform engineering. But maybe this is just the way modern companies work. Look, language is important, but outcomes are more important than labels, especially labels which try to draw crisp lines and have the potential to diminish collaboration or exclude others from the conversation. Instead of asking which label fits best, I prefer to revisit two more fundamental questions. Why is the business? And who are the customers? Our business is focused on delivering value to our customers. We build software for customers. The technology we're building creates and supports amazing customer experiences, bringing those customers joy. Happy customers want to keep using the products and services our company builds. And we built our platform for our customers. But wait, our customers actually don't care about the platform. After all, they aren't the ones using the platform. If the business of our business is happy customers, and those customers don't interact with the platform, what is the business of our platform? Why are we doing this? Well, look, we know that technology drives value and innovation, and our ability to deliver software quickly and reliably is at the heart of how customers interact with our business. We know this because it maps to our lived experiences. Think about it. How many of your own experiences with various brands have been enhanced by technology? So our platform must support our organization's ability to deliver software quickly and reliably. How do we know if it's working? Does it allow our teams to deliver software quickly and reliably? To know this, we'll need to measure the throughput and stability of those changes. Let's start off with some throughput metrics. How long does it take a team to get changes into production? And how frequently are they doing so? But measuring this and moving faster only helps if we can also do so reliably. So we need a way to measure stability as well. Things like how frequently are the changes we're pushing to production causing service degradation or requiring immediate attention from our teams? And if things fail, let's be honest, when things do fail, how long does it take for our systems and teams to restore service to our users? Our platform needs to provide the capabilities that help teams improve these 4 measures of software delivery performance. Research from Dora and our experience shows us that the top performing teams are delivering well across all 4 metrics without needing to trade off throughput and stability. Teams achieve this by continuously shipping small changes. So our platform is in the business of helping teams improve these 4 measures of software delivery performance. Those teams are made up of people. The people, the developers, are the ones that rely on our platform. So we need to build a platform to enable and support those developers. So what exactly drives developer productivity and a great developer experience? A recent article over on ACMQ shared insights from a team of researchers who dove into this question. What they found is that there are 3 key dimensions to great developer experience. First is flow, the mental state in which a person performing an activity is fully immersed in a feeling of energized focus, full involvement, and enjoyment. Platforms, therefore, should focus on creating optimal conditions for flow state. Next, cognitive load. which encompasses the amount of mental processing required for a developer to perform a task. Platform teams should provide easy-to-use, self-service tools to help developers streamline the steps from development all the way through to release. And finally, feedback. Faster feedback and learning about what is being built allows for more rapid course collection. Faster feedback and learning about what is being built allows for more rapid course correction. Fast feedback loops allow developers to complete their work quickly with minimal friction. Platforms should seek to shorten feedback loops by identifying areas where development tools can be accelerated. Think about build times as an example, or where human handoff processes can be improved. What does your change approval process look like? So if these are some of the ways that we can measure, how do we improve? How do we get better? Well, culture is one of the most important factors for driving sustainable success within your organization. Culture itself is the organization's pattern of response to the problems and opportunities it encounters. So what does good culture look like? Well, Dr. Ron Westrom, a sociologist, has researched culture in many different organizations and has published this topology of organizational cultures. Organization with performance-oriented or generative culture tends to perform better. These organizations are known for having high levels of cooperation. They use failure as an opportunity to learn, and they focus on things like implementing novel, new ideas. Culture is fluid, it's multifaceted, and is always in flux, making it something that organizations can change. But how do you change culture? Well, John Shook, another researcher, shares that an effective way to change culture is to change the way that people work. The way to change culture is not first to change how people think, but instead start by changing how people behave, what they do. So maybe the role of our platform is nothing short of changing the culture of our entire organization. No pressure. And don't worry, with platform engineering, we will get it right this time. But let's be honest, how often have you said that or heard that sentiment before? And how often have you believed it or seen it come to fruition? The truth is, we are unlikely to get anything right from the beginning. Admitting and embracing this fact is important. Changing culture, tooling, behavior, and incentives, it's hard. It's going to take alignment at all levels. It's going to take trial and error, and it's going to take us time. But here's the good news. It doesn't have to happen all at once. In fact, we will probably fail if we try. Trying to boil the ocean, trying to make changes organization-wide, trying to make a solid platform, a foundation that is unchanging, that everything gets built upon, that simply isn't going to work. We will get better through meaningful improvements that come as a result of continuous improvement. Experimentation with a mix of victories and failures. In both scenarios, teams can take meaningful action as a result of the lessons learned. So let's boil it all down. The role of our platform is to enable a happy team with less cognitive load, more time spent in a flow state, and receiving faster and more high-fidelity feedback. This will lead to improving our overall software delivery performance, as measured by those 4 software delivery metrics, which in turn leads to happy customers and improved organizational performance. Achieving this requires continuously learning and improving our platforms, improving the way our teams work, and improving our processes across a number of different facets. But remember, it is the culture that's driving us. To support a generative culture, Improvement comes from empathy, from cooperation. Go and see, how are others in your organization building, delivering, and operating software? What are the friction or pain points? What's slowing them down or causing unreliable systems? These observations will help you inform the next steps you take with your own platform. Remember, you cannot succeed on your own. You must build connections within your organization and across the global community of practitioners driving advances in platforms everywhere. The connections you're making here at PlatformCon can support you on your journey. Google Cloud's innovator community is another great resource for you to share your experiences and learn from one another. I invite you to join Google Cloud Innovators today. Thank you so much for joining me here today at PlatformCon 2023, and I'll see you later in the Slack for live Q&A.